Welcome to our program. Today we have two of the nation's leading astronomers with us to debate the topic, does the evidence from astronomy support an old Earth view or a young Earth view of the universe? Both men hold PhDs in astronomy. Each expert will share a one-hour presentation of the scientific evidence from astronomy to support their view of whether the universe began thousands of years ago or billions of years ago. This material will be enhanced by a 30-minute presentation of how the astronomical evidence correlates with their interpretation of biblical creation. These presentations will then be sent to approximately 20 astronomers with PhDs, asking for a written opinion of the accuracy of each presentation in light of their understanding of current-day astronomy. Once those 20 astronomers have expressed their opinions, they will be gathered into one document, which they will sign. Their findings will then be given to our two debaters, but also to you in the television audience. Dr. Faulkner will present the case for the young Earth view of creation based on his years of research as a professor of both astronomy and physics, incorporating a thorough presentation of how this information integrates with the biblical creation account. The second presentation will be made by Dr. Hugh Ross, who received his PhD in astronomy from the University of Toronto and has done postdoctoral work at Caltech on quasars. He will be presenting astronomical data that the universe began approximately 13.7 billion years ago, referred to as the old Earth view, and how this view fits the biblical creation account. Later on, I will introduce him further before he speaks. As we begin, we all agree that we are here to model how Christians can discuss this issue, even when we disagree, in humility and Christian respect. The age of the earth is not and should not be a test for orthodoxy. On the other hand, we cannot say that the book of Genesis doesn't matter. We all believe it is crucial, and it does matter in presenting a factual case for Christianity. That said, join me as we listen to Dr. Danny Faulkner.
John, thank you for hosting us here today. And Hugh, thank you for suggesting that we get together and do this. I'm really looking forward to our interaction today. I want to talk about the age of creation. That's a very fair question for a scientist, but particularly for the Christian who's very aware of science and what science has been saying for a number of decades now about the age of the world. And the big question is, the age of creation, is it thousands or is it billions of years old? We recent creationists seem to think thousands, and most other scientists seem to think billions of years old. We're kind of swimming upstream, I'm aware of that. And we've been asked today to present some astronomical evidences. Now, recent creationists over the years have developed a number of evidences for recent origin, many of those dealing with the Earth, and I decided not to talk about those. And so from the ones that have been given to astronomical topics, I selected out a few that I'm very comfortable with and I think have some good arguments. And in each one of them, I want to anticipate what kind of objection somebody of an old Earth persuasion or old universe persuasion could have, and try to answer some of those, anticipate those, and handle those. Before I begin, I'd like to talk about a few biblical issues, also a few broad philosophical and scientific issues, because I know I'm swimming upstream here, because I'm sure many people in the audience and the scientists want evaluating my talk probably are starting from a position different from mine, and I've got a fair amount of convincing to do. I've been studying these topics for 30 years, pretty seriously, more than 30 years, and I've slowly come to the position that your conclusion on this has very little to do with the actual physical data. And I think that's very interesting. I think when I first started off, I wanted to talk about data, but as I've gotten older and a little wiser, I hope, I've learned a few things along the way. Let me give you an example of all this. At the end of the 19th century, I like history, so I like to integrate that with these topics. End of the 19th century, biologists and geologists were pretty well convinced that the Earth, at least, was at least 100 million years old. Of course, that figure is way too low compared to the day's estimate of 4.5 billion. But again, into the 19th century, 100 million years they were shooting for. And Lord Kelvin, one of the greatest scientists of all time, but particularly of the 19th century, the latter part of the 19th century, he gave forth several arguments, two in particular dealing with what they thought then was the origin of the sun's energy and, of course, the heat of the earth. And both of these had convergent upper limits of about 30 million years. He very convincingly at the time showed that the age of the earth and the age of the sun could be no more than 30 million years. It could be younger than that, but it could not be any older than that, which is quite at variance with that 100 million year figure most biologists and geologists wanted at the time, a factor of 3 or more greater than that. And so I have to ask the question, why did people persist in believing that the world was much older than the very quantitative upper limit that Lord Kelvin had established? And I think the problem is that belief then they had was not because of the evidence, but was actually in spite of the best evidence. Again, 1890, if you had asked scientists for evidence about the age of the earth, age of the sun, they would have had to stick with Kelvin's figure, yet many scientists had already insisted the world was far older than that. So I have to ask the question today. People offer evidences for 4.5 billion years old of Earth and solar system, 13.7 billion years for the age of the universe. And one thing we need to be careful of is how rapidly those numbers can change. If they're wrong, if they're right today, then why are they going to be wrong in the future? And also, again, what's driving that? What kind of assumptions are going into this sort of thing? And what happened at the end of the 19th century is that many of those geologists and biologists firmly believed in evolution, biological evolution and geological evolution. And they estimated at that time that it took at least 100 million years to account for the geological structures and, I guess, the biological diversity we saw on the planet at the time to give that age. Again, they believe that because of their assumption of evolution. And I don't think a lot has changed over the past century. I think what really drives belief in old Earth and old universe more than anything else is the assumption of evolution. And if one truly believes in creation, then that doesn't really require a lot of time. Now, there's a wide range of beliefs about creation. You can have people such as myself who are what we call special or recent creationists. Hugh believes in progressive creation. You have people who are theistic evolutionists. They are a form of creationists, but very confused, I might think. But that's my own opinion on this point. But we have a wide range of that. But creation itself, keep this in mind, creation itself does not require great time at all. It can take that much time. If the Lord decided to create the world over millions or billions of years, He could have done that. But He's not constrained by that. But it's inconceivable to just about everyone that evolution could take place very rapidly. So while evolution requires great time, creation does not. So you have some flexibility within a creation paradigm, it would seem to me. And we are talking about the miraculous. We have 6 days of creation. We have a miraculous God who deals with miracles from time to time. He ordains certain physical laws to operate for the most part, but He can intervene in the world as He wishes. And I think at the very beginning, creation by its very nature was a miraculous sort of thing. Furthermore, I believe in His holy word, the Bible. God has given us information suggesting that the timing was very short. Not only can God do it that quickly, I think He has told us in His Word that indeed He did do it that quickly. And for the Christian, I think there are two approaches one can take. One is to start with the Bible. That's one of the 5 basic principles of the Reformation, Protestant Reformation. So, sola scriptura, Scripture alone, the Bible alone can lead you to important truths that we have. And that's a presuppositional sort of thing. I start with the Bible being authoritative, being trustworthy. It speaks about matters spiritually, but also other matters. It speaks with authority, and it's also true at the same time. On the other hand, one can start with science, and I think I see many people, Christians, doing that. I think they would disagree with that assessment, but I think they're actually starting with science quite a bit. And then coming back to the Bible. I prefer to start with the Bible and then work towards history, science, philosophy, all sorts of things. Don't start from psychology and philosophy and science and go to the Bible, but start from the Bible first and then interpret these other subjects that people have made up over the years in light of what the Scripture actually says. And I think part of the confusion we have is that many people think that science, modern science, has established that the world is the Earth is 4.5 billion years old, and the universe is 13.7 billion years old. And so sometimes we recent creationists are accused of disbelieving the great age. Well, that's just like disbelieving gravity or general relativity or any number of other things that have been well established. And that really confuses the issue, because there are two types of science we have today. One we call operational science, and that's a type of science that can be tested in the here and now. If I want to test a theory of gravity, I can go into a lab, I can set up an experiment, and I can keep messing with that experiment, changing what I'm doing with the experiment until I can get the results that I'm looking for and see if it disagrees or agrees with the predictions I've made for my theory or for my hypothesis. It works right now. I can continue working the way the world works right now. But the other type of science is what we call a historical science. It's dealing with a past process. You can use scientific principles to try to guess what kind of processes may have happened in the past. You're using scientific principles to try to deduce what possible physical processes could have occurred in the past. Notice now we're talking about possibilities. Is it really possible to then go back and do experiments in the here and now on these things? And the answer is no, because we're testing a past event that's no longer taking place. Forensic science is that sort of thing. You try to reconstruct a crime scene, but you can't do it completely because the crime scene has been altered with time. A lot of times things are destroyed in the commission of the crime itself. So we can't really have the same rules of evidence, the same rules of discovery that we have in operational science. And I think if you look through science with that approach, with that attitude, you will see that science is really at its best when it's working in the here and now with operational science, and far from its best when it's dealing with historical science, because now we're dealing with possibilities, not with high probabilities in many cases. And so I object to this comparison to saying that I disbelieve gravity because I disbelieve the world is billions of years old. And many times people, I think starting with science, will argue that the Bible is not a science book. And I may shock some people here today by telling you I agree, it's not a science book. That's not its purpose. I do believe when it deals with things that may touch upon some of these scientific principles, it does speak with authority, and it is true. But you know what? The Bible is a history book. Think about that. The first 5 books of the New Testament are history books. The Gospels and the book of the Acts of the Apostles. That's probably close to half of the total text of the New Testament. But you go back to the Old Testament, the first 5 books, the Pentateuch, and then the next 12 books collectively, the next 12 books giving you a total of 17 books. They're historical, all historical documents. The 17 prophets, prophetic books, also contain a fair amount of history in them. Jeremiah talks about different kings and things that happened, different reigns through all of that. When you go to the remaining 5 books, the poetic books, you find the book of Job is a historical account. It's told in a poetic way, but it is a real account of a real person and real events that happened to him. So it's my position that fully 35 of the 39 books of the Old Testament are historical books. So I think we can take the approach that the Bible is historically accurate, and we are talking about origins at least, we're talking about historical science. So if you disbelieve what the Bible's telling us about the history of the origin of the world, then it really undermines the authority of the Word of God when it talks about the history. And I think we ought to pause and consider the implications of that statement I just made. So what is my conclusion about the length and the age of the creation? Well, I think the creation week was literally 6 normal days. People say 24-hour days. I don't know if they're exactly 24-hour, but pretty close, okay, to a good approximation, 24-hour days. There are a number of contextual reasons for that. Don't want to take the time to do that today because that's not the purpose of our discussion. Hugh, you and I have discussed this on other occasions as well, what the creation days mean, the use of the words there and the verbiage. We have disagreements on that, but I've come to the conclusion a long time ago that the very best interpretation, I think, coming from the passage itself, is that the days are a normal 6 days. And then we have in Genesis, but elsewhere in the Scripture, a number of chronologies. And we can add those things together and we get roughly 6,000 years. Usher got close to 6,000 years, but he wasn't the only one. At the time Usher did his work 350 years ago, it was a rage in Europe. Everybody was doing that. And they all got something close to 6,000 years, give or take a few decades here and there. So I've come to the conclusion that the Bible itself offers 6,000 years of history. We may say, well, the chronologies were never meant to be added together. Well, that may be true, but why were those ages given to us, those dates and lengths of rulers and lengths of lifetimes given there if they were not intended for such a calculation? So I think if you look at the Bible as a historical document, and I think we must, then it starts to impinge upon what modern science has claimed about the earth. And so I think the biblical text itself argues for 6 days of creation and, again, 6,000 years ago. So I have to then interpret the world around me in terms of that paradigm. And my job as an astronomer has been to do that, is to look at the world. And I look at the world differently than most astronomers. I'll admit that right up front, because where other people see billions of years and must interpret billions of years, I don't. I see thousands of years and sometimes only days, and I want to interpret that. And it's an extremely liberating thing. And it's also very exciting because it gives me a whole new way of looking at the world, and it's the possibilities then really open up you would never see otherwise. Okay, we want to talk about dating methods, and certain assumptions must be made, and I've really kind of distilled this down to 3 assumptions. I have here on the podium here up with me a glass that, as you can see, is about half filled with water, and I could give people, I do this with my students quite frequently, ask them the question, could you give me some estimate of how long this glass of water has been sitting over here? Well, you might think, throw your hands up and say, well, that's impossible. But when you think about it, how does a glass of water change over time? And after a few moments, most people realize, well, the most obvious change would be evaporation. The water level, if you watched it over a period of time, would slowly fall over all of this. So you must make some sort of assumption to start with, initial condition assumptions. You must start with the assumption of where the water was when it began. Let's suppose most people would fill a glass of water up to, say, right there. I would. That's what I normally do. You could go clear to the top, but that's pretty impractical. You're going to spill it pretty easily. There's a chance that it could have been filled up to here to start with, too, but I usually don't do that. I usually go about right there. I could look very carefully and see there's a water line. Maybe when the water was filled up a few days ago, it was up to that point. So you make some sort of assumption. What happens if I assume the water level was here and it really started off right here? Then I'm going to get an overestimate, aren't I? But if I assume it was filled up nearly to the top, I'm going to get an upper limit to the age of the glass of water, how long the glass of water has been sitting here. Keep that in mind. It's going to be an upper limit that I'm going to get. And then we let the thing go for a while and see what happens, and we get this rate of change that takes place. Evaporation occurs. You could make a little mark here and come back tomorrow and see how much it's lowered again, and that would give you an actual measurement of the rate. But you know, there's some pretty smart people out there who have actually worked out relative humidity charts and tables dealing with temperature and any wind currents, and you could even calculate that if you wanted to. So you get a rate of change coming out of that. And again, we have to know what that rate of change is in any aging dating process. And then somebody can come by and take a drink of water out of the glass, and before your very eyes, if somebody walked in now into the room here and they hadn't seen me take that drink of water, they would assume that this much drop in water occurred gradually over evaporation. So we have to also assume there have been no bulk changes. Bulk changes can be a rapid loss of water in this case, or it could be the additional addition of water to this. And it turns out most dating methods require making assumptions along these lines, or assumptions very similar to these. And so when I share some of these dating methods with you, I want to talk a little bit about the assumptions that go into it and how those assumptions might be correct, might be incorrect. We might be very doubtful about some of those, but all of those assumptions are coming into the mix. A few more important considerations, as already pointed out. In the case of this water, if you assume the glass was up almost to the top, but it really wasn't, then what you're going to get is an upper limit to the age. That's what Lord Kelvin did with the age of the earth and the age of the sun. Using the best science of the latter 19th century, he found an upper limit. He was convinced that the sun and the moon could at most be that old, but could be no older than that. Generally, age estimations will give us a range, but many times an upper limit, sometimes a lower limit, but there's always a limit that you can put into that. And I often think that the precision is overestimated. See, radiometric dating of rocks, I think, is grossly overestimated. I remember back, I was in high school at the time when they got the first rocks from the Apollo 11. And I was looking at a write-up, I think in Sky and Telescope magazine, about 6-8 months later, about some of the initial age measurements from rocks brought back from the moon. And the age measurements were all over the place. One rock was 20 billion years old, one was 16 billion years old, and nobody believed those dates, so they threw them out. They found some way to discount them. Interestingly enough, they found a number of rocks that had the 4.2 billion years that they expected, and they kept those ages. They found some far younger, and they found a reason or a way to argue those away. And I think a lot of times in reports, you see PBS specials, you read textbooks on this, they don't tell you a lot of the nitty-gritties. It's not quite the exact science that many people would have us believe it would be. So some of the things I'm going to share with you today won't have the kind of precision that scientists are generally used to seeing, because I think the precision is grossly overrated. I'm looking for broad limits many times on these things. And ultimately, again, we're considering two possibilities. My position is the Earth is 6,000 years old, and Hugh is presenting 4.6 billion years old. We have two extreme positions on that. And when it comes to the universe, I'm thinking 6,000, and Hugh is thinking 13.7 billion years old. So I have to ask the question, if I present evidence that puts an upper limit that's greater than 6,000 years, but less than, say, 14.6 or less than 13.7, it would seem to eliminate one of those two possibilities. It doesn't automatically mean that the Earth is 6,000 years old, but again, the consistency there. Does my date fall within the limit you have, or does the conventional date that Hugh will be presenting fall within that limit? And that's the approach I'll be taking. Again, not as precise as many times we're used to seeing in science, but I think the precision many times is grossly overestimated. And I will also attempt to anticipate, as I said, some of the objections to the things that I will present today, and then counter those, or give my reasons why I think we can discount that. And what I'm concerned with is many of the reactions or responses to what I'll present today actually kind of bring in a whole new definition of science. And that greatly concerns me, because I see that happening more and more today. You know, I grew up with this definition. The science was a study of the natural world using the five senses. If you can see it, smell it, taste it, touch it, or hear it, then it's science. If you can't do any of those things, none of the five senses, then you can't do those things. I should say it's the study of the natural or physical world. If it's not natural or physical, then you really can't study it either. But that's the definition of science I grew up with, the study of the natural world using the five senses. But I've seen this subtle change take place in my lifetime. Now people are describing science or defining science to be the search for natural explanations. Now, that may seem like the same definition, but it's very different, because it says nothing about the methodology of using the five senses. It says everything about the assertion of naturalism. It's a metaphysical assertion that naturalism is what exists. And see, I take the metaphysical assumption that God exists. There's a spiritual world, and I think the Christian's going to have to take that assumption. But the way this new definition of science works, it's a denial of anything non-material, non-physical. And many of the explanations that I will try to respond to, the responses to what I will offer, I'll point out that they're simply assertions of a naturalistic sort of answer. And no evidence will be provided with those typically. They'll say, well, this is what likely happened in the past to explain this problem you're putting up here for an old Earth or an old universe. And all then they have to do is offer an explanation. It has to be plausible. It could have happened that way, but they're not required to offer any evidence that this takes place. Now, this is very different the way science has always worked. In the past, you have a hypothesis, you work up an experiment, you make predictions, you then collect your data or do the experiment, and then you see how well the data agree with your predictions. But now you don't even have to have data, don't have to have evidence. You simply say, aha, this must have happened in the past, so therefore that is what happened in the past. And again, no data being offered, and that's a radically different way of doing science. And I'm just really perturbed when I see scientists seriously offer that as a legitimate scientific explanation. Let me begin talking about some of the evidences that we creationists have used. Here we have a photograph of a comet. We have the tail going from the lower left to the upper right. There's the sun is off the picture quite a bit to the lower left. And inside of that big glow in the lower left of the photograph, there is a tiny nucleus a few miles across made up of ice of various types, not just water ice, but also frozen CO2, that's dry ice, and methane and so forth, and microscopic dust particles for the most part. As the nucleus goes very close to the sun, once every orbit, they have very long elliptical orbits. As they come very close, the heat, the light of the sun evaporates or sublimes a lot of that gas. It then begins to expand into a large coma that you see there. And then solar wind and radiation push the dust and gas particles away from the sun. So as astronomers would know, but many people watching the video may not know, the tail always points away from the sun. It doesn't matter which direction the comet is going. So you've got that small nucleus. The nucleus does not show up in this photograph because it's a longer exposure that completely blocked out the nucleus from showing up in this particular photograph. Now, as the nucleus is only a few miles across, we found that the nuclei in recent years we've discovered particularly are very porous. There's not a whole lot of mass there. The thing is very spongy with a lot of open spaces in between anyway, barely held together. And as the nucleus comes around, it loses a lot of material, comes back, goes far away from the sun to aphelion, comes back, loses more material, and does this several times. And each time it comes around, it loses a significant amount of material. That means then that from this evaporation of those gases and dislodging of the dust particles, the comet can't last very long. In fact, over the centuries, we've seen several comets that have faded tremendously, some that have entirely stopped glowing appreciably at all. So we've seen comets break up and die before our very eyes. And if you crank the numbers on what kind of orbit it has, how many paths it can take, you find out in some cases the maximum lifetime of these comets is only thousands of years. For a really long period comet, maybe millions of years. But an individual comet cannot last very long just from this evaporation alone. But there are other ways that we can lose comets. One, through collisions. We didn't really appreciate that until back in 1994. I have a photograph here of Jupiter you've probably seen before with remnants of Shoemaker-Levy 9, a small comet that was shredded apart a couple of years before, came back, hit Jupiter, and one by one hit into Jupiter, leaving these big black dots. That comet no longer exists. It was destroyed by its encounter in the inner solar system. And then thirdly, comets can be lost due to ejection from the solar system. As these comets come into the inner solar system, they pass by some of the larger planets, particularly Jupiter, and as they do, they can have their orbits shortened or they can have their orbits lengthened by the gravitational perturbations that take place. And we have observed a number of comets being ejected from the solar system. So collisions and ejection from the solar system represent catastrophic losses of those comets, and the evaporation, a more gradual but still a very short-lived sort of thing. And so people run the numbers. This goes way back before 1950, actually. First half of the 20th century, people began to run the numbers pretty well. And they realized that this puts a very severe limit on the age of the comets as they orbit around the sun. The solar system and the comets would have to be far younger than 4.6 gigayears, or 4.6 billion years. In fact, the upper limit, I've run the numbers on this, turns out to be on the order of maybe 100 million at the most. If the solar system began with these comets orbiting, then after 100 million years, there would be no comets left at all for us to see. So why do we still have comets in a 4.5 billion year old solar system if it's indeed that old? So I think this is quite a dilemma. Again, it's been recognized as a dilemma because as early as 1950, two responses came forward. So this is a problem that astronomers knew existed in the 1930s, 40s, and in 1950, two different responses of 50-51. One is by Jan Oort, a Dutch astronomer. He suggested that there was what we call the comet cloud, or now the Oort comet cloud. It was the source of long-period comets. out tens of thousands of astronomical units, or tens or thousands of times the distance of the Earth from the Sun, you have these comet nuclei orbiting very far out. So far out they remain cold. They don't lose their gases. They sit there in a deep freeze, more or less. Nearby a star or a gas cloud or some sort of gravitational tide can rob these nuclei of their orbital energy, and they can then be caused to fall into the inner solar system, where we see them for the first time, then a second time. So the idea is, as comets die, these long period comets die, then they are replaced by new-born comets coming in out of the Oort cloud, and at the same rate that they're being destroyed. So we're in a steady state rather than a one-shot effect. The other one was by Gerard Kuiper, I think a Dutch-born but a U.S. Astronomer, who suggested the origin of the short-period comets came from what's called the Kuiper belt. It's a collection of comets just beyond the orbit of Neptune. You have the planets basically in the same plane around the Sun, and just beyond the orbit of Neptune, a large belt, sort of like a bagel or a donut shape sort of distribution of comet nuclei. And largely through interactions with the outer planets, you can cause them to lose energy and fall into the inner solar system. And since they're coming from a much closer distance, you get a much shorter period, typically a couple of centuries or less. The orbits are very different. The short period comets orbit the Sun in the same direction the planets do, and at a fairly low orbital inclination. The long period comets about half one direction, other half the other direction, and they can have almost any inclination. So the orbits of the two types of comets are very different from one another. Now, what do I have to say about this response? Well, I have a great quote here I've used for years about the Oort cloud. It says, "Many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there is not yet a shred of direct evidence for its existence." Notice there, no direct evidence. I would even drop the word direct and just simply say no evidence for it exists. We've never seen anything in the Oort cloud. We've never heard it, never smelled it, never tasted it, never touched it. It's this thing they've made up. Remember that assertion of naturalism I pointed out, of plausibility? No evidence necessary. You simply suggest that this thing exists, but you're not required to provide any evidence. That's not the way science has traditionally worked. So I have to ask the question, is this science? And by the original definition, it isn't. You've offered no data, offered no evidence. It doesn't mean it's not true. It doesn't mean it is true. It simply means that you've offered this without following the traditional rules of science. If you want to change the rules of science, that's a different question, but I think people are wanting to do that. By the way, I should identify the author of this quote. It's the late Carl Sagan, who wrote this in his book on comets from 1986. I could have said this quote, but he did. And even though it's 2 decades old, nothing's changed on that front, not likely to change. So I stand behind this quote, and I think it very well illustrates the fact, my objection to the response. Again, I'm not saying, I can't prove that the Oort cloud doesn't exist, but it's imperative upon the people who want the Oort cloud to be there to offer some sort of evidence. So this is a philosophical response. It's not a scientific response. What about the Kuiper belt? Well, used to I could say we haven't found the Kuiper belt, but then 15 years ago, people began discovering all these particles asteroids, I should say, beyond the orbit of Neptune, and some people call these trans-Neptunian objects, TNOs for short, and some people call them Kuiper belt objects, KBOs. So if you think it's the Kuiper belt, you say KBO. If you're doubtful, you say TNO. I think TNO is more honest and also more straightforward because these are orbiting beyond the orbit of Neptune, so TNO fits. It's a good name for them. A few hundred of these now found. And so most people, when they started finding these, they assume, well, these must be the Kuiper belt objects. Several problems I can see right up front. First of all, these things are very large for the most part. They found some smaller ones, but some of these things are hundreds of miles across, which is many orders of magnitude larger than any comet nucleus we have ever seen. So if these are really comet nuclei, why have we never seen one this big? The largest comet nucleus ever seen was out of Hale-Bopp a decade ago, and it was estimated about 40 kilometers across. And the a fair number of these objects, the trans-Neptunian objects, many of them are more than 10 times that size. Volume-wise, they're 1,000 times larger. So these, and bigger than that even. So these are truly gargantuan comet nuclei, if indeed that's what they are. But there are other problems. We have the density of at least one TNO, or KBO if you want to call them, because now Pluto is understood to be one of the larger members of this group. We've had a density for Pluto for going on 30 years from when we first discovered that Pluto had a satellite back in 1979. And that density is pretty well known, at least to two significant figures. It's 2 grams per cubic centimeter. Now that's interesting because ice is roughly 1, maybe a little less than 1 gram per cubic centimeter. And so this density is consistent with about a 50-50 mixture of ice and rock, assuming there's no porosity built in, but I think that's probably not the case with Pluto anyway. Incidentally, we have a spectrum of at least one other TNO, maybe more now, and they match it matches the spectrum of Pluto very well. So it tells me the composition of some of these other objects out there in this asteroid belt match Pluto's composition very well as well. Well, what's the big point about the density? Well, we have a good idea of what the density of a comet ought to be, what the composition of a comet is. We have some indirect measurements of densities, but of comet nuclei. The problem is they're very porous, very spongy, with a lot of empty space in between them. If we can compress them down, get rid of the spaces in between, what kind of density would you have? Well, I did this calculation a year or two ago. I looked up the comet composition as best we can infer from measurements, also assumed to be primordial or average solar system compositions. And then I tried putting them back together again by working up the densities. I put the silicon and the oxygen together to form silicate rocks, or dust I should say. I had the various types of ices put together, and I started sticking stuff back in. And the best I could do was 1.25 grams per cubic centimeter. Actually, the density probably would be a little less than that. That's the compacted density that a true comet nucleus would have, which is a far cry from 2 grams per cubic centimeter. My conclusion is that Pluto and the other larger bodies we're finding out there can't possibly be comet nuclei. Not only is the size wrong, but the density is completely wrong, and hence the composition is completely wrong. So I seriously question if indeed the Kuiper Belt as the source of short-period comets has indeed been found. Okay, here we have a photograph of the Earth and the Moon taken from a space probe, I forget which one now, a few years ago. It's a very interesting one because it shows the Earth and the Moon, their appropriate sizes. Interestingly enough, they had to actually tweak the image of the Moon up a bit because while the Earth reflects light very well, the Moon's albedo is very low. So the Moon was too dark to really show up. So they had to play games with this photo a little bit to clean it up for us. And what I want to talk about is the tidal interaction that takes place between the Earth and the Moon. The Earth and the Moon, we all know, the Moon on the Earth causes the tides. We have 2 highs and 2 lows per day, usually in most places on the ocean at least. And there's some other complex interactions going on. There's the Earth's rotation carries the tidal bulge forward appreciably, and that makes kind of a handle or a lever that the Moon then pulls on and pulls back on the Earth's rotation, and it slows the Earth's rotation down. At the same time, opposite and equal reactions from Newton's third law causes the Earth to pull the Moon forward in its orbit. So 2 things are going on. First of all, the Earth's rotation slows down so that in the past the day was a little shorter than it is today, and the Moon spirals away slowly but surely, and we can estimate that current rate of the rotation slowing down of the Earth and the spiraling outward of the Moon. We've done that a couple of ways. One is during the Apollo program, they left reflectors on the surface of the Moon, and periodically, I think at McDonald Observatory, they use a 107-inch telescope. They fire a laser beam through the telescope to the Moon, off those reflectors and back again. So it goes 500,000 miles, round trip, and that feeble bit of light coming back allows them to precisely calculate how far away the Moon was at an instant. It's kind of hairy. I've looked through the papers on this, and getting down to a simple, nice little answer is not easy because there are all sorts of effects going on the moon's orbit, running a little tweaking of the moon's orbit all the time. It's not a simple two-body problem. It is to a first approximation. We're not doing a first by approximation here by a long shot. So you have to do a lot of analysis of the data to get this. What they found is that the moon is moving away about 4 centimeters a year. Yay much, not a whole lot. And they can also fix the rotation rate of the Earth by going back and looking at eclipse records, solar eclipse, where they were seen on the Earth, and that can fix the rate the Earth's rotation is slowing down. Now, interestingly enough, you can't model this. You can't just go in and run the numbers and have a model of what's going on with the Earth and the Moon. You actually have to fit it to the data. And the formula here, the tidal interaction goes as the inverse sixth power of the distance, 1 over r to the sixth. It's a very steep function of distance. And if you take this linear rate that we've measured and just extrapolate that back, then there's no trouble in the past, even going back billions of years. But you can't do that. You have to extrapolate back based on the inverse sixth power of the distance. And I've run the numbers myself on this, and I get the same results everybody else seems to get, that at the current rate of lunar recession, it's a differential equation you can solve. You find that the Earth and the Moon were in contact less than 1.3 billion years ago. That is, you run it backwards, the Moon spirals back, and it's in contact with the Earth. So you could start from there. The Moon and the Earth are here. The Moon starts spiraling outward. By the way, about 1 billion years ago, a little over 1 billion years ago, there would have been like mile-high tides on the Earth. This is not something that creationists themselves came up with. I read papers going back at least to the 1960s on this, asking the question, where was the Moon, say 4 billion years ago? And this seems to be a pretty stiff constraint. Again, it doesn't say automatically the Earth and the Moon are 6,000 years old, but it would seem to eliminate that they've been orbiting around one another for more than 1.3 billion years. You have a choice between 6,000 years and 4.6 billion years. It would seem to rule out the 4.6 billion years. Indeed, anything less than this and something appreciably less than this. Well, as you might imagine, there is a response to this, and the argument is that we live in a time of unusually high tidal interaction. Now think about that, an unusually high tide, time of unusually high tidal interaction. That is, the Moon is leaving the Earth at a very fast rate compared to what it was in the past. And it's kind of like a hand-waving sort of argument. You said, well, must have been some change that took place here, not really telling us what really happened there. No evidence for that, just simply assertion that this must have been it. In more recent years, they've gotten more clever. They argue more specifically that when the Moon and the Earth began orbiting one another 4.5 billion years ago, they were stuck in a tidal lock. There's a complex interaction. I said you couldn't model this. The reason being it depends on the locations of any continents you have. It depends on how much the upper mantle has been distorted and so forth. So the tidal locking held for supposedly for 3.5 billion years, and it caused the Earth and the Moon not to have any kind of tidal evolution taking place at all. And then it got out of tidal lock, and we're living at this time now where the thing has been spiraling away ever since. And people have done computer models of how this could have happened, might have happened, should have happened perhaps. But again, there's no evidence for it. Furthermore, there's no real mechanism for it. They simply hypothesize that this is what's happened in the past. And again, I have to ask, is this science? Is this the way science is supposed to work? I thought we were supposed to look for data, look for evidence. But what's going on here is people merely assert that this is what's happened in the past, not offered any evidence that that is indeed what's happened. And again, it's a far cry from saying that it might have happened or could have happened to saying it actually did happen. It's a plausibility argument at best. So this comes across as being rather ad hoc. Kind of a special pleading. In logic of special pleadings, you're asking for a gimme here. Gimme this to make sure that this will indeed work. And that's to me, that's very problematic that people are asking for that kind of help in this kind of response to this argument. Here we have a photograph of the sun showing several very nice sunspots. You know, earlier I mentioned Lord Kelvin's argument about the age of the sun. That was assuming that what we call the old Kelvin-Helmholtz theory of powering the sun based upon gravitational potential energy conversion. As the sun slowly contracted, it would convert half that energy into heat, be radiated away. Around that time, around 1900, beginning of discovery of radioactivity, people began to suggest that maybe the sun was getting its energy from some form of radioactivity. And eventually they decided upon this theory in the middle part of the 20th century of hydrogen to helium fusion. And when you run the numbers on that, you find the sun could shine for 8 to 10 billion years that way. So that would seem to salvage a 4.5 billion year old sun. And I think today there actually is evidence for that from the neutrino experiments we've done. So that's a pretty good science correction there. But even though we have nuclear fusion to power the sun today, there still is a problem out there. So a name's been given. This has been called the early or young sun, faint sun paradox. The early faint sun paradox, or the young faint sun paradox. I don't like to call it a paradox because I don't think it really is. What's going on here? Well, over what we understand about the structure of the sun and how it's getting its energy, over a long period of time, over billions of years, the sun should gradually brighten. There's a complex interaction going on as you, down on the core of the sun, as you fuse hydrogen into helium, you're changing the mean molecular weight because you're going from predominantly hydrogen to all helium at some point. And as you do that, it changes the structure because you're changing the mean molecular weight. You have to go through the ideal gas law and a few other laws to go through there to find that. But as that happens, it causes the temperature of the core of the sun, where those fusion reactions are occurring, to increase. And the fusion reaction inside the sun, which we think we understand pretty well from nuclear physics, is highly temperature dependent. If you change the temperature slightly, you change the rate at which the sun's energy is produced quite a bit, actually. So over a slow period of time, as you transmute material inside the sun from hydrogen to helium, it should increase the rate at which the sun produces energy, and it's driven out through the outer layers and eventually radiated away. And we can calculate how much that ought to change. And that calculation over 4.5 billion years, that the sun should have brightened by about 40%. That is, the sun today, according to this theory, is 40% brighter than when it formed 4.5 billion years ago. You can go back to 3.5 billion years ago when life supposedly first appeared on the planet, and it's a 25% increase. That is, today the sun is 25% brighter than it was when life first appeared 3.5 billion years ago in that long time approach to things. Now, you can imagine with concerns about global warming that if you increase the flux of the sun a bit, you would also increase temperatures on the earth quite a bit. And I'd read the results for this, and a few years ago I sat down and actually ran the numbers myself. And what I found, took me a while to figure it out, but I did finally, I got a calculation that in those 3.5 billion years, while the sun's temperature is raising, luminosity is increasing by 25%, the Earth's temperature should have raised 17 Celsius. That's, in real temperature, about 30 degrees Fahrenheit. That's an average temperature. In the literature, I've seen 16 to 18 Celsius. So when I got that number of 17, I wasn't doing any kind of error analysis. I was right in the middle of that range. I think the 16 to 18 is probably the error, plus or minus 1 Celsius. Well, it's interesting that the average temperature of the Earth today, I read, is 15 Celsius. So the average temperature of the Earth 3.5 billion years ago, when life originated on the planet, according to most theories scientists hold to today, the average temperature would have been minus 2 Celsius, or about 28 degrees Fahrenheit. I think you can imagine very easily the entire planet, most of it would have been engulfed in a huge layer of ice. And people have talked about ice ages over the years. What happens when you get a planet engulfed in ice, and getting it to go that direction is bad enough, but getting it to come back out of it is well nigh impossible. If the Earth would have frozen up like that, it will remain so. But on top of that, geologists and biologists seem to be convinced that the Earth never was that cold. In fact, they pretty much insist that over the past 3.5 billion years, the temperature has remained fairly steady. The temperature's increased and decreased by a small range, but it's not changed appreciably from what it was 3.5 billion years ago. So the big question arises, how could the Earth have maintained such a constant temperature over those 3.5 billion years. And indeed, I think that's really problematic. That's why I don't think this is a paradox. I don't think the sun and the earth have been around anywhere near 3.5 or 4.5 billion years. This fits very nicely with what I believe to be true about the age of the earth and the sun. Well, obviously there must be some sort of response to this, and so the argument is that the Earth's atmosphere has not always been the same as it is today. The argument is that the early atmosphere of the Earth had a lot more greenhouse gases in them than they have today. A lot of CO2, for instance, much more than we have today. And then as the sun gradually brightened and got brighter, the Earth's atmosphere changed in a compensating way so that the greenhouse gases were removed through geological activity, even through biological activity, in such a way that the two were balanced pretty precisely for 3.5 billion years. And that really kind of stretches my credulity to believe that you can have two unrelated events, one going on in the sun, one going on in the earth, and yet the two exactly compensate one another consistently for 3.5 billion years. There's no feedback mechanism involved in this, and there is no evidence actually presented for this either. It's just simply asserted. It's a plausibility argument. Once again, it could have happened, possibly could have happened, but that's not the way science works. Unfortunately, that's the way historical science seems to work anymore. And that's the reason why I said before is that the rules are very different, and I think the confidence that we ought to have in historical pronouncements from science should be very low compared to operational science. And again, this should cause us to wonder perhaps maybe the world isn't that old after all. By the way, I'll mention that a number of people have addressed this issue. One of the last papers, probably the last paper that Carl Sagan published, it was done posthumously, was on this very issue. He was one of the first ones to really write on this, along with a couple of co-authors who then finished the paper up after his death. And again, no evidence, just this could have happened. And that's an ad hoc sort of special pleading to get around this very strong objection to what's happened to the Earth in the past. Well, here we have a photograph of, I've never studied galaxies formally as an astronomer. I think they're very pretty, though. Spiral galaxies are really cool. This is, of course, the famous Whirlpool galaxy. And then here's a photograph of a barred spiral. I think these are really, really pretty galaxies to boot. And then here's the famous Sombrero, the M104 galaxy. That looks cool even through a good-sized telescope. Let alone the pictures. I can't really see the spiral structure showing up there because we're looking at it nearly edge on, but we're pretty certain that it's similar to the other kinds of galaxies, that spiral pattern. The spiral pattern is made up of combined light of many billions of stars, a lot of the brighter stars, particularly O and B type stars, blue, white stars, and you've got some H2 regions and other features there. Interesting, there's less there than meets the eye. If you go across the spiral arms from the center to the edge and did a census counting every star, you'd find the density of stars doesn't increase appreciably along the spiral arms, but instead you have an enhancement of the brighter stars. The density of brighter stars increases, but the faint stars are pretty constant across they slowly decrease as you go outward, but not increasing and decreasing across the spiral arms. So we have these spiral structures of galaxies. There's a big debate really from the 1930s through the 1960s. Once people realized that there were billions of other galaxies out there, they began studying those individually. And a big question came up, were these spiral arms winding up or were they winding down? That is, were they getting tighter as they rotated or were they getting unwinding, getting less tight as they rotated? And I think by the 1960s, mid-60s, they decided that neither one of those was the correct approach. Despite what your eyes seem to be telling you, they said, well, it's a little more subtle than that. And here's the reason why. As you look at this, you're looking at the combined motion of many billions of objects. And the objects near the inside are generally moving faster and they have a shorter distance to go. Planets around the sun, for instance, go faster at the inside, orbit faster. A little trickier here because we're not talking about a point mass anymore with the galaxy, but still the insides move faster than the outside. So as you rotate, the spiral structures should be stretched out. It should either tighten up and get smeared completely, or it should unwind very nicely. And so within a few rotations, you would expect any structure like these spiral arms should get smeared out. And yet we look at these these galaxies, and we see that the structure has persisted for some considerable time. And you can roughly do some estimates. Again, a few rotations would take, at least where we're located out from the center of our own galaxy, a 250 million years. So in 2 billion years, that would be 8 rotations just for us. And so it seemed that if you went through that many rotations, the spiral structure would be completely smeared out. And that's curious because we believe galaxies are probably 10 billion years old or even older. So the question is, after billions of years, many billions of years, why is it that spiral structure still persists in galaxies? And that would seem to suggest, again, not 6,000-year creation, but perhaps a creation that's not nearly as old as 13.7 billion years is generally thought today. Well, again, as a response, I want to anticipate that and come back and discuss that a little bit. In the late 1960s, they came up with this thing called spiral density wave theory. The idea is that there's stuff between the stars. We call this the interstellar medium. It's gas and some dust. And the idea is that there is a sound wave that propagates through that interstellar medium, and it tends to compress the gas, and as it does, set off star formation, which then allows us to see all those bright, hot stars along the spiral arms. And so the spiral arms are basically a density enhancement caused by that sound wave moving through. And so 40 years ago, everybody said, oh, that's it. Spiral density wave would explain this. And everybody else went on assuming that the problem was fixed. I understand over the last 40 years, people have looked at this and tried to make it work. It ought to be a fairly straightforward sort of thing, but they've had difficulty making the thing actually work in practice. I'm not convinced spiral density wave theory even works, and many other astronomers have reached a similar conclusion. I understand in recent years they've started arguing that you have interactions with companions, like for instance the Whirlpool galaxy. There's a small companion off the end of one of the spiral arms, and they think now that tidal interactions with the companions cause those spiral arms or have some effect to maintain and keep those spiral arms intact. Again, a lot of hand waving here, not a direct physical process. You write down the equations and out plops this nice spiral structure. It's a very kludgy, involved and convolved sort of theory. It ought to be straightforward. It isn't. I think the spiral structure still defies explanation. I think that they've not really done a good job in explaining all of these things. I'll go back to my title page. This is the Andromeda Galaxy. It's the closest galaxy, of course, to us, approximately 2 million light years away from us, the closest galaxy of similar size and type to our own Milky Way. And this really brings up a question that I want to anticipate at my conclusion here today and try to address this issue. This is another great photo taken more than a decade ago, the Hubble Deep Field. They took a little unimaginably small patch of sky where there were no galaxies or no nearby objects within a few billion light years, and they took a number of Hubble telescope exposures, stacked them, and so they had many hours of exposure. And when they got done, they got something like 1,700 little tiny galaxies. Almost every little smudge in the photograph is a distant galaxy, probably 8-10 billion light years away from us. Most, if not all of them, are too faint for us to actually get a spectrum and try to get a distance, so we can only estimate the distance. These are very distant objects, obviously, and this gives rise to what people have called the light travel time problem. That's the biggest problem, I think, that we recent creationists have to deal with, this light travel time problem. Basically is this: if the world is 6,000 years old, and I think the Bible suggests that it is, then how can you see things from 8 or 10 billion light years away from us? How can you see even the Andromeda Galaxy, which is 2 million light years away from us? How can you see a number of objects within our own galaxy which are only, say, 8 or 10,000 light years away from us? For instance, the Crab Nebula is about 6,000 light years away from us, which is right at the limit of what we would see in a 6,000-year-old creation. And that's a very fair objection. In fact, Hugh, I would be surprised if you don't talk about this in your presentation. If I were arguing for a very old creation as an astronomer, I would use this sort of argument. And it's a good one. It's one that we have to respond to, and fortunately we've had a number of responses. And without really endorsing or attacking any of these, I'd like to very quickly mentioned several. One was what we call mature creation. The late Henry Morris was very fond of this one. He argued that since God in the garden didn't make little tiny seedlings that grew up eventually to become trees, they had mature trees in the garden. You didn't have Adam and Eve being born as babies or being created as babies, having to grow up to become adults. They were, if we went back in a time machine, to appear to look like adults to us. They were told they could eat of any of the fruit there in the garden. And it takes time for fruit to develop, and the trees have been created on day 3 and they on day 6, so you had maximum 3 days of growth there. So obviously these things had to be created fully or nearly fully mature at that point. So he asked the question, why wouldn't the universe be created fully functioning and mature, us being able to see the distant objects and fulfill the purposes for those objects that the Lord gave back in Genesis chapter 1. I see the wisdom, I see the advantage of this, I see some problems with that as well, so I keep looking. Some people, Barry Setterfield, an Australian, has suggested that the speed of light has decreased. He's found some evidence, he thinks, from changing speed of light. I'm not a real fan of this one, but that's one that a number of recent creationists have suggested. Russ Humphreys has suggested what he calls the white hole cosmology, that the universe began as a white hole rather than a black hole, and he's got a book out and a video on things like this. And Hugh, you and Russ have talked about this one quite a bit. Jason Lyle, under a pseudonym of Robert Newton, suggested a few years ago a time convention. When does something take place? I mentioned the Crab Nebula. It's 6,000 light years away from us, roughly. It resulted from a supernova explosion which happened in 1054, the year 1054, 950 years ago. Because we have records of when that was observed here on the Earth. Well, when did it happen? Did it happen in 1054, or did it happen, say, 7,000 years ago? Because it's 6,000 light years away from us, and we observed it 1,000 years ago. Well, both answers are true. Both answers, because we can talk about it when the light reaches us. And so Jason has suggested that the light from the rest of the universe arrived on the Earth on day 4. And so in a sense, Jason's suggestion is an old universe sort of suggestion. Once people figure that out, they may not like it so well. Over the past year, I've been thinking about this in an entirely different direction. And I've really been struck with the fact that creation itself is a miraculous event. You go back to the garden, it says there, when he says, let the earth bring forth vegetation, trees, and grass, and flowering plants, and so forth. It comes out, and it talks about it in a very violent sense. It's like these plants leaping up out of the ground. If you look at the words there and look up the Hebrew meanings of those words, it's springing up, leaping up, coming forth very rapidly. So what I imagine in the garden on day 3, you have this little seedling suddenly sprout out of the ground, shoot up in the sky in like 20 seconds' time, this giant oak complete with catkins and acorns on the ends of the branches, in like a time-lapse photo. Abnormally fast, miraculous sort of growth and development. I'm thinking maybe on day 4, God creates these stars and then through some miraculous event yanks this light and brings it through space to us. Am I talking about a physical event for which I can give physical evidence? No, it's a miraculous event. I could no more give you physical evidence of any other kind of miracle. It's a miracle. It's a violation of these things. So I've been cogitating in that direction, just how miraculous this is. And in closing, Hugh, a couple of years ago when you were interviewing me in a radio program, you asked me something about, was the creation event something, a singularity, I think you asked me. You may not remember asking that question. I never had that question posed to me. And I'm coming around to the attitude that it probably was, though not the kind of singularity maybe you're thinking of or I'm even thinking of yet. But I'm really struck in the last year or so just how miraculous creation was. And I used to spend a lot of time worrying about this problem. But I think if God can make a universe as mind-blowingly big as it is and as marvelous it is, He has no problem getting the light here in a short length of time, and He can do it any number of ways. Well, thank you very much.
Our second presentation will be made by Dr. Hugh Ross, who received his PhD in astronomy from the University of Toronto and has done postdoctoral work at the California Institute of Technology on quasars. He is also founder and president of Reasons to Believe, a nonprofit research organization designed to provide scientific information from a Christian worldview. He's the author of numerous publications, both academic and popular, including The Creator and the Cosmos, Why the Universe is the Way It Is, The Fingerprint of God, and Creation is Science. Dr. Ross also hosts the weekly radio program Creation Update and travels worldwide challenging scientists, faculty members, and students to consider the reasons why they believe. Dr. Ross, welcome.
The universe, old or young? What does astronomy say? Now, it's not my role here to respond to any of the evidence that Danny Faulkner presented. I've done that previously in this book, A Matter of Days. What I'm here to do today is to present what I think are some of the better evidences in astronomy for why the universe must be 14 billion years old as opposed to thousands of years old. And I'm picking 8 evidences that I want to talk about. Number 1 would be the spreading apart of galaxies. And I'm purposely trying to pick evidences that are relatively free of assumptions, compelling evidences where assumptions really aren't a problem. Number 2 would be the presence of galaxies, stars, and planets. And then the temperature of the cosmic background radiation, the radiation from the cosmic creation event. Light travel times I'll discuss, and then the observed aging of stars and galaxies, the abundance of radiometric elements, cosmic observability, the fact that we are at that one time in cosmic history when we can observe all of cosmic history directly, and then looking at Earth orbit cycles seen in the ice cores. Now, where I do take exception with Danny is I look at astronomy as a special science. We can't see the present, but we can see the past, and we directly observe the past. We're not inferring the past because it takes light time to travel from the objects we're observing to what we're seeing. So this is why we see in astronomy the most compelling scientific evidence, not only for the cosmic creation event, but for the details of what God did in creating and designing this universe for the benefit of human beings. So let me begin. And let me begin with where I think we have common agreement. I think both sides agree that the universe has a beginning. And this beginning includes not only the beginning of matter and energy, but the beginning of space and time itself. Also, we see on both sides an agreement that the universe has continuously expanded from the cosmic creation event. Now, we have many compelling scientific evidences that what the Bible predicted thousands of years ago about a continuously expanding universe is actually correct. I'm just going to focus on one that I think lay people can most easily appreciate, and that's simply to look at the images of the universe at different light travel times. So, for example, here's an image from the Hubble Space Telescope that shows what the universe was at 12 billion light years distance, which for the light travel time would be 12 billion years ago, contrasted with another Hubble Space Telescope image where we look back only 2 billion light years instead of 12 billion light years. And this is all to scale. You can see that the galaxies were jammed tightly together in the distant past, but are now much more expanded apart. And so by looking at images of the universe taken at different light travel time distances, we can very visually demonstrate that the universe indeed has continuously expanded where the galaxies are being spread apart. Moreover, we can document that the universe started off very small and has become quite large as a result of this expansion. And so these kinds of images tell us by how much the universe has expanded. Now, this leads into an interesting evidence for the age of the universe, namely that if the universe were, say, less than 1 million years old, then it would be 100% diffuse gas. And the problem here is, as the universe is continuously expanding, if it expands too rapidly from the cosmic creation event, then the gas gets dispersed at such a high rate that it's not possible for gravity to collect any of that gas to make stars and galaxies. And so in a young universe, we would predict that the universe would be nothing but gas. On the other hand, if the universe were expanding more slowly, say if we were living in a universe that was more than a quadrillion years old, that slow expansion would mean that gravity would be able to collect this gas and dust so effectively that in a relatively short period of time, all the matter of the universe would be collapsed into black holes and neutron stars. Now, what you notice in both cases, you get a universe that can't sustain life. If all you've got is diffuse gas or all you've got is neutron stars, you've got a situation where you're not going to have the elements that would make life possible. Only if the universe is about 14 billion years old is it possible to get stars like the sun and planets like Earth so that life would actually be possible. So the very fact that we see planets and stars in the universe tells us that the universe is not thousands of years old or quadrillions of years old, but is actually billions of years old. Now, we can actually measure these expansion rates with some precision today. And since we recognize that the universe must have begun very small, our images actually demonstrate that the universe started off as very small, then we have a rather simple means to measure the age of the universe. This is the only equation I'm going to give you today, but the age of the universe would be its present size divided by the expansion rate. So determining the age of the universe boils down to measuring what is the rate of expansion. Now you say, is it possible for astronomers to measure this rate of expansion throughout cosmic history? Well, thanks to instrumental advances, astronomers possess a continuous record of the past 13.4 billion years of cosmic expansion. In other words, we look out 13.4 billion light years away, and we can see that the expansion rate has been continuous. And moreover, we can see only a tiny change in the cosmic expansion rate. So it's relatively constant over this 13.4 billion years of light travel time, only a tiny change. And in that context, every cosmic expansion measure that astronomers have run established that the universe is about 14 billion years old. In years past where the data wasn't as good, we didn't have that kind of agreement, but today, now that we have good expansion measures, they all agree that we are seeing a universe that's about 14 billion years old. Now, a method that is very free of assumptions is to simply look at the cooling of the universe. Again, another biblical prediction that with the universe continuously expanding under constant laws of physics dominated by the second law of thermodynamics, or the law of decay, as it says in Romans 8, we would get a universe that would get colder and colder as it gets older and older. Now, what you see here on the graph is that curve represents the cooling we would anticipate if the universe is 14 billion years old. Then overlaying that are actual measurements in distant gas clouds showing us the temperature, the radiation from the cosmic creation event. That temperature is going to cool down as the universe continuously expands, and we can actually measure what the temperature of that radiation was at different points in the past history of the universe, and we recognize that the data is indeed consistent with the predicted 14 billion year cooling of the universe. Now, light travel time is something that Danny did mention, and it's something that all astronomers recognize is a serious challenge to any young Earth interpretation. And it's simply the fact that light from galaxies billions of light years away must take billions of years to travel to our telescope. And in this context, there's no escaping the conclusion of a 14 billion year old universe unless one speculates something radically different happened to time or to the light phenomena. And all the attempts by young Earth creationists to solve this problem of light travel time boiled down to trying to manipulate time in some dramatic way or the character of light. Now, in my opinion, there's only three solutions from a young universe perspective to this light travel time problem. Many more in the literature, but young Earth creations acknowledge that they're patently absurd except for these three. One is that God created the light in transit, some kind of appearance of age argument, that God miraculously brought the universe into existence with this appearance of age, creating the light in a mature form at some point, that the velocity of light was different in the past than it is today. And to resolve the problem from a young Earth perspective, this light would have to travel 1 million times faster in the past than it does today. Or the solution that's been recommended by Russ Humphreys in the young Earth camp, that distant clocks in the universe run 1,000,000 times faster than they do here on Earth. Well, let me just go through these one at a time. If God indeed created the universe to have the maturity, created it mature in some miraculous fashion, or created light in transit, this is actually testable. Again, astronomers can look far away and therefore directly observe what God was doing in the past. And so we can actually test, did God create the light in transit? Now, one of the things we astronomers note, as a beam of light travels through space, it does two things to the spectral lines of stars and galaxies. It broadens the spectral lines, and it reddens the continuum in radiation between the spectral lines. So again, this is a typical spectral line you see here, and we would expect that as that beam of light travels through space, that spectral line would get broader and broader as it goes through space, and the radiation in between would get redder and redder. However, when we look at these spectral line widths and the continuum radiation of distant stars and galaxies, it tells us that God did not create the light in transit. It's something that God could have done, but our measurements tell us that's not what God did. Direct measurements show that indeed the spectral lines get broader and broader in direct proportion to the light travel distance, and the continuum radiation gets redder and redder. And what's broadening the spectral lines is the fact that as a beam of light travels through space, it goes through gas clouds, and these gas clouds have different motions. And those different motions are such that with the more gas clouds you go through, the broader the spectral line. And the reddening is caused by dust. As light travels through dust, you can see this in a forest fire. Dust from the forest fire will cause the light of the moon and the sun to get redder in proportion to the amount of dust. And this happens in astronomy as well, that the greater the distance, the more dust that light is going to encounter, and the more gas clouds are going to disturb the width of the spectral line. Now, the second proposal is that the velocity of light was dramatically faster in the past than it was today. And one way to challenge that is simply to look at the one equation that everybody knows. They may not know F equals ma, but they know E equals mc squared. And E refers to the energy, m to the mass, and c is the velocity of light. Now what this implies is that if light's velocity, the c term, were 1,000,000 times faster, say, for Adam and Eve than it was for us, that would make the energy output coming from the sun and the stars 1,000,000,000,000 times brighter. And notice that there are no other constants involved. You only have the one physical constant, the constant c. So it's, again, is free of any assumptions about the operation of other constants. And so what that would mean is that if you were to look back in time, the light travel time, objects would be far brighter than they would today. So for example, if this is a particular object that it looks today, if you were to look at it in the past, it would be far brighter than it would be in the universe today. Now, this only shows a small degree of brightening. We're talking a brightening that would be a factor of 1,000,000,000,000 greater than what we'd be observing today in all the stars, and in particular the sun. And if that were to happen to the sun, it would incinerate the earth, and we can read the biblical texts and recognize that Adam and Eve survived, and therefore he was not incinerated by the heat of the sun. This did not happen to Adam and Eve. And therefore, from a biblical perspective as well as direct observations, we would say the velocity of light has not changed. Since the velocity of light since the sun did not vaporize the earth, the velocity of light for the first humans couldn't have been any faster than it is today. Now, there's another way we can get at this problem. Was the velocity of light faster in the past? And this again, we go back to these spectral lines. There are certain spectral lines in astronomy called hyperfine split spectral lines, and some of these lines are extraordinarily bright and therefore easy to see at great distances. And the frequency of emission depends on the velocity of light. And so by measuring the spectral lines of position, we can determine whether or not the velocity of light in the past was any different than it was today. And we can see these hyperfine split spectral lines as far away as 13 billion light years, and it tells us that over the past 13 billion years of the history of the universe, we've seen no change in the velocity of light. it's the same as it was in the past. It confirms what the Bible says, that the laws that govern the heavens and the earth are fixed. And also we recognize that this is an anthropic principle, that any change in the velocity of light at any time in the history of the universe would make the universe uninhabitable. So the fact that we have life existing in the universe demonstrates that the velocity of light in the past was the same as it is today. Well, the favorite argument within the young Earth camp for trying to defend a young Earth perspective in the context of these light travel times is that distant clocks ran faster than they did in the past. The idea that the Earth and the solar system and our Milky Way galaxy at the bottom of a gravitational well, where you would get gravitational time dilation that was predicted by Albert Einstein, where you got very powerful gravitational fields, and therefore that clocks here on Earth are running much slower than clocks elsewhere in the universe. But these distant clocks are not hypothetical, as Russ Humphreys presumed. He was assuming that we didn't have any clocks to really put his ideas to the test. The truth is, the universe is filled with accurate clocks, and at all different distances. So we can easily test whether or not this idea that distant clocks run faster than they do here on Earth is indeed true. So do distant clocks run 1,000,000 times faster than they do here on Earth? Let me give you an example of one of these clocks. There are many different kinds of clocks, Cepheid variable stars, but supernova are the ones that we can see at fairly significant distances. And this is a supernova 1994D, which means it exploded, the fourth one to explode that we were able to see in 1994 in the galaxy NGC 4526. And you have a very bright star showing up. There's the supernova off to the bottom left, and it became very bright for several months, and then as the explosion finished, it dimmed away. Do you want to see that one again? Well, let me show you how it works. When a supernova explodes, a single star will actually shine with a light equivalent of nearly the rest of the galaxy, and this takes place over several months. So this gives us a supernova clock, where we see the luminosity of this star dramatically increase over about 2-month period, reaches a peak brightness, and then over the next 5 or 6 months gradually diminishes in brightness to where it's actually dimmer than it was before the supernova eruption took place. Now, in this sense, we can test 3 different models of the universe. Using these supernova eruptions that we see at very great distances in the universe, we can test, number one, are we living in a universe that is static? So a universe where there's no expansion, we would expect that these distant supernova would take the same amount of time to explode as they do in our galaxy, namely about 7 months. But if it's a 14 billion-year-old universe where the universe has been continuously expanding for 9 months or for 14 billion years, we would actually predict that the clock would run slower. And this is the direct result of Einstein's theory of special relativity, which says that if an object is moving rapidly away from you relative to the velocity of light, if it's a sufficient fraction of the velocity of light, the clock will actually run slower than it would if it were not moving at all with respect to us. And so in the old universe model, we would expect that these supernova would take longer to go through their cycle than they would in our own galaxy. But with the Russ Humphreys model, the prediction is that they would take about 18 seconds to go through their light cycle relative to what we see here. And there is no evidence that it's taking that fast. All the evidence tells us we're looking at 8, 9, or 10 months. We do see the time dilation that's predicted by the universe continuously expanding. And by the way, the degree of slowing down that we would see is another measure of the age of the universe. And this degree of slowing down of these distant clocks is consistent with the universe being 14 billion years old. So it leaves us with a conclusion that there is no young universe creationist resolution to the light travel problem, not even a conceivable resolution to the light travel problem. And this is widely recognized within the young universe creationist camp, and their typical response is to say, well, it's not just us young Earth creationists that have a light travel time problem. This is also true of old Earth creationists. And actually they have a point that in one context the universe seems too young in the context of light travel, that a 14 billion year old universe is too young to explain the fact that when we look at the cosmic background radiation, we see that radiation is thermally connected. And that means that the universe must be old enough that the different parts of the universe are actually in thermal communication with one another, which would require the light to actually be a higher velocity or the universe to expand at some point. But it does mean that from an old Earth perspective, we're presented with a problem. The universe seems too young, even in the context of 14 billion years, to explain this thermal connection. And obviously nothing happened with the velocity of light. We've already discussed that. And the problem, however, is completely resolved if there is a period of hyperinflation where the universe expands at many times more rapidly than the velocity of light when the fundamental forces of physics are separating from one another. And in terms of the physics, as the universe starts off nearly infinitely hot and cools down, as it cools down, you will get a separation from a unified field force into first two forces of physics, then three, and then finally 4 forces of physics. Now, this is called the inflationary hot Big Bang model. And it's not hypothetical. We can actually come up with evidence for whether or not the universe has undergone such a hyper period of inflation to make the universe thermally connected when these forces of physics were separating. And the inflation test comes out of detailed measurements of the radiation from the cosmic creation event. And it's something called the scalar spectral index. Now, if there's no inflation at all, then the scalar spectral index would measure to be 1.0 or something greater than 1.0. And if it's a very simple inflationary model, then we'd expect that scalar spectral index to measure 0.95, exactly 0.95, but if it's complex inflation, it's going to be somewhere between 0.96 and 0.97. And we now, for the first time, have measurements of this radiation from the cosmic creation event that are powerful enough to actually test which of these 3 models is correct: no inflation, simple inflation, or complex inflation. And the 5-year WMAP, the Wilkinson microwave anisotropy probe, the latest measurements tell us that the scalar spectral index is 0.960 plus or minus 0.013, which means with 99% confidence we can conclude that we do indeed live in a universe that experienced this period of hyperinflation. Now, just recently in the Astrophysical Journal, literally just this past week, there was a paper published where they tried to calculate the scalar spectral index based on measurements of 307 distant supernovae, came up with a similar number, 0.969, but with a significantly larger error bar. And there are instruments that are being planned, like the Planck instrument, that'll be capable of measuring this with far greater precision, and literally within a few years, we'll know for certain whether or not the universe is undergoing this kind of inflationary event in the past, but already the evidence is heavily leaning towards that. So from an old Earth perspective, we don't have a problem with light travel, but from a young Earth perspective, the problem persists. Now, the next thing I'd like to deal with is the aging of stars. And this is a globular cluster. It's the Omega Centauri cluster, and it's filled with stars that astronomers believe to be very old. In fact, it's filled with stars that are completely burnt out. Burnt out stars would be white dwarfs. A small star, when it runs out of fuel, becomes a white dwarf. A bigger star, a neutron star, and really big stars will end their burning time as black holes. But as we look throughout the universe, we see lots and lots of white dwarfs, quite a few neutron stars, and a few of these black holes. Now, in the context of trying to measure with some precision the age of the universe by looking at these stars that have burnt out, white dwarfs gives us the greatest precision. And the point here is it takes a long time for a small star to become a white dwarf. The burnout times, assuming a constant velocity of light, which we've already covered, are literally in the billions of years. So the very fact that the universe contains any white dwarf stars at all tells us that the universe must be billions of years old. But the other thing we can notice, and this has been a major advance in astronomy in the past several years, is now we have telescopes powerful enough that we can actually look at the cooling of these white dwarfs. And cooling diagrams of white dwarfs establish that many of them have been undergoing cooling for billions of years. And if you want to lay analogy, think of burning wood on an open fire. And there's a certain color and brightness you get when the wood still has fuel to burn, and when it runs out of fuel, it becomes a cinder. And as you wait, you can see that the cinder will change brightness and color as it gets cooler and cooler after it's run out of fuel. And this is what astronomers do with stars, only with stars we're looking at far simpler physical systems, and therefore we can measure with great precision not only how long they've been burning based on their mass, but also how long they've been undergoing cooling. And so by looking at tens of thousands of these white dwarfs, we can determine, and indeed many of them have been undergoing cooling that has lasted for billions of years. Now I want to point out, this is simply based on the assumption of thermodynamic cooling. So the Bible tells us that the entire universe has been subject to the law of decay, and we have these constant laws of physics. So just simply assuming that we are under this law of decay, that allows us to calculate with great precision how long these stars have been cooling. So we're only assuming that the universe possesses a thermodynamic history that would allow life to be possible. Without that law of decay permeating the entire history of the universe, there'd be no possibility of life. Now, in one context, I can give a quick rebuttal to what Danny Faulkner is talking about, because he does mention, he's probably best known within the young Earth community for his argument based on extended supernova remnants. And this is another point where we're talking about stars that are burnt out and what happens to them after they're burning out. And so he makes the claim that extended supernova remnants indicate that the universe can't be old. Now, I want to note here, first of all, that supernova remnants are the remains of burnt out stars. So the very existence of supernova and supernova remnants tells us that the universe must be old. Even the biggest stars take a few million years to go through their burning, to run out of fuel, and then undergo their explosion. But he does have a point. We don't see very many of these extended supernova remnants. But there's a good reason why we don't. In the context of an old universe, these supernova are going to explode, their remnants will expand from the explosion, but in the context of an old universe, they're going to blend together. And so if the universe is indeed billions of years old, we would anticipate that with all these supernova eruptions, that eventually the supernova remnants will blend together and explain why we're not able to see these extended supernova remnants, or why they would be rare. Let me give you an actual visual example of this. If we're talking about a supernova remnant, for example, it's 350 years old, they're quite distinct relative to the background. But when you get to one that's 2,000 years old, we see that already it's so dispersed it's hard to see from the background. And here we see one that's 3,000 years old, and it's very difficult to pick out the remnant relative to the background. In fact, in this particular slide that I'm showing you here, the only reason why we see the remnant is that observations were made at 3 different wavelengths: X-ray, infrared, and optical wavelengths. And putting that all together, we can actually pick out the remnant relative to the background. But if all you looked at was the visual light, you would not be able to detect this against the background emission that we see in our galaxy. And this point was taken up by 2 astronomers, Still and Irwin, in the Astrophysical Journal. And they noted, this is a direct quote, that old supernova remnants can be seen only in, quote, low density, low metallicity environments such as the outer part of our galaxy, dwarf galaxies, and low surface brightness galaxies. In other words, if you look within the spiral arms of our galaxies, you haven't got a hope of detecting these because of the blending into the background. But in the same paper, they described their observations of the remnant GSH 138-01-94. Don't you just love the names that they put on these things? This particular supernova remnant is positioned in the very far outer reaches of our galaxy, where the density of stars is very low, the density of gas is low, and so it's easy to see the remnant against the background. And as they look at the expansion age, and what we're looking at here is you see this remnant about this size. You can measure the rate at which the remnant is expanding, and that rate of expansion will tell you how long it's been expanding since the eruption. In this case, they get an expansion age of 4.3 million years. And so if you look in the right areas, you can see these hyper-expanded supernova remnants, and many of them are in the millions of years. Radiometric decay is recognized within both camps as being a serious challenge to the young Earth creationist proposition. And the point here is that if the universe were to be only 10,000 years old, then we would expect to see lots of short-lived radiometric elements in both the Sun and the Earth. The Sun and the Earth would be filled with plutonium, technetium, neptunium. Those are radiometric elements that have half-lives in the millions of years. And so if the universe were less than 100 million years old, we should see an abundance of these radiometric isotopes in both the Sun and the Earth. On the other hand, if we were living in a universe that was old enough to support biological evolution, I say that because whatever illusions biologists have had, astronomers have always known. If the universe is only billions of years old, that's woefully inadequate to support any possible evolutionary theory of biology. And so what you really need is not billions of years, but quadrillions of years. But if the universe were, say, 10 quadrillion years old, then all the radiometric elements would be missing in the Sun and the Earth. Not just missing neptunium and plutonium, you'd be missing uranium and thorium, long-lived radiometric elements. They'd all be gone. And so in this context, we know that the universe is not old enough to sustain any reasonable theory of biological evolution. But on a 14 billion-year-old universe, you would have no neptunium or plutonium or technetium, but you would have uranium and thorium. Uranium has a half-life of 4.5 billion years, thorium of 14.1 billion years, and therefore in a universe that's 14 billion years old, we would expect to see lots of uranium and thorium in both the Earth and the Sun, and that's what our measurements tell us, that the neptunium, plutonium, and technetium are completely missing, but we do see lots of uranium and thorium, telling us that the universe is middle-aged, billions of years, not quadrillions, not thousands. Now, the response from the young Earth community, they acknowledge that this is a huge problem. And their response is to say that in the past, radiometric decay was much more rapid than it is now. But again, that violates the biblical dictum that the laws of physics haven't changed. But let's just look at this possibility of faster decay. And if that was the case, then we would actually see things different in the past than they are today. And what we notice is we do see neptunium, plutonium, and technetium not in the Sun, but in young stars, stars that have recently formed. And we notice is the amount of neptunium, plutonium, and technetium we see correlates with the amount of time that these stars have been burning. So just using our standard physics on how long these stars have been burning, that actually correlates perfectly with the abundances of these short-lived radiometric elements. And recently in the journal Science, they had published a similar test with respect to planet Earth. Because on planet Earth, we don't see any plutonium today, but we do see in the crust of the Earth are the decay products of plutonium decay. We see a xenon isotope ratio, 136 xenon relative to 131 xenon, and the point here is you get a different ratio of these xenon isotopes if it's the decay of uranium, for example, as opposed to the decay of plutonium. And so in the most ancient rocks on the Earth, we do see the signature of plutonium decay in these xenon isotope ratios. What that tells us is that plutonium definitely was present on the early crust of the Earth. Moreover, it tells us that the rate of decay of that plutonium at that time in Earth's history was identical to what it was today. And we can apply this test at all different look-back times in the history of the universe or looking in the crust of the Earth, and it tells us there's been no decay in the past decay rates. And actually, you could argue the fact that we have life on the universe today also testifies that there's been no change in the decay rates. Having as radical a change in the decay as young Earth creationists are arguing for would actually make the universe uninhabitable and the Earth uninhabitable. But another argument that I don't think either side has paid much attention to is the fact that we are living at a very special epoch. That if we were created any earlier in cosmic history than 14 billion years after the cosmic creation event, light from that cosmic creation event, given the velocity of light, would not have adequate time to travel on the space surface of the universe and reach our telescopes. And the earlier we're created in cosmic history, the less of cosmic history we'd be able to see. So in the young Earth model, you'd be witnessing far less than 1% of the entire history of the universe, much less than a 10,000th of a percent of the history of the universe. On the other hand, if we're created any later, dark energy, which we now know makes up 72% of all the stuff of the universe, would be expanding the universe at greater than the velocity of light. So if we're created any later than 14 billion years after the cosmic creation event, dark energy would speed the radiation from the cosmic creation event away from our visibility. What this means is only when the universe is 14 billion years old do you get to see 100% of the history of the universe and directly witness the cosmic creation event. So I mentioned before in astronomy, we don't infer the past, we directly witness the past. But in order to witness 100% of the history of the universe, given the laws of physics that we see in the universe indeed must be 14 billion years old. Any younger, any older, you see less of the history of the universe. Now, in the context of a creator, we can appreciate why the creator of the universe would want to put human beings on the cosmic scene at that moment when those human beings can uncover the handiwork of God in creating and designing the universe for the benefit of human beings. It tells us in the Bible the heavens declare the glory of God, they declare the righteousness of God. But in order for us to be able to see that glory and righteousness, it's critical that we be able to observe as much of cosmic history as possible, and it's only at this one epoch where we get to see all of it back to the cosmic creation event itself. Moreover, what I've noticed in my university speaking, it's the evidence we have from the cosmic creation event that gives us the most compelling scientific argument for the God of the Bible. The Bible is the one holy book that gives us in great detail a description of how God created the universe and what he did in expanding the universe from that creation event to prepare it for life and human beings in particular. And therefore, in the biblical context, it's critical that we human beings be able to directly observe all of cosmic creation. That really only happens at that one epoch. And then we can look at these ice and sediment cores and you say, what has this got to do with astronomy? Well, hang with me, you'll see in a minute. But what we have now are 6 ice cores, 3 in northern Greenland and 3 in central Antarctica. This is kind of like tree rings. You drill through the ice and you see all of these layers, and each layer corresponds to a year, just like a tree ring would correspond to a year. You get to see the seasons. We also have sediment cores off the coast of southern New Zealand. Now, these don't testify of annual layers, rather they testify of layers that are about a century long each. But we can use the ice cores to calibrate this New Zealand sediment core. Now, the deepest of these ice cores is in a place in Antarctica called Dome C. And in the case of Dome C, they've been able to go through 1 million of these layers, and they're very carefully analyzing it, but they're confident that they have 800,000 annual layers that document the history from the present day back to 800,000 years ago. They're also confident that they'll be able to recover another 200,000 years and give us a 1 million year history. And they say, why are they confident that the layers are annual? Well, in these ice layers, they actually see dust signatures from volcanic eruptions that have taken place in human history. And so, for example, we can see in this next slide the eruption of Vesuvius and the eruption of Krakatoa. And we know historically, Krakatoa I think was like 1887 it erupted, Vesuvius in the time of the Romans. And you can count the number of layers between the Krakatoa dust signature and the Vesuvius dust signature, and indeed adds up to exactly what our calendars would predict for the number of years between Krakatoa and Vesuvius. So we can calibrate it with human historical events that have taken place within human history. But what's most interesting to astronomers is we see in these layers the signature of the variation in the eccentricity of Earth's orbit. Now, as the Earth goes around the Sun, it takes an elliptical path around the Sun, and what we notice is the ellipticity of the Earth's orbit changes with respect to time. So it becomes more elliptical and less elliptical, more elliptical and less elliptical. It's a very regular cycle, and we can calculate that the variation is 100,000 years. So by making careful measurements of the Earth's orbit, we see it's 100,000 years. Moreover, it's exactly what we predict from our celestial mechanics calculations based on Newton's laws of motion. They would also testify of this 100,000-year cycle. But this 100,000-year cycle affects the climate, and that climate's going to affect what we see in those ice layers. And what we can see is actually in Dome C, 8 cycles, 8 very consistent cycles of variation showing that indeed we see in this ice core 8 cycles of the variation of the eccentricity of Earth's orbit. And really to defy this as an age measuring method is to defy the physics of Isaac Newton. So if Newtonian physics is accurate, and given the accuracy, the measurements of the observation of the orbit of the Earth, there's really no getting around that this ice core testifies of a minimum of 800,000 years of history and of that part of the world. Now, all 6 deep ice cores, not all of them have 100,000 layers, but they all have over 100,000 layers. Each one of them yields the identical result that the Earth must be more than 100,000 years old, based on the volcanic data and the variation we see in the ellipticity of the Earth's orbit. Now, the one off New Zealand actually shows a continuous record of the past 4 million years of the history of the Earth. And we can see 40 cycles of variation of the Earth's orbital eccentricity. Now, what I've done here in a few minutes is just to give you, 8 different evidences from astronomy that indeed we must be living in a universe that's not thousands of years old, but billions of years old. And let me conclude here by giving you what are the best measurements we have to date for the age of the universe and the age of the Earth. In the case of the universe, the best measurements we have are 13.73 billion years, plus or minus 0.12 billion. That's from the measurement of the cosmic background radiation, the WMAP, the 5-year WMAP, but it's also the same figure we get by looking at the geography of galaxies in the Sloan Digital Sky Survey. And in the case of the Earth, the best measurement we have based on radiometric dating is that the Earth is 4.5662 billion years old, plus or minus 0.0001 billion. Now, those error bars you see there are standard deviations. And in science, a standard deviation is a measure of the scientific certainty of the measurement. Now, in the case of the Earth, the difference between the old Earth date and the young Earth date is quite dramatic. If we were to measure it in the context of standard deviations, there's 45,662 standard deviations difference between the old Earth date and the young Earth date. And that's a little calculation showing you how we got that. And that allows us to determine the probability that the old Earth date is wrong and the young Earth date is correct. Now, I mentioned earlier, if you got 3 standard deviations, that's 99% certainty. 1 standard deviation, 67% certainty. 2 would be 95% certainty. But if you got 45,662 standard deviations, this is the degree of scientific certainty we're talking about. That the probability that the 4.5662 billion year date is wrong and a date somewhere in the neighborhood of 6,000 to 10,000 years is correct. I chose 10,000 years just to be generous to the young Earth creationist community. That means that the scientific probability that the young Earth creationists are right is less than 10 to the minus 452 million. That's 452 million zeros after the 1. And to give you some point of comparison, it's equivalent to someone winning the California lottery 60 million consecutive times where they buy just 1 ticket each time. Or, as one mathematician friend of mine told me, it's really no different from the probability of winning it 60 million consecutive times where you don't buy any tickets at all. And so this is why the scientific community is so extremely confident that we must be living in a universe and an Earth that's billions of years old and not thousands of years old. Now, I've only reviewed 8 different methods. There are many other methods, of course, for dating the age of the universe and the Earth, but with no exception, every other reliable scientific age measuring tool yields results consistent with the best measures. The scientific community does not recognize any age measuring method that would not be consistent with the billions of years. Or as was said at the Supreme, at a court hearing on young Earth creationism, Brent Dalrymple, a geologist, testified it'd be easier to believe in a flat Earth than to believe in a young Earth based on just how consistent all and rigorous this evidence is. Which leaves me with the following conclusion, that really the only explanation for a young Earth creationist interpretation would be an ideologically dogmatic insistence on a peculiar interpretation of a few Bible passages. I can't think of any other reason why anyone would ever conclude that the universe is 10,000 years old. And indeed, the only people I've met that believe that it's 10,000 years old are those people who hold that belief based on a particular peculiar interpretation of a few Bible passages. And this is even admitted within the young Earth creationist camp. For example, I was participating in a radio debate on the largest Christian radio station in America, KKLA, a big Christian station in Los Angeles. And years ago, a host, John Stewart, moderated a debate between me and the president of the Institute for Creation Research, John Morris. But this is the question he put to John Morris in the debate. Do you know any scientist who concludes, apart from a particular Bible interpretation, that the universe or Earth is young? And he answered honestly, no, I don't. And I also had a similar debate with Dwayne Gish, also of the Institute for Creation Research. The same question was put to him. He also answered, no, I don't. And again, if you want to read up a little more on this subject, I've written an entire book on this called A Matter of Days, looking at both the scientific and biblical evidence for why we must be living in a universe that's billions of years old, not thousands of years old. Thank you. The universe, old or young, what does the Bible say? Once again, I want to begin where I think both sides agree. We both agree that the Bible is wholly inerrant and must be read literally unless the context indicates otherwise. We also both agree on humanity, that all humans are descended from Adam and Eve, whom God specially created less than 100,000 years ago. We also both agree on the definitions of the Hebrew word yom that's translated day in Genesis 1, that the literal definitions for that word yom include a long but finite period of time. Can't mean infinite time, but could definitely mean a long finite period of time. Now there is another word in Hebrew that can mean a long period of time, but only in modern Hebrew and not in biblical Hebrew. In biblical Hebrew, yom is your only option. It can mean a long time ago or a long time in the future in biblical Hebrew, but not a finite period of time. So yom is really the only option for describing a long period of time in biblical Hebrew. And Danny made reference to sola scriptura. Again, we both agree on sola scriptura, that the Bible is the only verbal, propositional, authoritative revelation. But it's not the only revelation that God gives us. And the whole point here is nature is not a verbal, propositional, or authoritative revelation. Authority implies a person. Only a person has authority. And so the record of nature does not wield authority. And this is really what the framers of sola scriptura had in mind. That the Bible is the only verbal, propositional, authoritative revelation, but it's certainly not the only revelation. Why? Because the framers of sola scriptura were also involved in the two books confession that we see most prominently in the Belgic Confession. And what does it say in Article 2 of the Belgic Confession? We know him, that is God, by two means: First, by the creation, preservation, and government of the universe, since that universe is before our eyes like a beautiful book in which all creatures, great and small, are as letters to make us ponder the invisible things of God. Notice that the Belgic confessors, writing in the 16th century, looked at the record of nature as a book with letters in it. So they really endorse this idea that God is giving us two revelations and that we're to read and study both revelations. In that context, if you're a Christian, you're a scientist. God has given us a command to study the record of nature, just as he's given us a command to study the words of the Bible. Now, where the Belgic confessors got this two books theology was from the Bible itself. Psalm 19, verses 1 to 4, the heavens declare the glory of God. Day after day they pour forth speech. Their voice goes out into all the earth, their words to the ends of the world. So here we have the psalmist actually describing the record of nature as speech and words declaring God's glory. In Psalm 97, verse 6, it tells us that the heavens proclaim not just the glory of God, but his righteousness, and makes the point that this is one book that God has given us that every human being has seen. All the peoples have seen the glory of God because of how clearly God has revealed himself through the record of nature. And there are more than a dozen other Bible passages that make the same kind of claim about the value and the trustworthiness and reliability of the record of nature. And it's not that one is better than the other, they're different. Just like Hebrews is different from Romans. And we don't conclude that Romans is superior to Hebrews or Hebrews is superior to Romans. They're both the perfect Word of God. And so both the record of nature and the words of the Bible are God's perfect revelation. Our interpretation may be problematic, but there's no mistake or problem in the records themselves. And the point that we see in the Bible that's relevant to this debate about what does the Bible say about the age of the universe is it proclaims repeatedly that the physics of the universe does not change from the time that God creates it. Now, young earth creationists believe they have a mandate for change physics because of the curse. But if you look carefully at the curse, it doesn't say that God cursed the ground. Rather, it says, cursed is the ground because of you. In other words, because of human sin, we spoil our environment and we ruin our environment. And so the God does not claim that he changed the physics of the universe. Rather, he is saying that humanity changed as a result of their rebellion. Now, in Jeremiah 33:25, it tells us explicitly that the laws that govern the heavens of the earth are fixed. God is not changing them. He has established these laws for his purposes, and as long as the universe exists, these laws of physics will exist in the same form in which he had created them. In Romans 8, verses 20 to 22, it states that the creation was subjected to frustration, and the creation itself will be liberated from its bondage to decay. In other words, it's telling us God put the entire universe in bondage to this decay, this law of decay that scientists would recognize as the second law of thermodynamics. And in telling us that it really does apply to all of creation, the whole creation has been groaning right up to the present time. And we know in astronomy is you can't really separate the space dimensions from the time dimension of the universe. This implies that the entire creation from the creation event forward is subject to this law of decay. Now, we really know that all of creation is subject, and we see in Genesis is it states that stars were shining and humans and animals were eating before and after Adam's fall. And this would tell us that the laws of physics before the fall of Adam are no different than the laws of physics after the fall of Adam. Why? Because shining stars, burning stars, and the metabolism of food to process energy to do work, those are two processes in nature that are extremely sensitive to even the tiniest changes in laws of physics. So one reason why we know the laws of physics didn't change at the time of the fall or at the time of the flood is that we got people and animals eating both before and after, and we got stars shining continuously throughout that very period of time. And so the Bible really does rule out any possibility for the young earth doctrine that the laws and constants of physics were different in the past. And I say this because you see this in every young Earth paradigm to support the idea that the universe is thousands of years old into billions. At some point, they must appeal to radically altered or changed laws of physics, typically at the fall or at the flood or both. But the Bible categorically rules that possibility out. So in that context, we really must interpret the record of nature, recognizing no change in these laws of physics. The other thing that I find interesting is to look at this young Earth, old Earth debate in terms of history. And what you notice is only since the emergence of biological evolutionary theory has the church divided over the age issue. You know, once you get before Charles Darwin and the theory of evolution, biological evolution, the church comments on it, but without any specific statement and certainly no division of the church. In fact, the commentary is ambiguous until we see the emergence of this evolutionary theory. So somehow the birth of Darwin's theory of evolution launched this debate within the church over the age of the earth and the universe. And what's triggering the debate is this following conclusion. If Darwinian evolution is presumed to be an extremely efficient process, then the only way to tackle or to defend the idea of God creating and being responsible for all life, many verses in the Bible tell us that God indeed is the author of all life. He's the creator of all life. The only way to defend that, if indeed Darwinian evolution is extremely efficient, is simply to take away the time and say, well, we've only got thousands of years. We don't have the quadrillions of years that are necessary to support Darwinian evolution. And so this is really, I think, a key division between the old Earth community and the young Earth community. And the debate is, how much evolution does the Bible really tolerate? Now, young Earth creationists refuse to credit God for creating carnivores, for example. I'll give some reasons why in a few minutes. Instead, they appeal to hyper-efficient Darwinian evolution after the fall to explain why the Earth has carnivores instead of just herbivores. They also appeal to very efficient Darwinian evolution to explain how millions of species arose from just a few thousand on board Noah's Ark after a globally extensive flood. As far as I know, every young Earth creationist leader out there also believes that the flood of Noah was global in extent and wiped out all life except for those on board the ark. Well, as Henry Morris has pointed out, even if the animals don't eat or drink, we're looking at a maximum of only 30,000 pairs of animals, and the planet today has 10 million species. So you go from 30,000 or less to 10 million in a relatively short period of time. So you'll see in their literature, for example, that Noah took on board, say, a single horse pair, and that rapidly after the flood of Noah, that single horse pair, through Darwinian evolution, evolves into horses and zebras and donkeys and even creatures like the likes of llamas. Now, this appeal to hyper-efficient Darwinian evolution has been noted not just within the church, but also outside the church. Recently, the biologist Philip Kitcher published in his book that rates of speciation that creation science would require are truly breathtaking, orders of magnitude greater than any that have been dreamed of in evolutionary theory. In other words, the hyper-evolutionists on the planet today are not atheists, rather they are young Earth creationists. No one believes in Darwinian evolution as an extremely efficient process as dramatically as do young Earth creationists. And I think this point is lost in the debate in the church between young Earth and old Earth creationists, and really just how significant a role Darwinian evolution plays in the debate. And so the question is, how much evolution? Now, the difference between our two camps and the reasons to believe creation model, we do not have any biological evolution over any time scale, billions or quadrillions or thousands. We have no evolution at all beyond the species and genus level. And you say, why are you quibbling that? Well, in the scientific literature, you'll find 16 different definitions for a species. It's not like physics. These things are not well defined. Some of the definitions, in my opinion, are merely referring to breeds within a species. And recently they classified the steelhead for being a trout and put it back in the salmon genus. And so there's even problems trying to determine where a species falls within a genus. But in the young Earth creationist model, they hypothesize rapid evolution, naturalistic evolution, up to at least the family and the order level. And so this is the difference between our two camps. And the reasons to believe camp, hardly any biological evolution going on at all. And the young Earth camp, very aggressive biological evolution. So the question I want to address, does the Bible allow for efficient biological evolution? Is there any reason to believe that this assumption is correct? Now, I could focus on the science here, but my job is just to really look at the Bible in this particular talk. What does the Bible say? Well, in the Bible, we see not species or family or order or genus, but we see this word min that's translated as kind. So the debate really focuses on what does the Bible mean by kind, where it says reproduce after their own kind. Well, the word probably does not refer to genera, family, or orders, given the prohibition we see in Leviticus 19:19. What does Leviticus 19:19 say? Do not mate different kinds of animals. Now, it's making the point that it's possible to mate different kinds of animals, like a donkey with a horse and get a mule, but the Bible is telling us not to do that. And so the fact that it's talking about the possibility of mating different kinds of animals implies that this word min has a much narrower definition than a family or an order, and is probably focusing on something akin to a species. Now, this word min occurs 31 times in the Old Testament, and it's always in the singular form. And kiliyam, which is where it says don't mate creatures of different kinds, has only one definition, two kinds. So the point I'm making here, this is really referring to the same thing, one singular, one is plural. Now, to drive that point home, we can look at Deuteronomy 14:12 through 18. And what that passage does, it lists the eagle, the falcon, and the hawk. And these are closely related bird species. It lists them as separate men. It lists the red kite and the black kite as separate men, and the vulture and the black vulture as separate men. Again, this seems to eliminate that the min could mean something as broad as a genus, a family, or an order. And we notice in Leviticus 11:15 to 17, as well as Deuteronomy 14:15 through 17, that the horned owl, the screech owl, the little owl, the great owl, the desert owl, and the white owl are all referred to as being separate men. So once again, min appears in these two passages as to have a very narrow definition, certainly not as broad as a family or an order. So at least for the higher life forms, the Bible rules out natural evolution beyond the species and genus level. In fact, you see that in Genesis 1. When it's referring to the soulish creatures, the birds and mammals, it uses the word bara and asa to describe how God brought them into existence. Both words demand God's immediate, direct, miraculous intervention to bring about those species. So in that context, I think we can confidently conclude the Bible would rule out the young Earth hypothesis that, say, a single horse pair or a single cat pair can produce all the, quote, horse types or all the cat types that exist on the face of the Earth through natural means. Now, I was involved in a debate involving three different positions, young Earth, old Earth, and the framework hypothesis many years ago. And what I noticed was the core of that debate. In fact, the editor really tried to get us away from that debate, but I think it's significant that one of the ways we can probably make some progress in resolving this debate is to look at what the Bible says about the seventh day as opposed to the 6 days. Why? Because the Bible's got a lot more to say about the seventh day than it does the first 6 days. Many Bible passages address the topic of God's day of rest and exactly what he rests from. And this illustrates a principle that the key to resolving these biblical controversies, both within the church and outside the church, is to integrate all the biblical creation accounts. Now, Genesis talks about creation, but it's not the only text in the Bible that deals with creation. In fact, as I go through the Bible, I find 27 chapter-length or longer creation accounts. 5 of them are in the book of Genesis, but the other 22 are beyond the book of Genesis. And so we have here a list of these different significant creation accounts in the Bible, and 3 of them, Proverbs 8, Job 38 and 39, and Psalm 104, actually take you through the scientific content of the creation days, the 6 creation days. And therefore, one way I think the church can make progress on this is to integrate their interpretation of Genesis 1 with at least those 3 other accounts that also address the 6 days of creation. But obviously, you really want to look at all the creation accounts in the Bible, and not just those creation accounts, but all the passages in the Bible that deal with the topic of creation, which is why we've made a complete list of biblical creation passages on our website. So for yourself, you can kind of go through all these texts and see what all of the Bible, not just the book of Genesis, is saying on these creation issues. Now, one thing we will notice is that the first 6 creation days in Genesis 1 are marked by a beginning, namely the morning, and an ending, the evening. You know, whatever you think about the words evening and morning, they certainly are referring to the beginning of the day and the ending of the day. But what you do notice is there's no boundary set for the 7th day. There's no evening and morning for the 7th day, only for the first 6 days. And the text is quite clear that God rests after he creates Eve, and that he is still resting from his creation work. So after he creates Eve, he undergoes this point of this state of rest. And what does it tell us in Psalm 95, verse 11? So I, God speaking, declared on oath, they shall never enter my rest, referring to those who are rebelling against his authority. Notice that he's referring to his day of rest in the present tense. And we see this picked up in the New Testament in Hebrews 4, where it refers to God's 7th day, both in the present and the future. On the 7th day, God rested from all his work. Anyone who enters God's rest also rests from his own work, just as God did from his. Let us therefore make every effort to enter that rest. So evidently, we're still in this 7th day of rest. Now, this has scientific support in the sense that if indeed this biblical principle that God is currently resting from his work of creation, then as we do science in the present era, we would anticipate finding only natural processes and only natural causes. This is where some scientists have gotten the idea that science is an enterprise that only works with natural causes. Well, if you're doing experiments in the present realm, indeed from a biblical perspective, that's all you'll find, because God's resting from his work of miraculous creation. However, given that God worked for 6 days and rested on the 7th, that means that we would expect to find plentiful evidence scientifically for God's miraculous acts of creation in the past, before he created human beings. And indeed, this answers the fossil record enigma. The fossil record enigma is the fact that we see extensive evidence for speciation before the arrival of human beings. And it's at a very high rate. It averages 1 new species appearing in the fossil record every year. But if you look at it in the present era, we don't see any. I mean, we've yet to document the appearance of a single animal species in the record of nature. So in the human era, we don't see any significant speciation, whereas in the past, we see a huge abundance of this speciation evidence. So this would indicate that indeed God has been creating for these 6 time periods, but we're in that period right now where he is in a state of rest. And if we read on in the Bible, we'll discover there comes a time when God stops resting and creates again. This will occur after God permanently conquers and removes evil. And so the removal of evil from his creation, the universe will have fulfilled its purpose. That will be the end of the 7th day. And then we have the 8th day of creation and following, which marks the beginning of the new creation. Now, the resolution we have here is if the 7th creation day is a long period of time, as all these different creation texts in the Bible would argue, then given the grammatical structure of Genesis 1, the first 6 creation days also must be long periods of time. Now, after God creates advanced land mammals, and this is creation day 6, so a good chunk of creation day 6 is focused on God creating advanced land mammals to cohabit the planet with human beings. So after he creates all these advanced land mammals, he then creates both the human male and the human female. And all this happens on creation day 6. The land mammals, the advanced land mammals, then he creates both the human female and the human male. But notice what Genesis 2 says about what happens between the creation of the human male and the human female. It tells us, this is all taking place on creation day 6. It tells us that Adam was created outside of Eden. Eve was created in Eden, but Adam outside, which I think is one reason why God held him more responsible. He saw what was going on outside of Eden. And then it tells us he had an opportunity to watch the trees of the Garden of Eden grow. And so he was there long enough to see growth in these trees. And then God said, I want you to tend the garden. And so here he was tending the garden. And I imagine he had him work the garden long enough to realize there's got to be more to life than gardening. And that's when God had him name all the soulish creatures. Now notice what God is doing here. First, he's introducing Adam to the purely physical creation, the garden. Second, he introduces Adam to the creation that's not only physical, but also soulish, endowed by God with mind, will, and emotions, so that these creatures can actually relate not only to one another, but to human beings. And that's what we see in birds and mammals, that every bird and mammal species has been designed by God to form relationships with us human beings. A powerful argument against biological evolution in the context these creatures were created before human beings. So before humans even existed, they were endowed with this property to serve us and to form relationships with us. Now, I think what Adam was doing was giving an appropriate name to each of these creatures that described the way God designed these species to relate to him personally. And he began to experience a much greater degree of fulfillment with the soulish creatures than he did the plants in the Garden of Eden. But it tells us even after he had related to all these bird and mammal species in all their multiply different ways, that he was lonely. And again, it takes time to become lonely. And after he became lonely, God began to perform surgery on him, put him to sleep, perform some surgery on him. The text tells us that he recovers from the surgery, and then he sees his new creature, this female human. And what comes out of his mouth that's recorded in Genesis 2 in the Hebrew text, it's the word hapa'am, used 4 other times in the Old Testament, the meaning of the word at long last. Why would Adam say at long last if there was only a few seconds between his creation and the creation of Eve? But if you look at everything that takes place on this time between the creation of Adam and creation of Eve, it becomes quite clear this is certainly more than a 24-hour period. And again, the resolution here is that the 6th creation day is much longer than 24 hours, then given the grammatical structure of Genesis 1, all 7 creation days must also be much longer than 24 hours. But I'd like to address the question, do any Bible authors directly comment on the antiquity of the world? I mean, I hear people saying the Bible nowhere says the universe is billions of years old or the earth is billions of years old. And indeed, I agree, you're not going to find those kinds of passages. But there are Bible authors that actually do comment on the world's antiquity. And to demonstrate that, let me show you a photograph of one of my favorite mountain regions in Canada. And what you see here are some mountains, and you can see huge piles of rock at the bottom of those mountains. Now, if you sit there and have lunch, you might be lucky enough to hear a rock come off the top and join that pile of rubble at the bottom. And I've actually done that, and typically there's about 4 to 6 rocks per day that will fall off one of those mountains and join all of its buddies at the bottom there. Now, you can kind of look at that pile of rocks there and say, I wonder how many rocks are at the bottom. Many billions of rocks are there at the bottom. And so in the context of the rate at which we see rocks coming down, we would recognize this would testify indeed of a very long period of time to accumulate that pile of rocks.
Welcome to our program. We've got a great one for you today. Does the scientific evidence from astronomy show that the universe is billions of years old, or only 6,000 years old? My guests today are terrific, all right? We got Dr. Danny Faulkner, Professor of Astronomy and Physics at the University of South Carolina, Lancaster. Got Dr. Hugh Ross, who received his PhD in astronomy at the University of Toronto. He did postdoctoral work on quasars at Caltech. Dr. William Keel, Professor of Physics and Astronomy at the University of Alabama. Dr. Pamela Gay, Research Professor on the faculty at Southern Illinois University, Edwardsville. Dr. Donald York, Horace B. Horton Professor of Astronomy and Astrophysics at the University of Chicago. Folks, we are glad that you are here. And previous to this program, we held a 2-hour debate right here in the studio with Dr. Hugh Ross and Dr. Danny Faulkner. And Dr. Ross presented the scientific reasons why he thought the universe was brought into existence 13.7 billion years ago. And Dr. Faulkner presented the scientific reasons, the evidence why he believes the universe is only 6,000 years old. Their two presentations were sent to 13 astronomers. Two criteria for these guys in picking them out, all with PhDs, all who are Christians, who are asked to give a written opinion of the accuracy of each presentation in light of their understanding of current day astronomy. They have now done so. It's taken, 18 months, all right, to do that. So they really poured over this. And they have sent to us 3 courageous, world-renowned astronomers to represent the group. And I appreciate them coming to be on the hot seat today and present their conclusions to our 2 debaters and to those of you in our television audience. We want to hear what the scientists thought. Do they think the scientific evidence persuasively points to the universe being 13.7 billion years or to 6,000 years old? Then we're going to have some interaction with our debaters. So let's start with the official statement of the group. And Dr. William Keel, I'm going to ask you to begin. Let's look at the statement.
A group of Christians professionally trained in astronomical research has reviewed presentations by Drs. Danny Faulkner and Hugh Ross covering arguments on the age of the universe. We appreciated the civility and respect of the discourse on a topic often generating more heat than light within the Christian community. Our analysis concentrates on arguments made by the speakers dealing with astronomical data and calculations rather than about biblical interpretation or biological evolution, because that's our area of expertise. We do note that, for example, one's view of scriptural interpretation and theology will affect the range of models that one would consider. Our aim has been to assess the evidence for the age of the universe in the light of the arguments presented using a standard scientific approach.
When you got this group together on the phone, okay, was it tough slugging through all of this stuff?
It took a while for a number of reasons. We're a bunch of academics who have other things on our plates, and this was not an activity that our employers generally wanted us to do on a lot of company time.
That's why I'm very thankful that you did it, and I'm thankful for the courage it took to do it, too.
And we also had the issues that there were people who sort of almost had to drop out of the discussion for a term. They were away on leave or something. Another issue was we wanted to make sure that we really understood all of the arguments and hashed through what was involved if it was something that was outside our immediate area of expertise. So we wanted to try to make sure that we got this right.
Okay. Pamela, let's continue.
So we wrote as a group, science seeks to make progress in understanding the physical world through inductive reasoning rather than the watertight proofs found in mathematics. This means that scientific understanding advances through an enormous amount of focused, incremental efforts with many consistency checks in the context of a mutually accountable scientific community. So what this means is, as we come to terms with this universe, we start out painting with that large, broad brush, and we're painting an accurate picture, but it lacks the details. And over time, as we gather new data, as we reach for those smaller brushes, we're able to fill in details, but it's not all done in one go. It takes time to put on those layers of paint and put all of the details into our understanding of the universe. Mm-hmm. Drawing sound conclusions about a general question such as the age of the universe cannot be done on the basis of one argument alone, but requires many different independent experiments, including tests that could falsify completing claims. Any conclusions, along with an evaluation of their certainty, are then made on the basis of the overall weight of available evidence. As we build our picture, we sometimes make amazing conclusions that when we first find them, it's not a eureka moment, it's an oh no, what did I do wrong moment. And to come to terms with our own discoveries, which often change our paradigms, we poke at them, we prod at them, and we find other tools. You don't just measure the size of the wall using one ruler, you sometimes grab that laser as well. And as we've come to terms with the age of our universe, we've used multiple different lines of evidence that we find all bring us to one unified conclusion.
What you're saying, too, is that some of those conclusions you didn't want to find necessarily.
Right.
You say, goodness sakes, look at this, and it leads you further down the path.
And it helps us find where we initially weren't as accurate as we thought. For a while, our understanding of stellar astrophysics and our understanding of the expansion rate of the universe led us to data that indicated our understanding of stars wasn't as good as we thought, because the stars are older than the universe. And as we've refined our techniques for measuring both the expansion rate and for modeling how stars evolve, both those numbers now are consistent, and stars are now younger than the universe, which works much better.
Right. I mean, I think back of Einstein looking at the numbers, and it brought him to the fact that the universe began at a point and came out. He just didn't like that because it had a beginning, so he fudged the numbers. What you're saying is if you fudge the numbers, you're going to get caught by looking at other areas, because they're all going to gang up on you eventually.
As scientists, we're required to change our way of viewing the universe when the data says that we're wrong. And that's an uncomfortable place to be. We grow up learning certain things, and as our tools get better, we realize that the conclusions drawn on bad data have to get revised, and we have to change our worldview as scientists.
Okay.
We went on to say, there will often be some data that appear to disagree with the rest of the evidence. This does not automatically provide evidence for alternative hypotheses, but often means that our theoretical understanding is not yet entirely complete. The universe is hard to understand. It's a big place filled with details, and many of them, just something as simple as the convection of oil in a pot, how a lava lamp works. We're still trying to understand the finest details of convection. And as we try and come to terms with everything in the universe, there's going to be places where we struggle a bit. And our initial understanding we know has flaws. We know we don't fully understand the insides of black holes yet. Relativity is still the developing field. But science makes predictions. We know it has value. And we know it's an ongoing dialogue as a community of scientists as we come to understand everything.
Now, folks, if you're listening to that voice, you realize it could melt butter. The fact is, if you think that she ought to be on NPR radio, you have heard her. She did some of the very first astronomy podcasts that were ever done, and she is still doing them, and she just sounds terrific. And so, Pamela, we're glad you're here. Don?
The last part of the statement is that Ross's Hughes arguments provide solid evidence that the universe is billions of years old. He presents several independent arguments based on a wide range of data, indicating that the universe and most objects in it are much older than 10,000 years. This refers back to some of the earlier comments, and we'll probably delve into some more details of that today. The light travel time argument is particularly strong and is particularly simple and based on sound physical principles. This is a statement that's made because some of the issues that are raised in this type of discussion are really extremely complex, as Pamela has noted, and it would take much longer than one has even to do the research, let alone to express it on a public show like this. Faulkner does not produce evidence for a universe thousands of years old, but rather makes claims for isolated inconsistencies in the case for the great age. The evidence is for things that are very, very short. I'll make a comment later about this. Basically track our conception of the size of the universe and the distance that light would have to travel to come from the edge of the universe. So there's a range of ages that one might think of, but there's very little evidence, even with Danny's presentation, for anything as short as a few thousand years.
Bill?
Again, the group wrapped up its statement noting, while it is common scientific practice to look for holes in well-established theories, The new contrary evidence must either be very strong to counter the existing evidence for the theory, or else be supported by a new theory that readily explains both the new evidence and the old. That is, nothing that qualified as a fact, well-supported, repeatable experimental or observational data, can be changed by a new theory, because the theory explains the facts, not the other way around. So when you overturn a theory which has had a lot of successes, either it means that you have much more precise data than you had before, or you're able to get data in some new area, some new regime. Relativity came in because we were dealing with things moving much faster than anything Newton had to deal with, for example. We judge that the inconsistencies pointed out by Faulkner do not meet these criteria. In some instances, the observations are completely consistent with our current understanding of these systems in the context of an old universe. In others, while universally accepted interpretations don't exist today and our knowledge is still incomplete, such explanations are likely to be forthcoming as observations and theory progress. It's our professional judgment that the weight of the evidence overwhelmingly supports a universe that's billions of years old.
All right, now I'm going to have a reaction from our debaters in a little bit, but we've listened to them for 2.5 hours already, and so I want to continue before we get to it. I want to get to the crux of the debate in at least one specific area, all right? And that's your statement that the light travel time argument is particularly strong. Now, this came up in the debate, okay? So if folks have watched the first 2.5 hours, they've heard this. Dr. Faulkner brought this up himself, and he said, if the world is 6,000 years old, then how in the world can we see things from 8 or 10 billion light years away from us? Okay? He said the Andromeda Galaxy, the closest galaxy to us, is approximately 2 million light years away from us. Does light from galaxies billions of light years away really take billions of years to travel to our telescopes? If it does, then you can't escape the conclusion that the universe is 14 billion years old, unless you speculate something radically different happened to time or to the light phenomena. And Danny brought up 3 conclusions, possibilities that the young Earth, young universe folks suggest. Number 1, God created the light in transit, some kind of appearance of age arrangement, that God miraculously brought the universe into existence with this appearance of age, creating the light in a mature form at some point, all right? Number 2, that the velocity of light was somehow different in the past than it is today, that light would have to travel 1,000,000 times faster in the past than it does today. Or that distant clocks in the universe ran 1,000,000 times faster than they do here on Earth. All right? Now, I want to start with this. Let me hear your conclusions. What do you think about any of those 3 options, and why do you feel that light is such a key point here?
Well, Danny's comments and your summary really made the point. There's really good evidence, it's something we've made enormous progress on in recent decades, that we understand distances in the universe quite well out to a certain point. We have multiple interlocking ways. We can see stars of known kinds. With Hubble, we can see stars of known measurable kinds out to hundreds of millions of light years distance. Of course, everybody on the panel is a Christian. That was a stipulation. And the question isn't, did God have the ability to create light in transit with whatever properties he might have found appropriate? Going a little bit outside our brief here, the problem we all had with that idea isn't scientific, it's theological. You know, if the heavens declare the glory of God, they are more than some sort of cosmic digital graphics. To take a concrete example, in 1987, we saw the light from the explosion of a star in one of our satellite galaxies, a Large Magellanic Cloud, which from multiple indicators is about 150,000 light years away. This star, in its death throes, became temporarily bright enough to be seen, as bright as the North Star, for over a quarter of the world's population. This was not a particularly subtle thing. If the universe was only thousands of years ago old, that star never existed. And that's just seems to be a real sticking point in this argument.
Mm-hmm.
You could postulate that the speed of light has changed, and in fact cosmologists have wondered about changes in physical constants. You can't change the speed of light by itself without violating things we see. There are properties of atoms that change if you change the speed of light, because electrons interact with the nuclei by the electromagnetic force. Electromagnetism propagates at the speed of light. There are, for example, patterns of features in the spectra of distant astronomical objects that change if you change just the speed of light. And the constraints on that, I mean, it's an interesting enough question of physics that people have gone off probing this for quite independent reasons, are limits of parts in 10,000 and changes of the speed of light to very distant objects in the universe. If you wonder about clocks running at a different rate in the early universe, that it arouses skepticism because it violates a principle of physics that the last few centuries have taught us to rely on, which is that the laws of physics will be measured to be the same no matter who's doing it and where. This is the whole point of relativity, was understanding how to do that transformation. And you can put together consistent models, but they amount to clocks run at different rates compared to all physical phenomena, which amounts to sort of relabeling time. And again, that's something that goes outside the range of things that would even have an imprint scientifically, because there's no measurement you can make.
It all comes down in large part to the cosmological principle, the idea that everything is homogeneous and isotropic, which is a fancy way of saying if you could get out and look down on the universe, you'd see it as all an even distribution of materials. And no matter where you are in the universe, as you look out, you see the same understandable universe. And that's one of the amazing things about astronomy, is we have the ability to slowly come to terms with what we see. And if what I see here on the planet Earth has to be consistent with what is seen by an observer on the other side of the universe looking back towards us, then, well, first of all, time has to allow the light to get to them. And it disturbs me a bit to think that, well, yes, God knows everything, that my light back towards that alien was also created somehow. And if time is running differently in both places, then how do you make time run strangely so that observers on the other side of the universe both have only experienced a short time, yet are able to see ancient time in the starlight? It's once you start figuring out, how do I make it so that my kindred on the other side of the universe can see and observe and experience physics that I experience, all of these arguments become that much harder to see as being possible.
All right, I'm going to brag about Don a little bit here, okay? He doesn't want me to do this, but I'm going to do it anyway. Dr. Don York is also the founding director of the Sloan Digital Sky Survey. Collaborating with 30 institutions, 300 astronomers around the world, that in 1998 began conducting the largest census ever taken of the sky. The Sloan Digital Sky Survey, if you don't know this, was created to systematically map 1/4 of the entire sky, producing a detailed image of it and determining the positions and absolute brightness of more than 100 million celestial objects. Also records the distances to 100,000 quasars and 1 million galaxies. Now, those might be old numbers, Don, but that's just to say I'm glad that you're here.
Thank you.
And I think you got an idea on this thing of light. Tell me, when you're looking and you're cataloging all of these things out there, do you know for sure what you're doing?
I think actually the point of the Sloan survey was that we wanted to assume we didn't know what we were doing. Now, what I mean by that is that there are many statements that one makes about old objects based on the fact that they're very far away, the light took a long time to travel, but it's very hard to observe those objects. They're very faint, You can see the cores now with our modern equipment, but you can't see the edges, so you really don't know if they look like our galaxies or not. And we took the view that we needed to have a really good reference of the nearest part of the universe before we could carefully compare old objects in the great distances with new objects and really make profound statements based just on morphology, which is what much of this is about, meaning the shape of things and how far apart they are. So we actually took the point of view that we really didn't know, and that we had to have many, many objects to determine what is. In other words, the question is, what is out there? What does the universe look like? Let's just start over again. We've been working on samples of 10 or hundreds and making sweeping statements about what the universe might be like. Let's take it to a different level. That's really what the Sloan survey does. Now, I was telling Bill at breakfast, I've actually done a little bit of thinking about this. How many objects does it take before you know how to classify that object? How many humans do you have to know that you understand human nature? A child knows a few people and doesn't understand much about human nature. A high school student is getting there, but it's really in the college or out in the working world that you start to meet thousands and thousands of people, and then you start to see all kinds of characters. And those characters may in some sense define more about humanity than we realize. If we don't meet them, we don't know that part of humanity. So how many objects does it take? Sloan, as was just mentioned, the Sloan survey measured hundreds of thousands of many different kinds of objects, most of which we didn't set out to find. We couldn't avoid them. They were in the data. And people have taken these results, many of which didn't have to do with our initial goals, so it's what we call serendipitous, taken those results and tried to make new definitions, different kinds of variable stars, different kinds of galaxies, different kinds of stars. I've noticed in the papers that people write that they start with hundreds of thousands or even a million, but then you have to go through and define a sample which is free of any bias of the way we did the survey, of the way humans think. It's all about getting rid of biases and defining what we call pure samples or gold standards. It's usually the case in these papers that people get down to 10,000, having had this very large number to draw from. And then you can start to make statements. You feel comfortable making statements about the nature of objects. 10,000 in a statistical sense means that you're talking about properties at what we call the 1% level. That is the number of objects that are going to be rare. You will have those, but they won't dominate the sample. There will be more rare objects that you couldn't understand unless you had 100,000 objects or a million objects to pick from, just like there are truly rare, I call them 5 sigma people, who are way off scale, and you don't meet those until later on in life. We would love to do that, but we don't have the capability. That would take a survey much, much larger, much deeper than Sloan. But now we're working at the 1% level. I would say before Sloan, in many, many areas, we were working kind of at the 10 or 20% level of precision. Many, many things in astronomy we think we know to what we thought was precision, but actually it's only at the 10% or factor of 2 level. But with Sloan, now we're down to where we can talk about things at the 1% level, and during the course of this conversation, we'll talk about some of the things that we now better understand than we did before.
All right. I love all of this, and I hope you folks do. We're going to take a break. When we come back, we're going to hear from our debaters, how they are processing this information, and get a response from them. So stick with us. We'll be right back. All right, we're back. We're talking with Dr. Danny Faulkner, Dr. Hugh Ross, Dr. William Keel, Dr. Pamela Gay, Dr. Donald York, and we're talking about, does the scientific evidence from astronomy show that the universe is billions of years old or just 6,000 years old? And we're talking about this problem of the light travel time. And Danny and Hugh, you've listened to what these folks have said, both in their statement as well as in what they've said about this first area of light travel time. And Danny, first of all, I am really glad that you're here. And as I have said off stage, that you are the only young universe astronomer who's got a PhD that has had the courage to come on and talk to these folks. And you have a sweet way of talking about things, and we are modeling for the church how we can look at Scripture and sometimes disagree, okay? And you're familiar with the scientific evidence, and you're here to talk about that. So let's have this conversation. And again, I appreciate you here, but how did their opening statements about light, what did you think?
Well, thank you, John, for having me here. I want to thank the panel particularly for the considerable effort and time you spent on evaluating our presentations, and also for the spirit of the statement that you just read a little bit ago. And I want to particularly thank the three of you for coming and interacting. I'm looking forward to our discussion. And I'm going to surprise you by stating at the outset that I share many of the considerations and criticisms of solutions that recent creationists have had to the light travel time problem. I'm in many respects still looking. I see advantages to each one of those three broad approaches that creationists have taken, and I also see problems with each one of them. And I also maybe ought to point out that I think the light travel time problem has been improperly formulated by almost everyone. We concentrate on, let's say if the universe is 6,000 years old, how can we see anything beyond 6,000 light years away from us? But in reality, the stars were made on day 4, Adam came on the scene on day 6, and the nearest star is more than 4 light years away. So it seemed that he couldn't see any stars at all. Adam could not have, unless the light had gotten here somehow in just 2 days' time. So the problem's even worse than usually formulated. And for the past 2 or 3 years, I've been cogitating on this and going in a totally different direction. I mentioned this briefly in our presentations we gave, and maybe I can talk a little bit more about it now, but I've been struck in the last couple of years the fact that creation itself is miraculous. I think every aspect of it is miraculous. And I've been looking more in towards a miraculous sort of explanation. I think changing speed of light, fully functioning universe, different time conventions, slowing down of clocks, those are all, for the most part, mechanistic or physical ways of doing it. And you might as well look for a physical explanation for the resurrection or the virgin birth, things like this. These are not, they are physical events, but they don't have physical explanations to them. So I'm thinking in terms of more of a miraculous approach to this. And again, I share many of the criticisms you have of some of these other solutions people have put forth. And I didn't mean to necessarily imply by my presentation that I liked any particular one over another. I endorsed one over the other. Again, I see advantages and disadvantages to each of those. And you have good points. I've been on record a long time stating that the light travel time problem, I think, is the greatest single problem that we recent creationists have to deal with. And I think dodging it or pretending it's not there or just minimalizing it isn't a solution at all.
Okay, Hugh, you take some of the scripture verses and say that God did fix the laws of nature at the beginning, okay? So this travel time, whatever it is, has got to be a constant. It's got to be a solid one. It can't change. Where do you go with this?
Well, you're right in the sense that the Bible states 7 places that the laws of physics don't change from the cosmic creation event until evil is gone. And we do measurements in astronomy that tell us when we look at distant galaxies and quasars, the constants of physics are the same as what we measure in the laboratory today. And so that would seem to negate the possibility that the velocity of light, for example, was 1,000,000 times faster in the past than it is today, both biblically and scientifically. That would appear to be ruled out. And I do recognize, Danny, that you did acknowledge that there's serious problems with the different explanations. And I appreciate that you're not the only one. I mean, as I look at what young Earth creation scientists are trying to do, they realize that this is a serious issue. And in my talk, I made the point that we can look at clocks in the universe. The universe is not clock-free. There's clocks everywhere. And they show us that the clocks are running actually slower than what they do here on Earth, which is a prediction of the theory of relativity. It's not 1,000,000 times faster. But what I'm seeing in the young Earth creationist literature is they're acknowledging, yes, we do have measurements that make the idea that clocks are running 1,000,000 times faster untenable. The new model they've come up with is that ancient clocks on Earth didn't run at all. There was no time passing at all. But I kind of anticipated that in the debate by pointing out we have clocks here on Earth, not just clocks in the universe, but clocks on Earth, not just clocks that we have today, but we can actually see clocks on the Earth that go back in time and show us that indeed the new speculation that the clocks were running at a zero rate for the Earth before God created Adam and Eve.
Give us an example. What kind of clocks are you talking about?
Well, for example, we can measure xenon isotope ratios, xenon 136 compared to 131. And xenon is a decay of uranium and plutonium, and you get a different ratio for plutonium than you get for uranium. And what it shows is that plutonium must have been present on the early Earth. Moreover, that plutonium must have been decaying at the same rate that it decays today. So that would be a clock showing that the early Earth indeed had a clock that's running at the same rate as we have today. I'm finding the one that lay people most appreciate and easily understand are the deep ice cores. And those deep ice cores actually show us the pattern of the 100,000 year variation in the eccentricity of Earth's orbit. Astronomically, we can look at the orbit of the Earth and realize it's about a 100,000 year period. The deepest ice cores show 8 different cycles, 8 consecutive cycles, meaning that that ice must be a minimum of 800,000 years old, and it's self-calibrating. We can actually see in those ice layers the dust signatures of volcanoes that exploded in human history. So it actually shows that the layers indeed are annual layers. And you can actually see carbon-14 decay in those layers as well. So it calibrates the carbon-14 clock. And so it's difficult to avoid the conclusion that the ice in Antarctica and in northern Greenland is hundreds of thousands of years old. Now, that's not billions, but it does show that it can't be as young as, say, 10 or 20,000 years that young Earth creationists would claim that Genesis 1 teaches.
Yeah. Frame this thing for our audience. The fact is, via the speed of light, how far back do we go in terms of looking at the stars and things in the universe, and how old is the oldest thing, and why do you think it's that old?
Well, I believe that the most distant object from which we can get an accurate measure of the velocity of light is a little more than 12 billion years distance, which means you're measuring the value of the velocity of light 12 billion years ago. And so those who would claim that the velocity of light is 1,000,000 times faster than most distant galaxies and quasars would say otherwise.
What do you think, Danny?
All right, I'm not an expert on this, of course, but I've always been skeptical of these, Hugh, because my understanding is that there's a lot of thinning at the bottom of both Antarctica and Greenland.
Yeah, because of the pressure of the ice.
Right, but you have the vast majority of the thickness is actually encompassing only a few thousand years. And those several 100,000 years are represent a very tiny amount of the thickness. And I'm not so convinced that it's all from compaction. And I think the people like Larry Vardaman who studied these ice cores believe that those single lines happening once a year are actually a number of events taking place over a few days.
Well, they do that by pointing to ice cores in southern Greenland, where you've got remelting that takes place during the winter, which is why they do these cores in northern Greenland and Antarctica, where you don't have that melting, which means you really are looking at annual layers. And of course the layers get thinner and thinner as you go deeper and deeper because of the ice pressure. But I think there's a sound argument that they really are annual layers.
My point is, though, that I believe that there is a recent creation response to that. Larry Vardaman and a few of his colleagues have written quite a bit on this.
Well, I've read their material, but I don't think they're interacting with the actual ice cores. They're pointing to data in southern Greenland, which I'd argue is irrelevant to the case that's being made.
It'd be better to have Larry Vardaman come on the show and talk about that, probably.
Right, and then you've still got the problem that you've got the imprint of the cycles of the variation of the eccentricity in Earth's orbit.
All right, let's jump to a topic that I think is related to this, all right? And that is that during your debate, you denied that you believed in the Big Bang.
Yes.
And you're saying the Big Bang happened 13.7 billion years ago. I want to ask our astronomers here, the fact is that you were talking about the evidence brought you to conclusions many times that you didn't want, okay? And it seems to me that the Big Bang has got to be the all-time conclusion that the astronomers and astrophysicists did not want to find, okay? Starting back there with Einstein, who actually figured out what was talking about, and this started with a beginning, and that sounded too much like Genesis 1:1. So he fudged the numbers on the cosmological constant, okay? And later on said it was the greatest scientific error of his career, all right? What I'm saying is, do you feel that the Big Bang, that the scientific evidence continues to pile up, that it actually took place, that it accurately describes what happened at the beginning? What do you think?
This is actually a good example of how science has to work, because we are not handed the answers. We don't have the back of the book when we're doing science. We start with fragmentary data, ask what range of explanations, basically to guide our next measurements, our next observations. And what has given the so-called Big Bang cosmology so much traction is that it accounts at once for a very wide range of things that might otherwise need separate explanations. The fact that we see spectral shifts in galaxies increasing with distance, the cosmic microwave background, the relative abundances of certain elements in places in the universe that should have had minimal interaction with anything else. And it does a good job of accounting for everything we see, traced back to a time of only minutes after the creation. So at that point, remember, the Big Bang doesn't talk about an explosion at some point. It talks about a universe originally in a state of enormously high temperature and density we can't yet reproduce in the laboratory. Space itself expanding at that point. Time existing only after this happens, because space and time are linked. And watching how the history of the universe, the successive appearance of the things that we see, would follow from that. And even astrophysicists who, as you mentioned, didn't like this idea because it would bring them to have to deal with the question of, why did this happen? And if the universe only happened once, why? And why is it that it's so fit for complicated life? Have been driven to ideas that share more and more of these features, because that's been the most economical way to account for this very wide range of data.
Don, you've been working with this background radiation of the universe forever, it seems. Tell me what you found and why you think that this explosion, this creative event that brought all of space, matter, time, and energy into existence happened back there about 13.7 billion years ago.
Okay, so I don't work on cosmic background, so let me just make a few comments, but aimed at what you're saying. First, just to emphasize what both Pamela and Bill have said. It's important to realize that scientists don't take a conclusion like the Big Bang or like the reflection of the motion of the Earth as seen in the ice cores as finished once an answer is out and a paper is out. Enormous amounts of energy and time and money go into pushing things to the next level of testing. People now talk about precision cosmology, which is down in the better than 1% on every parameter, reflecting back on my comments about types of galaxies. In the case of the Big Bang, you're right. It's the conclusion that nobody wants, and it's not infrequent in an after-dinner, after-day discussion at dinner for people to just say, scientists to say to each other, how could this possibly be? We're talking about things going on in 3 minutes that affect all of cosmic time, 14 billion years. So we're constantly asking and constantly testing. There's an enormous amount of energy now going into telescopes at the South Pole that will test this. We're talking tens of millions of dollars. There's satellites being put up to make the next level of precision measurements on the cosmic background radiation to find new things which have been predicted. That's what we do. And to try to confirm that they're true, these projects run into $3 or $4 billion. And all those dollars reflect minds, many, many minds dedicating their lives to this kind of thing. So nobody takes this lightly. Nobody is going to let the Big Bang sit on the table untested. And we are testing, with every dollar that we can get from the government and every minute that we can steal from our teaching, our families, whatever we have to steal from. That's how we spend our lives. I want to just introduce one new element now, answering your question about why I'm answering the question why I think the universe is old. And to do that, I think that you have to look out into the universe and look for confirming pieces of evidence that seem to be true everywhere. Reflecting on the ice cores, which I like that example, and I will add to it a new dimension that yes, there's Greenland, yes, there's Antarctica. There's an enormous amount of work going on now, which has brought many, many nations of the world together in agreement that this problem has to be solved, trying to make the age determinations at the 600,000 year level consistent between Greenland and Antarctica and answer just the questions that are being raised here. So there's enormous international effort at the South Pole because the South Pole layers go much, much deeper than those in Greenland. Right? So you see for several 100,000 years in two different completely independent parts of Earth the reflection of these motions. Some problems come up at a certain level, and so you ask a new question, you spend more money, you put more lives at stake, if you will, and you go pursue that, and that's happening now. It's one of the largest international collaborations that I've seen. I think it's wonderful. With regard to the universe, Sloan has now shown us, based on the large number statistics that I just mentioned, that when you look in every direction, you see certain signatures which are the same everywhere. And as has been said, the laws of physics, the way we formulate them today, have to apply everywhere or they don't apply. So among these are the peaking of the number of quasi-stellar objects. These are massive black holes at the cores of galaxies. They peak in time. We can see them getting more and more numerous up to a certain distance or look-back time, and then they disappear. This number is the same everywhere. We've discovered, much to our consternation, that the actual age of a galaxy, some galaxies before they burn out, is much younger than we thought, but it's in the sense that they're really, really active right at the beginning. They turn everything they have into carbon, nitrogen, oxygen in a few billion years. For our Milky Way, it's taken millions of years for that to happen. That phenomenon is seen everywhere in all directions around the universe. We just can't find any place where you don't see completely uniform nature of these truly cosmic events. Now, having said that, this reflects on the comment about the cosmological principle. There are scientists today who say that we can test this principle, this uniformity of things happening everywhere, the speed of light being the same everywhere and so forth. We can test that in great detail in azimuth, looking around the sky. It's much harder to do it in the radial dimension. And maybe there's something beyond what we think of as the edge of the universe, which is actually affecting the inner, what would be the inner part of the universe. So that is a lot harder to test, but on the other hand, a lot of people are turning their attention to that. It's true that throughout time, the cosmological principle throughout the 20th century, cosmological principle was postulated at each new step. So we postulate it when we think the universe is 30,000 light years in size. Then we think that's not true, the universe must be bigger. So now we go postulate it again and say that everything has to be uniform in all directions. And we test that exhaustively. Many, many lives have gone into testing that. And it works. And so now we go to a new dimension. We keep testing and testing. It hasn't been tested on the largest scale possible because we don't even know what the largest scale possible is. And it's possible there'll be some great surprises. There'll be some non-uniformities that show up, which reflect back on what we think about the universe the way it is now. But we give the best answer that we can based on all the data that we have. and we can't speculate about what's out there further. We have to go find some information about it. So
Let me
those
ask
are my
you and
arguments.
Pamela for kind of a personal kind of wrap-up statement in terms of the Big Bang. Scientists are always looking for evidence. Is the Big Bang a real good start in gathering evidence for defining what a miracle is?
One of the truths about astronomy is we can't address the question of what happened before the Big Bang. We can't address the question of what caused the Big Bang. And the fact that our universe is capable of supporting human life is something of a miracle. If you change any of the many parameters that define physics by even 10% or less, sometimes by only 1%, it changes how the entire universe changed over time, how quickly galaxies formed, even if you could get to galaxies before the entire universe collapsed in on itself. Or if you changed it the other way, did the universe simply drift apart with stars never forming? That we live in a universe so finely tuned for humanity. It's referred to as the anthropic principle, and there's only 3 ways out of it. One is that there's some underlying physics that we have yet to define that says these parameters have to be this way or physics doesn't work. We don't think we're going to find that. The other way to get out of it is to invoke multi-universes and simply say that it was a cast of the dice, and if you create enough universes, you eventually get life. But that's a cheap man's out in some ways, because how do you get all those universes? And the only other way out is to say there was an initial cause. There was something that tuned our universe. It's a hard way to look at it, and science can't answer these questions. We can't test if there's a multiverse. And with the Big Bang, this is an amazing story of the predictive power of science. What makes something a scientific argument is not only does it explain all of the observations that we currently have, but it also makes a prediction. When they first discovered, looking at 25 or so of the nearest galaxies, that they weren't randomly coming towards us and moving away from us, but were rather almost consistently moving away from us, it changed everything. We'd expected a static, steady-state universe. And so Hubble did work to carefully quantify what does it mean the galaxies are moving away. And he realized we have an expanding universe. And the theorist stepped in and said, well, if we have an expanding universe, then... And they made a whole series of predictions. And then we found the cosmic microwave background, which fulfilled a set of their predictions. So we started to fill in more details. And the theorists came back and said, well, and based on this, we have these different options. And then the Wilkinson Microwave Anisotropy Probe, WMAP, came in and said, here's the data. And we knew this set of theories was now correct. And at every step of the way, since that initial discovery that the universe is expanding, the theorists have come in and explained the data and then made predictions that were fulfilled by better data that came from better instruments being made in the future. And it's that predictive power of our understanding of the Big Bang that makes it hard to deny, based on all the lines of evidence, that the data points towards a Big Bang.
Don?
I told you yesterday that the Big Bang is certainly a miracle. I don't think Danny's statement is. I think it applies to any way that you could come and create the universe. The question is whether you apply whether you appeal to evidence to explain how that happened. You can ask separately, do I need to know how that happened? But if you need to know, then you have to go to the evidence, and we're spending enormous amounts of time on getting that. My original research topic was the uniformity of the abundance of deuterium in the universe, which is one of the elements that was being referred to a while ago. And I could only test things very close within the galaxy. But now, with the study of quasars and the very large telescopes, the number that I got has been completely confirmed. So this didn't have to be that way. It's just the way it is. It's the result of many, many years of study, and now we realize that deuterium is uniform throughout the universe, and we have not thought of a way to explain that if it didn't come from the Big Bang. On the other hand, it's a natural outcome of the Big Bang. The Big Bang is not complex. It's actually very simple because you start with something that's just so hot that everything is all homogenized, and then things happen because of dark matter and so forth and so on. So yes, I would say it's a miracle, but it's a miracle that I would love to understand in detail how it happened. And maybe it will happen someplace else in another multiverse. That's fine. That's the way things were made.
Hugh, you want to comment on what you heard so far?
Well, I appreciate the predictiveness of the Big Bang cosmology. That to me is very impressive, how over the past 60 years it's consistently proven successful in its predictions. And I also appreciate that young Earth creationists have been looking at the predictiveness. I mean, what I'm seeing in the latest young Earth creationist literature is, well, inflation is not correct, or there is no dark matter, or there is no dark energy. But I think today we've been able to show that dark matter is real. It's a dominant component of the universe, and dark energy is even a more dominant component. In terms of inflation, well, we're about 99% certain we live in an inflationary universe, but that's not enough to convince us, which is why we have the Planck satellite orbiting the Earth right now. And we're all looking forward to what that's going to say about our ideas about inflation. But yeah, our Big Bang model predicts that there's going to be an inflationary aspect to the universe, and so we'll have an opportunity literally within a year or two to see whether and how well the Big Bang has fared in making yet another prediction. But the point is, it's proven consistently successful in all the predictions that have flowed out of it. And if I could just say something, it was a big factor in my coming to faith in Christ. You know, reading the Bible alone without any contact with Christians, and realizing the Bible thousands of years ago taught that there was a beginning of space and time, that it was continuously expanding under constant laws of physics, where one of the laws is a predominant law of decay, which is a universe that must get colder and colder. And being a young astronomy student, I said, this is the only holy book I've ever read that predicted Big Bang cosmology thousands of years before anybody discovered it. So that was a huge factor in my signing my name in the back of a Gideon Bible at age 19.
Danny, when you look at the persuasiveness of the science that's come so far, and you know, I remember when the scientists that got the conclusions from the Kobe satellite went on Ted Koppel and announced it on ABC, that Ted Koppel opened that program in terms of what they had discovered, and he said, in the beginning, God created the heavens and the earth. And the scientists came on and quoted the next two verses. What I'm saying is that this scientific evidence that came out there doesn't seem like a lot of the scientists wanted to go that direction. They fought it every way they could, and it kept bringing them to the fact that the universe began, it's not been here forever, and there had to be a cause outside of space-time, matter, and energy that brought it all into existence. And that seemed to look like God too much, the God of the Bible. Now, you don't like that theory, do you?
No.
Why not?
I don't think it's biblically sound. I don't think the Bible teaches that, in deference to disagreement with you on that. It's no secret we disagree upon all of that. The belief in an eternal universe goes back to the ancient Greeks, and I've been very curious that while science came about in the 17th century, primarily through Protestant Christian influence, this idea of an eternal universe persisted. Many people 300 years ago believed in an eternal universe, but believed in a much younger Earth. They were old universe, if you will, young Earth creationists. And it was that persistent belief in eternal universe that was really the problem in the early part of the 20th century, when Einstein predicted, or was able to, did predict the expansion of the universe, later confirmed. It was Lemaitre, who was a theist, was a Belgian priest who wanted, he saw Genesis in this, but Einstein and others didn't see that. And some of it was coming from their atheism, from their agnosticism. In other respects, it's coming from their philosophical predilection for 2 millennia. It's kind of hard to start thinking outside of the box, and I think that was a large part of the problem. And then many people are, Lemaitre saw it in a theistic way. I think many other people see it in a theistic way, but there are plenty of top cosmological theorists today who steadfastly refuse to believe in anything beyond the physical. They believe the Big Bang is the ultimate uncaused cause. That's the reality of the situation. That it doesn't necessarily result in people seeing God behind it at all. There are attempts. Stephen Hawking just came out with a book recently dealing with this very question. I've not really had a chance to read the book much yet, but I think maybe the press was a little over the top on what he supposedly said. But I'm aware that he's at best an agnostic on this, and there are many others. So I don't see that necessarily the Big Bang is God's method of creation. Again, biblically, I don't see it.
Bill, what would you say to that?
Well, one of the points that I think the viewers should take away is that we will all get up here and affirm that the creation of our universe was a massively miraculous event. And what we are discussing is what the physical evidence now available can tell us about how that happened, what we would have measured with our instruments at that time, or what we would have seen. So what's at debate here isn't, was there a miraculous creation of the universe? It's what were the details for those of us who care about such things.
Yeah, I mean, Hawking basically said this. He said that that almost everyone now believes that the universe and time itself had a beginning at the Big Bang. Now that's a step forward in terms of where a lot of people were at, that we had a full start. And if you had a full start, then you have to say, what caused the start?
You have to face that question, which you might not have had before, but the data do not give you the luxury of saying, well, I don't have to worry about where this all came from because it's already been here. That's not tenable for many reasons.
Hugh, I had on the program the world's foremost philosophical atheist for 50 years, okay? Dr. Anthony Flew. Mm-hmm. And when I had him on the program, he was speaking for atheism big time, all right? And I corresponded with him. We did a program on the resurrection. Was that a miraculous event? Was there historical evidence for it? And we had a great time in terms of talking, had a debate with Dr. Gary Habermas. But as we went along, I remember reading, he says, to believe there is a God, we have to have good grounds for the belief. But if no such grounds are provided, there exists no sufficient reason for believing in God, and the only reasonable position is to be an atheist or an agnostic. But I was really happy when in 2004, the Associated Press broke the story, the world's leading atheist now believes in God. And in his book that he wrote entitled, There Is a God, he says, after 50 years, he says, I now believe that the universe was brought into existence by an infinite intelligence. I believe that the universe's intricate laws manifest what scientists have called the mind of God. I believe that life and reproduction originate in a divine source. He says, why do I believe this, given that I've expounded and defended atheism for more than half a century? The short answer is this. We must follow the evidence wherever it leads. And he says, this is the world picture, as I see it, that has emerged from modern science. Now, I'm telling you, if you knew Anthony Flew, and if you heard him argue in those debates over those years, and he led the philosophical movement against God, basically, to hear him read this and to hear him expound that the scientific evidence that you fellas and Pamela ladies that have found, all right, brought him, this hard-nosed fellow, to belief in God. To me, that's pretty amazing stuff. Wouldn't you say that this evidence seems to point that direction? I mean, even if you might not like it, wouldn't you say that it seems to point that direction?
I can see why people like Anthony Flew are suggesting. Did he actually come to a belief in God, though?
He came to a belief in theism. He did not come to a belief in Jesus. He was looking at Jesus next, but he came to a belief in God.
So what I'm concerned about, John, is many people write, Stephen Hawking does this, I think Paul Davies does, they talk God little g, and what they mean by that is nothing like what I think people in this room understand it to mean. It's this very uncanny order behind the universe. They look at the universe and they marvel by this. There's a famous quote attributed to Einstein, the most incomprehensible thing about the universe is that it's comprehensible. And I think someone like Isaac Newton would have slapped him upside the head and say, well, duh, that's the whole point. That's what we expect from a Christian worldview. I think people like Flew and Hawking and others have a difficult time explaining this order we see in the universe through a theist, to a Christian at least. You expect to see that sort of thing. It's all what you expect to see and what you want to see. And I don't think Flew was...
But the deal is...
Was he really believing in a transcendent creator? I don't know if he was.
Yeah, but here's the thing that I'm seeing, is people like Flew did not want to believe it.
Yeah.
Okay? And it brought him over the line.
And Flew is not alone. I mean, there's a number of scientists who held to an atheistic worldview perspective who've become full-blown Christians, not just theists, but followers of Jesus Christ. But what's interesting is that when you interview them, they consistently name 4 pieces of evidence that brought them across the line from atheism to belief in Jesus Christ. One was the origin of the universe and the need for a transcendent causal agent. Number 2 is what Pam was already discussed, the anthropic principle, how we see all this design in the universe for the benefit of humanity. Number 3 is the origin of life. And number 4 is the origin of humanity. I find it interesting that that's exactly what Anthony Flew named as the 4 pieces of evidence that brought him across the line. And so it's not just a matter of, well, if the evidence is compelling, all the scientists in the discipline will believe it. Romans 1 tells us that there's an inherent rebellion within each of us that resists the idea of a God that would be in personal authority over our lives. So, as I attend Origin of Life research conferences, I see that there's predominantly atheistic worldview perspective, but there's also a frank admittance that they can't explain the origin of life from a naturalistic perspective. And I think we see that in Big Bang cosmology. I agree with your statement that many people who are Big Bang adherents are not followers of Jesus Christ. Nevertheless, they admit the compelling philosophical implications that come out of Big Bang cosmology.
All right, we're going to take a break. We're going to pick this up again, and we're going to ask our scientists here for an opinion going the opposite way. Give me your best assessment of the evidence for the young universe view. All right, we'll talk about that when we come right back. Stick with us. All right, we're back, and we're talking about, does the scientific evidence from astronomy show that the universe is billions of years old or only 6,000 years old? And you've heard that my guests are Dr. Danny Faulkner, Dr. Hugh Ross, Dr. William Keel, Dr. Pamela Gay, and Dr. Donald York. And we're going to pick up in this segment here, and we're going to talk a little bit more specifically. Give me your professional assessment. If you weren't Christians, if you weren't anything, okay, you're just scientists that are looking at the evidence. Is there any evidence for believing that the universe is 6,000 years old? Bill, start us off.
This won't make me any friends, and I may have to return to Alabama with a bag over my head. But there's no compelling evidence that I've ever seen for an age of the universe around 6,000 years as opposed to much older than that. There are interesting arguments that the current mainstream consensus view may be missing something serious about the history of the sun or the history of the Earth-Moon system. But none of these point to such a young age if you're coming at it purely from a broad brush, what is the science evidence perspective?
Okay. Pamela, what about these anomalies that we've been talking about every once in a while that do they persuade the overall picture that we ought to change our mind the universe is really, say, 13.7 billion years old?
No. One of the things that you have to constantly remember is science is a process. It's a story being told through the scientific journals. We find new things every day, and we have to continually add details to our picture, and occasionally the stuff that we put in there without having complete understanding we have to erase. Descartes explained that the origin of sin came in acting beyond full understanding. Well, occasionally our theories do that. They act beyond full understanding. And it's only as we look more and more at the universe around us, the world, the earth, even the dirt and rocks around us, that we're able to realize, yes, we still have an incomplete picture. Yes, occasionally our conclusions aren't quite right. But if we just keep digging, we'll fill in those gaps and we'll fix those anomalies to build that complete picture of an old universe.
What is the strongest piece of evidence in your mind that the universe is old?
It's, as a scientist, I look for things where there's multiple lines of evidence. And for the universe, it comes down to the theory of Big Bang evolution is able to look at the hydrogen-helium abundance of the universe, the existence of the cosmic microwave background, the change in what is the layout of galaxies with time. As we look further and further back, things are less clumpy, and they clump up as we move toward today. As we put all of these progressively more detailed ideas into our theories, new predictions are made, and every time we see that new line of evidence played out. And even within our own solar system, looking strictly at geophysics, we see evidence for a solar system that's between 4.5 and 5 billion years old. And it's echoed across each of the rocky worlds and rocky moons in our solar system.
Mm-hmm. Don, what do you think?
I don't know of any evidence that I would take seriously for a young Earth, or by extrapolation, a young universe. I think it's true that if you have one strong piece of evidence, that is something everybody would at least say, yeah, I have to think seriously about that, then arguments for a young Earth aren't consistent with that, and so you have to get rid of those. You can't, you'd have to have all the evidence pointing towards a young Earth, because there are many ways that you could think it was young, that everything we think is what we can measure, what our ancestors, what our predecessors could measure, et cetera, and that only goes back 6,000 years, so it's not unusual to think about a young Earth. But if you have one good argument for an old universe that's completely consistent with all that we know about the supposed young Earth, we just don't know everything. So so if you had lots of evidence for a young Earth, you would have to not have any evidence for an old Earth, and the reverse doesn't apply.
In your presentation, Danny, you pick out the one thing that is the strongest piece of evidence you think for science pointing toward a young universe.
Well, a portion of the universe, not the universe as a whole, but a portion of it. I think the tidal evolution of the Earth and the Moon together indicate very strongly that the Earth and Moon have not been orbiting one another much more than 1 billion years, which is...
I keep worrying about when you say that, those kinds of things. That's not 6,000 years, and that's what we're talking about.
And my presentation I dealt with that. The argument I put forth there is that many age estimates are upper limits that you put on things, not an actual firm number. I really am skeptical many times of the precision we offer many times in science, not just on dates, but many other issues. And my point is that we've got two extremes: 4.5 billion years for the Earth, Moon, and a few thousand years for the Earth, Moon. And what does this one indication say? It seems to rule out anything longer than 1 billion years. I agree with you. It doesn't say automatically 6,000 years. If someone came in with a 900 million year old Earth, that I could be discussed in that context, but that's not on the table as far as I can tell.
Yeah, but just to, I'm not trying to take away your time, but
no, go ahead.
You argued the other way for Kelvin. You said why would
the Kelvin Helmholtz of the
30 billion years?
That's an upper limit as well.
That's a lower limit if you believe Newton gravity.
Right.
A lower limit? What do you mean by a lower limit?
That you can't have anything younger than that in a natural formation process. You can
have
have lots of things older.
All right, in a natural formation process, but you could argue that's arguing that the gas from which the sun formed was, to a first approximation, infinitely distended and came in. But if it started halfway out, 1/4 of the way out, that's what I mean by being an upper limit. If you start from a large gas cloud contracting down to the sun it is now, that is the limit you would get. But you could start the sun smaller than that at some point if the sun is powered by Kelvin-Helmholtz.
The Kelvin-Helmholtz timescale doesn't depend on a very large gas cloud. There's a term in there that
Right.
the radius can be big and not huge, and it's
my
still
point
the right
was,
limit.
if you started with the sun, say 20% larger, God created the sun 20% larger than it actually is today. And I was talking about in the context of late 19th century, by the way, not 20th or 21st century physics. Then it was an upper limit in the sense that if you started with a sun that's 10 or 20% larger than it is today, you would end up with a lifetime far less than 30 million years. And if the sun started off 6,000 years ago, we're deriving its energy from Kelvin-Helmholtz, then again, that's an upper limit once again.
Well, Danny, I've read your material, and you're not saying that the sun cooled down through gravitational collapse.
No,
you're actually
not at all.
arguing that
Not at all.
the sun burns through nuclear fusion.
Yep.
So in one sense, that argument is irrelevant
But
to your case.
my point in bringing my presentation was about what people thought the age of the sun and the Earth were back in the end of the 19th century. That was my illustration there.
To return to the Earth-Moon scenario, in your presentation you discussed how it was a matter of a simple differential equation to get at the evolution of the Moon's orbit as it moves further and further from the Earth, as has been observationally measured with the 30-inch, actually, not the 107-inch, out at McDonald Observatory. And one of the things that concerned me about this is, if you look at the orbits of the other planets, there's actually all sorts of different gravitational interactions, and there's also changes in the moment of inertia of the planet Earth as the plates move, as our planet is in constant flux. And while there are indications that the Earth was had an 18-hour day in the past, had a 22-hour day in the past, as we look through the past many 100,000 years of geological records, we still, if we take into account all these different changing factors, can get at a moon that formed 4.6 to 4.5 billion years ago.
From tidal interaction?
From tidal interaction.
Yes.
But you have to take into account the gravitational pull of all of the other planets. Yeah. You have to take into account the change in the moment of inertia of the Earth. You have to take into account our planet and the moon weren't always solid.
But we don't know what the moments of inertia were back then.
No, I think the argument, Danny, is you get the 1.6 billion year date that you talked about.
1.3 billion.
Okay, 1.3 billion.
Using the current boundary condition on the problem.
My point is it's model dependent. If you assume the Earth-Moon system is a two-body system where the both point sources, you get the number you quoted. But we know that's not true for either the Earth or the Moon. We have to use a more detailed model. And use that more detailed model, you get an age that's much greater than the 1.3 billion.
I think one of the things that sort of downplayed this argument when the panel was discussing, which took quite a while because we didn't actually have any geophysicists, so we were reading a lot of stuff up, was first, this is a subsection of the universe, and being astronomers, we're allowed to think that the Earth might not be the most interesting thing. But also, coming back to some of the points on dating methods, you want to pick as a clock a system which is as simple and free of external influences as possible. And there are, for example, studies of what motions of the continents would do to the strength of the tidal coupling between the Earth and Moon. And I would never have thought that that moving the continents around would change what you could think of as the tidal friction of the oceans nearly as much as they show. So that, and when you're extrapolating as 1/r⁶,
But
that to me that in our minds balloons the errors on trying to run that back and learn very much.
I think that I looked at Danny's presentation on the plane down yesterday, and many of the criticisms that you just mentioned he actually refers to. He refers to the continent's drift and so forth. I think the problem is the model dependency, because what you were asked was, what is the evidence, the strongest evidence. And as soon as you have to put in a model,
Yeah.
then there are problems.
But
And
we
error
almost
bars.
always have to put in a model, even if it's such an obvious model that we don't think we're doing it.
That's right.
But
a Newtonian model.
the simpler the model that you can account for the relevant parts of the data with,
Right.
the better the odds that you manage to get all the pieces of it right, the fewer external factors.
Yeah, are you saying that basically with all of the pieces that you know at this moment, when you put those into all of your figures, that number doesn't come out?
Yeah.
Or that the error range on that number extrapolates back to become quite large. And actually,
talk about that,
Danny
Bill.
brought up a
what
point
does that
here.
mean when you talk about how close are we to being sure about it versus how much of an error is in there?
Yeah, this is an important point that Danny brought up. And one of the ways I phrase this to students about the role of error in science is there's this huge irony in how much of our most precise knowledge about the universe comes from relentlessly looking at ourselves to find out by how much we could be wrong.
Yeah.
We're getting better through statistical treatment and having digital detectors at knowing what the certainty range of our measurements themselves are. You can do repeat measurements, ask at least how well do we know this quantity. Then, we always have to ask how accurately do I know the physical situation that I'm applying that to when I try to derive some more interesting number. The things which are undeniable facts in science are generally pretty boring. The result of this measurement taken 10 times was thus and such with a certain range. That's not usually very interesting. What does that imply about the age of the universe? That's a more interesting thing, for example, or the expansion rate of the universe. And science is full of cases where we didn't fully track the uncertainties in that process. So you get a number with a stated error, and more accurate observations later didn't agree with that. So you find out that. So you really have to watch out as human beings is making sure that you know how wrong you could be about all these
Let me give you an
issues.
example. I think it's in the November 10th issue, the Astrophysical Journal. A group of astronomers published an age, astroseismic age for a star. And they got a 1% error bar on the age of that star. But then they went into all the possible models that would fit that measurement. And they published that it was 15%. So they determined that the age of the star was 6 billion years, plus or minus 15%, when you consider the entire range of possible models that could explain the phenomena they were observing. But their actual measuring error was only 1%.
How does that break that down for our people? Does that mean that we're close in terms of Danny's close to being right, or is he close to being wrong here in terms of the dates that he's giving for
Well, that
young
particular
universe?
paper, at best, the age could be 15% less than 6 billion.
Okay, so the closest it could be would be what?
Well, take 15% away from 6 billion, which is 0.9 billion. So 5.1 billion would be the minimum age in any possible model for that star.
All right.
But
So
if you come back to Danny's example, the worry we had is that these uncertainties in changes in the structure of the Earth and Moon, changes in the shorelines, which is where some of the connection between motions of the Moon and rotations of the Earth happens. When extrapolated back over such huge changes in time, there's a serious worry that beyond a certain point in time, we have no clue how to track those back. And,
Like
the effects are
reorientation of
small.
continents. If you change the continents from north-south to east-west, it makes all the difference.
would you agree, Danny? I mean, you know all this information, and you've had to factor some of this new information into what you've been saying. Would you agree?
With what?
Would you agree that the new data and the stuff that you would have to put into your model would make the numbers rise?
There's no new data. As I understand it, the inverse 6 power function, that's the physics involved. I think that's beyond dispute. There are other factors. I think the main factor, from my reading, is that it is the location of the continents, distribution of the continents, And that's the sort of thing we can't even really model. I don't think our models aren't that good to do that. Even if we could, we don't know where continents were in the past, at least in the very distant past. The 4 centimeters per year rate that's been measured, that fixes what the continents are doing today. Hopefully, if we could really model this in detail, it would then predict 4 centimeters. I don't think we can do that, but that maybe one day we can. But my point is that that's the actual data. So when you hypothesize that in the past the continents were in a different distribution so that it made for a much lower tidal interaction rate, I acknowledge and I raise that issue, that possibility, but don't call it data. That's simply throwing out a possibility.
The data we have are the Earth and Moon as they are today, and the changing separation.
That's right. That's the data. We only have one point to work with.
Right. So the concern was that we have other reasons for thinking that continents move around. Apparently, if you have a really good GPS, you can measure that now.
Yeah.
And there have been simulations showing that innocent-looking motions of continents, or even bodies of water opening or closing, could have a much larger impact on this than I would have thought intuitively.
We can actually measure the change in the Earth's rotation that was created by the large dam that was built in China and the subsequent lake that formed behind it. The fact that one admittedly large man-made object can change how our planet rotates is profound, and over the eons of the Earth, much more dramatic events have occurred between the movement of the continents and the opening of rift zones that have subsequently filled with water.
I mean, that's the explanation I would expect. That's the explanation that people give, is that the change of the continental distributions and the upper mantle of the Earth. But don't call it data. Call it the surmising that's what's happening.
This is a concern of processes that we see going on now that could expand the error envelope of the behavior as you trace it back.
And we do have data over the past 250 million years. I mean, we have a pretty good idea where the continents were, what the elevations were. We actually have measurements with coral reefs and what the rotation period of the Earth was. So I would agree, we don't have good data back 4.5 billion years.
But I've examined those papers too. They have data I've seen 900 million years into the past, and they're consistent with the current rate.
I'm talking about the last 200 million years. That's where we got, I think,
but I'm saying from the literature I've looked at, they're claiming 900 million years.
That is the rate of tidal recession.
Yes, consistent with the rate that we have today, consistent with the physics we have today, and what it amounts to is in a 4.5 billion year old paradigm, you have to believe that with all the continental shifting we've had over the past 900 million years, that it all totals up to an extremely or unusually high tidal recession, and that blows my mind. That in almost 1 billion years we had all this very high tidal recession, but the previous 3.5 billion years had very little, given the fact that the continents were supposed to have moved around tremendously over the past 900 million years.
But none of this calls into question that the Earth is older than 200 million years.
Well, I think if you look at what I'm saying here is if you look at it in terms of the literature on the varves and the 22-hour rotation rate in the past inferred from that, and the length of the month inferred from that, it is saying that we've been living an unusually high time of tidal interaction for 900 million years. And that's sobering. It really undercuts what you're trying to say here with the moving of the continents. You're going to tell me that for 900 million years the continents have conspired to move in a way so that it maintains that high rate?
Well, it's a high rate primarily because you've got the continents oriented the way they are, the sizes
for 900 million years.
No, I mean not for 900 million years.
Well, that's what I've read in the literature.
There is the data which is anchored in today, and if you use all of the human records, you might get data back to 6,000 years, but no further than that.
More like 2,000.
That's a fact. That's a set of facts. And then you have the issue of what could have be. What could be. Yeah. I mean, life is full of possibilities. The universe is full of possibilities, and so forth. And to publish a number or to address a certain argument, you have to have the data, and then you have to to use the largest parameter space that you can think of in terms of what could be possible, and evaluate the full range of errors, given as many of those things as you can do. Now, in a computer, you can do millions, so it's not an issue. So you can develop the error bar, and I think that's important. The second point I'd like to make on what you just said is that, and this is also a commentary on your presentation, the scientific process absolutely requires that everything be written down, it be in public, and anybody can ask questions about it, and all those questions, they can't be answered maybe, but they can be addressed. And I don't know, just because of my ignorance, when you refer to certain buzzwords or certain people, I don't know where to go to find those papers, and I don't know how thoroughly those papers are refereed. So I think it's extremely important to say, like you just said something in literature about 900.
Yeah.
It's important, even in an informal discussion like this, to give a reference. And then, then I can take that information, which I am ignorant of. I spent my life focusing on
A good point. I don't have it with me today. I have it in my files at home, but it doesn't come from creation literature. It's coming from geophysical and geological journals, things like this.
That's very important, because that stuff is peer-reviewed.
And Don, I appreciate your point about mentioning the contingencies, and I think I've attempted to do that in my presentations, always dealing with this and other methods.
It has to be written down and put in a peer-reviewed journal so that people can look at each piece of it. I think that's the important part.
And you weren't claiming this was a compelling argument for a young universe. You were just simply saying, this is something that's not well understood.
Not well understood.
Well, I'm saying I think it's a good argument for at least a more recent origin for the Earth-Moon system than most people would think.
One of the things that we deal with constantly in astronomy is coming across things that are complex dynamical systems that last unexpected amounts of time. Saturn's rings are an excellent example. As near as we can tell, they're being constantly renewed and are going to be allowed to last for a long time by one set of theories. But by another set of theories, they're only going to last for 600 million years.
Or 1 million.
Yeah, and so these are complex situations dealing with multi-body problems that we're still learning how to deal with. And I think the Earth-Moon interaction, where we're dealing with evolving planets, movements of all across the solar system, not knowing necessarily how many big rocks hit the Earth and hit the Moon and had effects of their own, this is one of those places where the error is so great that we have to acknowledge different theoretical models will get you at different answers. And until we have a better data set, all we can say is this is one of those places where dragons live. And we need to keep working to solve these problems.
Because, it is just a bare fact that we have this Earth-Moon distance, this change in the Earth's rotation rate, this recession rate for the Moon. And if you do the straightforward extrapolation, you get this number, and something needs to be looked at there.
And need to clarify, too, what kind of extrapolation you want to do, because some people have attempted a linear extrapolation with 4 centimeters per year. Almost. And that's not a problem. So it's when you say extrapolation, many times I've talked to people who've taken the 4 centimeters and just done a linear extrapolation, not realizing that it's not a linear function. But
right, and you always, you want to have the physics built in to your understanding of the situation.
I think what I hear the three of you saying is you want to interpret that which is very complex and not well understood in the light of that which is really simple and well understood. And how can we build a case for a young universe or an old universe?
The question would be,
you want to do that in using processes that are as straightforward as possible.
Right.
Yeah, the question would be is how many anomalies would make a good case? If you've got, say, 100 good solid arguments over here versus, say, a few over here, that these are all saying it's billions of years old, and this is saying it's younger. Now, I was going to ask you, secondly, are you going to move the young universe, young Earth group towards over 1 million years of existence?
I don't think so.
Yeah. So the fact is that even 1 million years is out there a ways, but with the new data that's in there, that could bring it up to, again, to what, 4 point some billion years old for the Earth? So you've got an open question here, and what I'm saying is that when you're formulating this thing and you're organizing a case for the young universe view, if that's the strongest one, is that a problem?
For me?
Well, I'm just saying if that's one of the strongest points, and we've got all of these anomalies on this anomaly that we don't know, and you're saying that it could be up there even further. I'm saying, does that show the weakness of the case for the young Earth?
I don't think so. I think part of the problem we have is we have, you can count on one hand how many recent creation astronomers there are in the world, how many there have been of late in the world, the amount of time we've spent on it compared to building a billion plus year paradigm. We don't have a creation model of astronomy, a biblical creation, recent creation model of astronomy. We've got our work cut out for us, and we're in our infancy. I think you're demanding or asking that we have a list of 100 evidences, and we're just getting started.
I think you can't just focus on the Earth-Moon,
Yeah,
or
I agree.
the Earth or the solar system.
I agree.
If you want to tie the age of the universe to the age of the Earth, then there are just so many other arguments that have to be attacked. The Earth is unknown to the rest of the universe. It just doesn't matter. It's here sitting doing its own little spinning. I just wanted to add one comment. There is an area of completely new data that's going to come in over the next few years, and that's the study of extrasolar planets and moons. And on this point in particular, it's completely accidental, and you can't repeat it, but you can get many systems showing it. When you have a foreground object around a star when you have a foreground star with a planet, and the planet has a moon, and the whole system passes in front of a distant object, then you get a very complex gravitational lensing effect that will teach you about that moon, about the separation of that Earth-Moon, et cetera, et cetera. So we don't have much data on this problem, but even if you look at the whole solar system, but we are going to have much more over the next 20 or 30 years. And that may teach us how to do the error analysis, the modifications we're talking about, et cetera, et cetera. So it's not like we're just sitting here with nothing to do.
All right. This is terrific stuff, and we're going to take a break. When we come back, we're going to talk about other parts of Danny's argument. One is that the definition of science is changing from what it used to be. And I want to know, have you guys monkeyed with the figures and monkeyed with the definition, or are we still using the same paradigm? And we'll talk about that when we come right back. All right, welcome to our program. We're talking about, does the scientific evidence from astronomy show that the universe is billions of years old or only 6,000 years old? And my guests are Dr. Danny Faulkner, who's professor of astronomy and physics at the University of South Carolina in Lancaster, Dr. Hugh Ross, who received his PhD in astronomy at the University of Toronto, did postdoctoral work on quasars at Caltech, Dr. William Keel, professor of physics and astronomy at the University of Alabama, Dr. Pamela Gay, research professor on the faculty at Southern Illinois University, Edwardsville, and Dr. Donald York, Horace B. Horton professor of astronomy and astrophysics at the University of Chicago. Folks, I am really glad that you are here. And in talking about this question of, is the universe old or is it young? One of the things that Dr. Faulkner brought up in his presentation was the fact he thinks that the definition of science has changed. And in some respects, those, not Danny, but in some of the other respects of young Earth, some of the folks have said that if you have gone to secular universities, you've been brainwashed. And the fact is that your definition of science is changing. And because evolution is the philosophical mindset, that therefore you can't think straight. You can't get your evidence straight. Now, is that basically what you're saying, or am I?
That's a little harsh, a little strong, I think, to put it that way. But I do believe that the definition of science has changed in my lifetime. And the original definition I remember growing up with was it's a study of the natural world using the five senses. But the definition that many people, not everyone, but many people are pushing for now is the search for natural explanations. And it looks like the same definition, but I don't really think that it is. The purpose of that new definition is an exclusive, explicit exclusion of anything non-physical, non-physical or non-natural, that is the spiritual realm. I think it's an explicit attempt to rule any possibility of God intervening at all. And the original definition of science didn't do that. I think I brought that definition up in the context of my discussion with comets, but I think it's a much broader question I'm very keenly interested in. If you exclude anything beyond the physical, beyond the natural world, then if something you encounter comes along that has no physical or natural explanation, then what do? Well, you make one up. And no matter how illogical, how convoluted or improbable that solution or that answer may be, that must be the answer, because the other possibility is something non-physical, non-natural. And in earlier discussions we had, I think a couple of things came up along those lines. One of them is the origin of life. I don't think there's a physical explanation for that, and I think everybody here would agree with that. We believe, whether billions of years or thousands of years, we believe that life was a special creation by God. That's a non-physical, non-natural explanation. The origin of the universe, whether you believe it began in a Big Bang billions of years ago or a more recent special creation as I do, again, it's a non-physical, non-natural event that involves the agency of some non-physical, non-natural cause. We call him God. So those are just two examples of the change that have come here, and I think you have a lot of agreement with me, at least on that point, that I'm very concerned with the directions it's taking, because that's not the way science was practiced for more than 3 centuries.
But Danny, I wonder if it's partly our fault as Christians, in that we've gone on university campuses as Christian apologists and have tended to critique the naturalistic paradigm without providing a positive creation model and inviting them to put it to the test. And I like your definition, Pamela, that the best explanation is that which most comprehensively and the greatest detail explains the record of nature and is most successful in predicting future scientific discoveries. So it reasons to believe, we're convinced that what we have to do is go to the academic community and present a positive case, not a negative argument, but a positive case for a biblical creation model, and then we invite them to critique it. But the standard we're asking is, show us how our model fails to provide a better, more comprehensive explanation, how it is failing to more accurately predict future scientific discoveries. And if it's not, then the supernatural basis of our model should be seriously considered.
And one of the things that's happened is we've gone from what is euphemistically referred to as the leaf collecting phase of science, where you go out and you collect things and you categorize them based strictly on how they look, to a point in time where we're able to look at things from the standpoint of the underlying science. We're realizing that that which is called a rose isn't necessarily a rose because its genome says it's, well, something different. And as we develop techniques that allow us to probe deeper, and as our scientific theories allow us to understand things at a completely different level, science has gone from simply being a matter of observing and based on observing saying that if I observe the same thing again, I'll see the same thing happen, to saying, I've observed this, I understand it, I can make predictions, but those predictions speak to more than only what I've seen so far. Mm-hmm. It's an expanding of our worldview.
But one of the things that I do agree with Danny is that if you hold to naturalism hard enough, there is no evidence that can persuade you. Although I would say the Big Bang is doing a terrific job. Okay? I mean, again, people have struggled to try and show that it's not true every which way, and now I think through multi-universes are doing hypothetical reasoning that's not based on the evidence they do see, to avoid the conclusion that the universe actually had a beginning. Because if it had a start, then you got to say what started it. And that cause has got to be outside of it's got to be a transcendent cause. All right?
If I can jump in a little bit, Danny's point pulls together several things. I mean, the basic, not definition, description of science is conversation with the universe. The interplay between observation, measurement, and hypothesis, and constantly refining our mental picture to match the world. And much of the time, this entails the junior everyday version of naturalism. That is, as you practice astronomy in the observatory or the lab, naturally your first instinct, the most workable thing, is to see how you can interpret what you can see in terms of measurable physical causes. And there's a very easy philosophical transition that a lot of people find very congenial to, from this is how we can play out science in the lab on the small scales, watching what's going on around us, to, and therefore it's such a parsimonious explanation that that's all there is, that I will just shut off definitions beyond that point. And I think you're right to call people on this, because there are sometimes when you see this being brought up at almost a subliminal level, like the famous line in Cosmos, the cosmos is all that ever is or was or will be. Owen Gingerich actually asked the producer about that. He said, it's a ringing endorsement of atheism. He said, we didn't think of it that way. We just thought it sounded good.
And many people who heard that statement from Carl Sagan thought that that was a marvelous scientific statement. And there's not a bit of science in it. It's a philosophical.
It's an assertion.
It's a metaphysical assertion, very clearly. And that's an example of what I'm talking about here. I think that's a kind of an alternate way of the statement, new statement of what science is. It's a search for natural explanations. He's excluded everything beyond that. There is no God is basically what we get it. You get it. I get it. But the producers just say didn't get it at all. That's interesting.
Yes, seemed not to realize that they were making any philosophical statement.
But in terms of the age of the universe, has even the philosophical assumption of naturalism jimmied the figures?
No, because science didn't start with a presupposition as to the age of the universe. The people who were working to try and figure out the idea were consistently being stymied with the fact that the universe was bigger than they wanted it to be. It was older than they wanted it to be. People were struggling with their faith based on what the observations were forcing them to try and understand. This hasn't been an easy conclusion that we've reached as a community. It's actually been a very humbling one, with the realization that it was hubris to think that we could, as Aristotle tried to do, use thought experiments to understand the universe. And we've only been at this game scientifically for 400 years with the advent of the telescope. We've come a long way in those 400 years, but we still have a long way to go. And it's in understanding just how complicated the universe is. It would be so easy to look at a problem and be able to say, God just jimmied it. But how much more fantastic is it to say, look at the precision with which everything fits together, and there was no random going back and fixing of details required.
Would you say, Don, that the origin of the universe and the design of the universe has been something that has stood out to astronomers and all scientists and kind of messed up their worldview?
There's no question that the scientific worldview and the public, more popular view have changed dramatically as we have learned each step where we learn more and more about the universe. The earliest scientists in Britain, which set the stage for the whole world, were Christians, as is well known in the Royal Society and so forth. And I don't think that things have really changed much since then. I disagree with Danny on that. And I'll give a couple of examples. Copernicus didn't really worry about the size of the universe, but when he made the Earth go around the sun and thought it as a pure thought experiment, in fact, the universe expanded by a factor of 5 in linear dimension, a factor of 125 in volume. But he couldn't prove that. In fact, the calculations, what we were talking about, setting errors and so forth, it wasn't a better model necessarily than what Ptolemy had come up with. Time had to pass before there was the possibility of proving that he was right. There was nothing, of course, he wrote his book, I'm sorry, he didn't write his book posthumously. It was published posthumously. But even if he had dared say that during his lifetime, he died in 1543, he wouldn't have had any means of testing that. The question was, as I said, does the Earth move? And there was just no way to answer that question. Okay. Galileo invented the telescope. Used the first telescope for astronomy, had no way to pursue that question. He absolutely was a Copernican. He saw those moons going around Jupiter. He said, aha, the Earth goes around the sun just like those moons go around Jupiter. The Jupiter has no trouble towing its moons around the sun, and everybody agreed at that point that Jupiter went around the sun. And people said, well, how does the Earth tow the moon around? Well, Galileo said, just like Jupiter does, however it does it, and so on. But he actually couldn't prove it. This was still his prejudice. He was a Copernican. He had to keep a little bit quiet about it, and Kepler urged him to be more vocal. He wouldn't do it because there wasn't any evidence. The first evidence really came by accident, and that's a big point I think I want to make. Serendipity has a lot to do about those things that we can actually test. So when you reach a barrier and you don't have any further explanation, you just have to sit, and somebody else has to do the good work. So 1738, 1756, 1838 are the benchmark dates. Each date, a discovery was made which put the Copernican view on a firmer and firmer foundation. By the time the parallax was measured in 1838, everybody believed the Earth was going around the sun, but you still could have not had a discussion like this and proved that the Earth was going around the sun. So that's, 300 years or something like that. And the technology had to develop. You had to have a special telescope. Many great men were involved with making the instruments that finally made that measurement and so forth and so on. There are many examples like this. I have thought several times during this discussion about Kant. Kant said that he was fascinated by two things, to paraphrase, the moral life within and the starry skies above. And he didn't particularly believe in God, I guess, I don't know. But he certainly did pay attention to the astronomers, and he noticed that they were finding fuzzy patches everywhere. And in his mind, it must have taken him 2 minutes, he made the leap. Those fuzzy patches are Milky Way galaxies way, way out in the universe. Yeah. And on that day, in 1754, the whole universe expanded by an enormous factor, 10 with many, many, many zeros after it. Nobody would believe him. And many astronomers spent their lives fascinated by this idea and built into their telescope projects the ability to prove that Kant was right. None of them could prove he was right. And it was 1921, actually in a debate like this, between two astronomers, that finally they convinced each other and then the world that Kant was right. The universe was just enormous. There were galaxies all the way out, billions and billions, as Sagan would say. So there's another example of a brilliant idea. It was purely hypothetical, just like Copernicus was, and it just took time before we accidentally got the ability to make that measurement. Mm-hmm. So I think Danny's separation in his talks of operational and historical science, I don't quite ring with those. It's already been said here. I think you do the research that you're doing. Who knows why we're interested in a certain piece of evidence? Why does a person become a banker or a securities person or whatever? You get into it some way, and then you do your work. You carry it to the end of whatever data you have, and an idea appears. It wasn't your idea. You didn't have it just by sitting on a desert island. You were driven to it, and you can't test it. What do? You try to do better. That's what's happening with the 3-degree background. You may have to just wait and die, and somebody else will do it. But that is part of science. That's why Western science has progressed. And there have been several references to the fact that science is a product of the Protestant European world after 1600. I'm not sure that's supported by the evidence either. The unique thing that arose in the West that made the science and this debate possible and so forth was the two things of having data. You could get data. Kepler got that data and showed that the orbits of planets were ellipses. Newton used that to create a theory. Newton couldn't have done his theory without Kepler's measurements, even though Kepler did them 3/4 of a century before. And on the other hand, Newton couldn't go get new data to prove that he was right. And his theory would have just been speculation. In fact, I'm sure a lot of people laughed at it until these accidental confirmations that came along. So not in other societies, but in Western Europe, this idea of discussion between speculation and evidence, as we've talked about here, evidence, speculation, that confrontation is what leads to the answers that we have today. And we've heard many times during this discussion about that process just continuing.
Yeah. The gathering of evidence, you've gathered evidence. Everybody's got some assumption about how you gather the evidence, store it, and what you do with it, okay? But it seems like regardless of your prejudice, your philosophy, your bias out here, this evidence keeps on talking its own language.
That's right, exactly right.
And the fact is that, Hugh, help me out here in terms of it seems like there is a prejudice to not want to believe the evidence, but the evidence is pulling people, and that seems to be biblical in my estimation. The heavens do declare the glory of God. Their message goes out to the whole world, okay? It doesn't matter where you're at in the world, it's going to talk to you if you're looking at it.
Well, the Bible exhorts us to look at the evidence and to use that evidence to test our assumptions. I mean, I think that's one thing we tried to do in our debate, Danny, is try to look at the assumptions behind the conclusions we were drawing, and then trying to base our arguments on that which is most free of assumption, or where the assumptions can be rigorously put to the test. And that's something science must continually do.
Well, let's go biblical with you two here at this point. And the fact is that you do have these Bible verses, okay? And this data is screaming at us over here, it seems. I'm listening to these scientists that are not Christians talking about the fact that they believe in God, or the design shows that there's got to be a designer. The fact is, how can you say that we shouldn't be looking at the very evidence that Scripture says is screaming at us?
But data itself doesn't mean anything. I mean, you have to interpret the data, and your paradigm, your worldview, your theoretical construct, whatever you have is how you interpret the things.
Well, that's what I want to talk about. Is that true?
See, what you say, of course, is true, but there's another step.
Okay, I agree, but you're giving the example of Copernicus and then Kepler. They were using the same data that the geocentrists used. The geocentrists could explain the data, and the attempt that Kepler had was to explain the data at least as good and maybe better. But the data itself that data, at least planetary positions, didn't convince anyone one way or the other, because people were interpreting the data differently, and they interpreted the data differently because they had a different worldview.
But eventually they got the data that could put the assumptions and the models to the test.
Well, then you left out the discovery of the phases of Venus. That killed the old Ptolemaic model. It pretty well invalidated that. It didn't kill the Taconic model, and that sputtered on for a few more decades.
But then that's an example of data which ruled out paradigms.
Right.
Exactly.
So
the Venus thing seemed to rule out a paradigm. Exactly.
Enough data of sufficiently wide kind sometimes can.
Yeah. The Ptolemaic model had gone on for 15 centuries, the most successful theory in all time, and I got a lot of thoughts about that. Maybe I can come back to at some point, but it finally came up against something it couldn't explain, and that was the phases of Venus. You could not fix the Ptolemaic model to fit that kind of data. But one point I keep seeing here is the fact that we're talking about here with the Ptolemaic or the Copernican model, or with Kant's island universe idea, those are all operational science in the sense that they can be tested in the here and now. If not now, at least maybe in 100 years from now, new telescopes come along. And that's what I mean by operational science, is that at least in theory can be tested now because it's an ongoing event right now. And until new technologies come along to bring data into bear, it's really not even a scientific concept. The Copernican idea really wasn't for a while. Kant's idea certainly wasn't for a while. It was more of a philosophical idea. Then it began to take on the trappings of a scientific idea at some point. That's very different from a historical science, which is getting back to the change in definition of science I was talking about. The examples I gave of evolution and origin of life and origin of the universe, those are past events. Those are not operational things that you can test in the here and now, because as a past event only happened once, won't happen again, I don't think.
But if you believe that physics is the same everywhere in the universe, and you have modern computers, then that changes.
In other words, it's impossible to separate your origin paradigm or your historical science paradigm from your operations science paradigm. They do overlap and they interconnect.
But I think the standards of evidence and the standards of argumentation are very different in the two fields. I get tired of hearing this statement. You've probably heard it too. People equate the disbelief in evolution, biological evolution, with the disbelief in gravity, and that's on par with a non sequitur in the sense that we can test different theories of gravity in the here and now. How do you test past events of evolution or origin of life? I don't think you can do that.
Well, to use a specific example, there's a wonderful modern day example of evolution, and this is called water purification using bacteria. Every city has its own wastewater issues, you might say, its own stuff that needs cleaned up. And they'll actually breed very rapidly through multiple generations of bacteria that will evolve to meet the water purification needs of different cities. So we can today watch evolution in the laboratory environment of your local wastewater treatment center and see evolution happen. And then we can watch through the fossil record and see the evolving change of the leg of a horse as we go through and we see the incremental changes in place. Now, applying this to astronomy, telescopes are time machines. When I look at the sun, I see it as it appeared 8 minutes ago. When I look at Andromeda, I see it as it appeared when Homo sapiens were just starting to evolve on the planet Earth. And as I look back further and further in the universe at things that appeared further and further back in time, I'm able to see the changing structure of our universe and get data from multiple wavelengths, from multiple telescopes that allow me to see each and every step of our changing universe. So I can't recreate the universe. I can't watch it happen twice, but I can watch it happen at every step in the process.
What did the bacteria turn into?
Just a different version of bacteria that weren't identical to the original version.
I just wanted to ask that question.
No, but I think we're on an important point here, because I think, as you know, many of your colleagues have made the claim that there is no scientific witness to the past. But we're all astronomers. We realize our data does come from the past.
We're seeing stuff that took a while to get here. I will grant you that.
Right.
I don't think it's the same thing as what I mean by historical science, something that happened on the Earth, say, a million years ago. It's something akin to it, but I don't think there's an exact equation between the two.
Well, let's move away from the Earth.
Right.
By going a million light years away, we're dipping into the past. Now, you might argue maybe the speed of light is changing, whatever, but
for the sake of argument, we won't debate that right now.
Right, but the whole point is, in astronomy, we have a direct access to past events. So it's not what we're inferring the past, we can actually see the past. Although, as I tell my wife, because we're astronomers, we know nothing about the present. We only know about the past.
We have our narrowness of viewpoint.
Right.
Let's keep on going here, and let's talk about Danny's other objection, and that is comets and the Kuiper Belt and the Oort comet cloud. He's in doubt whether those exist. All right, and also his statement that comets actually show a young universe.
Solar system.
Say that again?
Solar system.
Solar system. All right. And how young was the solar system for yourself, according to that, in terms of comets? Not more than
100 million years, just to pull a rough
100
number.
million years. Yeah. All right. Let's talk about that. Do you agree or disagree?
Okay, to run back so everybody's sort of up with the discussion, people have seen comets coming near the sun, lighting up in our sky throughout recorded history. And early in the 20th century, there were enough that had measured orbits. We see them coming in from way out beyond the known planets. We're wondering, wrestling with, where do these things come from? What are they? And an important advance came with one of the many brilliant things done by Dutch astronomer Jan Oort, noticing that many of the comets, the ones with very long orbits, took thousands of years to round the sun, very long cigar-shaped orbits, spent most of their time very far, many times Pluto's distance. And his conclusion was, this means that there is a roughly spherical, enormous cloud, maybe extending thousands of times Pluto's distance, from which some occasionally dive close to the sun. At that point, there wasn't enough of a picture of the solar system to know where they came from. So the vague idea was that these comets either had their orbits perturbed by passing stars because they're so far from the sun, or they were on paths that were long and looping enough that occasionally one passes near the sun. We see it as a long period comet. Sometimes one of the planet's gravities will trap them. It came to be known as the Oort cloud, and that was, for decades, the working idea of comets, that for some reason there was this vast cloud around the sun. His student, Gerard Kuiper, came along later and realized that there was another category of comets which came, whose orbits took them not so far beyond the orbit of Pluto. Those didn't come from every direction. They were sort of lined up with the planets. So he added the notion that there is a Kuiper belt, or trans-Neptune belt. And after a great deal of wrestling and public hand-wringing, astronomers have realized that, yes, we already knew of an object that was in the Kuiper belt, and we call it Pluto. And by now, there are, I think, several thousand known. They're very faint, they move. What it required was big silicon detectors that you could search a lot of the sky with. So there's one case of an initially hypothetical zone in the solar system that we eventually got clever enough to find. And a lot of pictures of how the solar system took its shape make these two comet clouds different beasts. The Kuiper belt, just outside the zone of the giant planets, would be things that never built up into bigger planets because it was too lonely out there. It was not at all like Darth Vader's asteroid belt. Whereas the Oort cloud consisted of things that, by circumstance, managed to do what we can do with space probes on purpose. The orbits of one of the giant planets flung them out, and following the way gravity works, if you get flung out, you spend most of your time moving very slowly. The problem with the Oort cloud has been these objects are tiny, they're a very long way from the sun. An Oort cloud comet in its native habitat remains undetectable to our present technology. We see these comets only when they are well on their dive to the sun. So it's a slightly uncomfortable thing. We'd like to know more about the Oort cloud and other stars.
Was Danny right then in quoting Sagan, who said many scientific papers are written about the Oort cloud, its properties, its origin, its evolution, yet there's not yet a shred of direct evidence for its existence?
Not anymore. I mean, what we are seeing in the Kuiper belt is two populations of comets and asteroids. There's a serious color difference. And the distinction there is that the Kuiper belt is much more crowded than the Oort cloud. So you're going to get collisional effects and dust creation effects. And it's such that when you look at these colors, you can determine, yes, there must be a bigger, more distant Oort cloud. And one paper actually was able to use the colors of these objects to determine that the Oort cloud wasn't just a sphere. It was a spherical shell, and inside that spherical shell there was a giant disk-like structure. Moreover, we're actually able to see Oort clouds around other stars. Because when you look at a star that's, say, 10, 20 light years away, the Oort cloud type comets that are orbiting about it kind of coalesce in such a way that you get a combined image that is detectable.
But you don't see the individual objects. You're seeing dust.
No, what you do in our solar system is, we are not at a technological point where we can see even a large comet way out at the main radius of the Oort cloud.
That's my point.
The best you can do is find comets coming into their solar system whose orbit has a farthest distance.
And we've known about those for a very long time.
Right. And
in fact, that's what the Oort cloud was trying to explain the existence of.
Right. The subtlety that I think you were getting into is making sure that that's really where they came from, that their orbits have not had time to be perturbed by passing Jupiter and throw them yet farther out. And if I remember, there were a few discoveries, maybe even from Sloan, of comets that were coming in such a direction they hadn't been perturbed, that
that seem to be
At
on
least
their
two.
fall
We'll
from
get
the
the
Oort
reference and put it up for the audience. But there are two that have been heralded in the last year as being truly originated. And you do see them. There's no question about their being there. It's just that it's the numerical change of position that gives you their orbit, which tells you that they originated in the Oort cloud.
What about this statement? If the solar system began with these comets orbiting, okay, we're all talking about the fact is they are orbiting, and now you're talking about where you think they have been in terms of the orbit that you're measuring. But what about this statement? Then after 100 million years, there would be no comets left at all for us to see. So why do we still have comets in a 4.5 billion year old solar
John,
system?
that's assuming there's no source of resupply.
Yeah.
And I think they would agree if there is no source of resupply, then that's a true statement. Their argument would be there is a source of resupply.
Is that what you're saying?
Well, that was his argument in his show, and he just said he thinks that was a hypothesis. It's unproven, and we're saying that as time goes by, chinks are being broken in the armor that it's not proven.
Let me restate it, I guess. My position on the Oort cloud is it's in a position something, as you pointed out, with Kant's island universe idea. And I didn't mean to imply from the statement, I thought I made it clear in my presentation, but maybe I didn't, that there may become a day when the Oort cloud is a testable, directly testable sort of proposition. At this point, I don't see that it is. I think the things that Hugh was referring to were kind of illusions and very indirect at best.
No, there are at least two direct ones now.
All right.
We'll get the reference.
Thank you.
All right. Now, the conclusion of that, though, then, is that a strong or a weak argument for a young or old universe here? A young or old universe? In other words, what's the conclusion to what we're saying? Is it still hypothetical, or is the evidence kind of dragging you toward the direction that maybe it doesn't show a young universe?
Well, I've given in my comments here and earlier the direction that I think the response is. If I were wanting to attack my position or counter my position, I should say, that's the direction I would go. Okay, we're working on that. We're looking for it.
Yeah, I wasn't really even trying to go on the attack. I was just trying to get a summary here of where you guys were going.
I think this is a scenario where when we look at our solar system, we have to say, we do not yet have the technology to say how much material is in the Oort cloud. We have observations indicating there are objects with orbits that are consistent with our theory of the Oort cloud. So it is reasonable to suppose such a thing exists. But without knowing how much material exists in it, how much material originally existed in it, we can't use the existence of comets today as a way to age our solar system at all. Because this is a multi-body dynamics problem, if we have a cloud of debris surrounding our solar system, objects will periodically undergo multi-body interactions, change one another's orbits, fling themselves on suicidal paths towards the sun. But we don't know how dense that cloud of material is. We don't know how frequently these interactions occur. We don't know how much material is out there to continue flinging things in towards the sun. Without knowing those initial parameters, we can say nothing about how long the process has been going on.
I think the history of this whole argument is interesting because, young Earth creationists have been arguing about the comet problem for 30, 40 years. And 30 years ago, they were saying there's no such thing as a Kuiper belt. There's no such thing as an Oort cloud. We developed the technology and found over 1,000 Kuiper belt objects, and it confirmed that our theory of the Kuiper belt that we had 30 years ago was correct. We're now at the point of being able to discover these Oort cloud objects. And moreover, I would argue that there's even evidence for the great age of the Oort cloud because we're actually measuring some colors in these objects that we realize are a sign of erosion that's been going on for billions of years. And that, I think, is giving us some confidence that we're on the right track with our Oort cloud model. And the fact that we're seeing similar phenomena in nearby stars that are solar-like tells us that, this is looking good for our model. It's not finished yet. It's going to take a new kind of technology before we can actually directly detect these Oort cloud objects in the quantities and the sizes that we think. As a matter of fact, I now hear young Earth creationists saying, well, you found the big Kuiper belt objects, but you haven't found the small ones yet. What we have found is a power law. where we see many more smaller Kuiper belt objects and bigger Kuiper belt objects. And the extrapolation looks reasonable given that that's kind of the way bodies in the universe behave anyway. So, but if you ask the point, I'm not going to believe it till you prove the whole model. Well, we're never going to be able to prove the whole model. But look at the trend line. The more we learn, the more compelling the evidence becomes for the Oort cloud model and the Kuiper belt model that was developed 50, 60 years ago.
All right, we're going to take a break. When we come back, then we're going to turn the tables and we're going to look at what did you think of Hugh's arguments in terms of the universe being old. All right, we'll talk about that. Stick with us. Program, we're talking about the questions of the scientific evidence from astronomy so that the universe is billions of years old or just 6,000 years old. My guests are Dr. Danny Faulkner, professor of astronomy and physics at the University of South Carolina, Lancaster, Dr. Hugh Ross, who received his PhD in astronomy at the University of Toronto, Dr. William Keel, professor of physics and astronomy at the University of Alabama, Dr. Pamela Gay, research professor on the faculty at Southern Illinois University, Edwardsville, and Dr. Donald York, Horace B. Horton, professor of astronomy and astrophysics at the University of Chicago. Folks, we're glad that you're here. And in this segment, what we want to talk about is there was a presentation that Dr. Hugh Ross made about the universe being 13.7 billion years old. And we want to talk about what's your professional assessment of that evidence. Does the scientific evidence point that way? And Hugh, I'd like you to pick just 2 of the 8 that you presented and just give me a short summary and then let us bounce off of that. Let's see what the folks think about it.
Right. Well, the 8 that I gave, I would argue, weren't the most compelling evidences, but they're evidences I thought lay people could comprehend. And of those 8, I think probably the 2 easiest to comprehend would be the fact that we live in a universe that has stars, galaxies, and planets. And I think 2 things that we can agree on, both biblically and astronomically, is the universe has a beginning of matter, energy, space, and time. The Bible actually speaks more about the continuous expansion of the universe than the beginning of the universe. And that's something, too, I think we all agree on. As we look at the universe, we can see that it has continuously expanded from this beginning. But if it expands too quickly from that beginning, gas will be dispersed at such a high rate that gravity will never be able to form galaxies, stars, and planets. On the other hand, if you expand it too slowly, then everything collapses into black holes and neutron stars. For life to be possible, it must be a universe that has galaxies, stars, and planets, and you want them appearing at the right time in the history of the cosmic expansion. And the bottom line is, it won't work if the universe is only thousands of years old. You'll never get stars and planets. It won't work if it's quadrillions of years old. You will get the appropriate results that make life possible, namely the existence of galaxies, stars, and planets when it's billions of years old in our current context. I think that's a fairly simple argument to follow. But another one that I think lay people appreciate is radiometric dating. Not that that gives us the most accurate measurement for the age of the universe. We have measurements that are much more accurate, like the Sloan Digital Sky Survey and the cosmic background radiation. But I think lay people can appreciate that when we look at the sun and the Earth, we see that it has no short-lived radiometric elements. There's no Neptunian, there's no plutonium. And if the universe were only thousands of years old, the Earth and Sun were only thousands of years old, we should easily see plutonium and Neptunian. In fact, we can see the relics of plutonium in the elements of the Earth. The xenon stuff we talked about earlier shows us that plutonium at one time was on the face of the Earth, but it's completely missing now. Because it decays in just with a half-life of 88 million years, that means that the Earth must be sufficiently old that all that stuff has disappeared through radiometric dating. Yet at the same time, we can see stars that are young where the plutonium, Neptunian exists, because sometimes young Earth creationists will say none of that stuff was ever present in the first place. Well, we do see it in young stars. We don't see it in the Sun. We don't see it in the Earth. But we do see the long-lived radiometric elements. The uranium and thorium, for example, are still here because they have decay rates of billions of years. and we can measure how much uranium remains on the face of the Earth, and that actually gives us a measure for the age of the Earth. We can do the same thing with the universe through thorium, for example, and get a measure of the age of the universe. It's consistent with our best measurements.
All right, as you folks know, we've had a group of 13 astronomers that have written a statement about the presentations that Hugh and Danny gave answering this question. What does the scientific evidence show about is the universe old or young? And they sent 3 representatives from the group. And this time around, we're going to have ladies first. So Pamela, what is the assessment of the group? And let's talk about your personal assessment in terms of some of the arguments that Hugh has presented in terms of an old universe.
Science is based on people looking at the universe, trying to understand all of the different observables within a single context, and then taking our understanding and putting it out to our peers and saying, poke holes, poke holes, poke holes. As a community around the world of people bringing a multitude of different cultural and ethnic prejudices to the system, we have come to the conclusion that it is an old universe. And the group of us brought to the table as Christians with PhDs working in the field of astronomy. We looked at the data and we see reflected in the cosmic microwave background, reflected in the comets, reflected in so many different things, either a lack of evidence for a young universe or definitive evidence that we have a model of an old universe that works.
Bill, want to add to that?
Okay, in looking at the age of the universe, an important point is it's not like there's one killer argument. There's a whole set of sometimes interlocking, sometimes independent things, all of which make sense in that context. Our understanding of the life cycles of stars leads us to predict how galaxies should look at various times. We see galaxies full of young stars. We see no galaxies that are 30 billion years old. We see light which has been traveling for billions of years. So if that reflects a reality, that pushes us that way. An amazing observation that became possible in the last few years was uranium-thorium dating of stars. Certain stars have clear enough region in their spectra that you can measure how much uranium and thorium they have. It's just blown away. It's only good to 10%, but I'm just so amazed they can do it that I had to do a shout out there. And there's an interlocking set of things that make sense. What stars you see in clusters, when you see white dwarfs, how much white dwarf remnants of dead stars have had a chance to cool over time, which all tie together and make sense in this span of cosmic time that we've just seen no alternative fit for without that.
All right, Don, one Christian to another Christian buddy, okay? What evidence would you suggest that Danny look at to bring him over the line?
Well, I don't think, I think, actually, I don't think it's a very big stretch. Many of the arguments that Danny gave used the term 100 million years. The light cores put it down at 1 million year. There seem to be plenty of evidences where the lower limits must be much bigger than 6,000 years. Moving those lower limits up is possible just by taking the universe as a whole and looking at that which happens everywhere, and then using the light travel time argument. So I think, as Danny very carefully said during his presentation and also here, if you want to start with the data and the existing evidences and calculations based on those evidences, then it's very clear that we have an old universe. If you want to start from a theological perspective and insist on a literal interpretation of the Bible, then you've created by now an ever-growing dichotomy between one set of writings and what people used to talk about, the book of nature, which is what we're talking about here, the way nature is. I don't see how to reconcile the literal view of the Bible, the writings in the Bible, with the standard interpretations that we are constantly refining on the side of science. Now, I also have to say that I've been involved in a number of religious traditions. I'm teaching a course right now on consciousness in the cosmos, and I've traveled in China. I've looked a little bit at Buddhism. I know a little bit about Hindu and so forth, and I know quite a bit about Christian traditions, at least in America, and to the extent they go back to Europe, in Europe. And I think the fact that the Christians themselves, who want to believe the Bible literally, don't agree on so many different passages and so many interpretations, even of themes and concepts and so forth. It's very hard to take Hugh's view, read the whole Bible and consider all the facts together. If you do that, then you can come up with an interpretation which is consistent both with a Bible that has the God as the creator of the universe and the better scientific explanations that we're gradually moving for. But I don't see any bridge between a literal interpretation in the sense that Danny's talked about and a scientific interpretation.
Yeah, let me talk about this word literal, because Hugh would say your view in terms of how you're looking at the words of Hebrew. I mean, we've debated this for 8 hours with other scholars. We had the Hebrew scholars in here, and they were talking about the fact is that it looks like we're talking about two literal views, but only one of them can be correct.
Right.
Okay? Why is the old universe view, day-age view, a literal interpretation of Genesis 1 and 2? And then we'll have Danny, I want you to say why you think that the young earth is a literal interpretation according to the word. So we've got two literal interpretations going here, but we all agree only one of them is going to be correct.
Right. Well, the Hebrew word yom that's translated day in Genesis 1 has 4 different literal definitions. Part of the daylight hours, all the daylight hours, a 24-hour period, or a long but finite period of time. And in biblical Hebrew, the only word you got for a long finite period of time is the word yom. And I find it interesting that it's English language speakers that debate this issue. And I think it's partly because in the English language, we have at least a dozen words for a long period of time, and it's hard for us to appreciate that there's another language where they only have one word that has alternate literal definitions, which is why I often say to audiences, it's not enough to take the Bible literally, we have to take it literally and consistently, something that Don said. You know, if you actually look at all the biblical data, all 66 books of the Bible, all the creation texts in the Bible, and read them consistently, it's compatible with a consistent interpretation of the book of nature, and in particular the astronomical evidence we're talking about.
How many creation passages are there?
Well, we have on our website 27 passages in the Bible that are at least a chapter in length, or at least a good portion of a chapter in length or longer. And there's about 1,500 creation texts in the entire Bible. We also have all those posted on our website. And we're encouraging people, read all the creation data in the Bible first before you draw any conclusion as to which literal interpretation you're going to settle up with.
Give me the literal interpretation of young earth.
The word literal gets thrown around quite a bit. I don't think anybody gives a 100% literal understanding to Scripture. That's a real misnomer and kind of a propagandist approach to literal interpretation of Scripture. Many times people characterize Scripture can have poetic and metaphorical interpretations. The question is, I think when you look at it, it ought to be very clear if it's poetic or metaphorical, particularly in the original language, particularly to the people who wrote it, the people who read it, or for the first few centuries at least, for a few millennia. I'm a little disturbed that we've decided in the last few hundred years, we alone have decided that these are metaphorical or poetic sort of terms. Hugh is correct that I dealt with my presentation that the word yom can mean 4 different things, one of them being a period of time. But what the word yom might mean in isolation has nothing to do with it. It has to do with, in the context, what does it mean? And there are a number of contextual arguments within it that indicates that it is a normal day.
Let's debate 2 of them. Let's pick 2 of them.
One of my favorites is in verse 5, I believe, of Genesis. It says that he separated light from the darkness, and a light he called day, which amounts to a de facto definition of what day means or yom means. And immediately it follows with, and the night dark he called night, and immediately it says, same thought, same paragraph, if you will, the evening and the morning were the first day. I think within the context there, you're using the word yom in 2 very different ways if it means something, if it does have a different meaning. There are others dealing with the numbering of the days, the evening and the morning, indicating a beginning and ending cycle, those sorts of things. And it's not just something in Hebrew, but also something that works in other languages as well. But it's not just looking at the first or second chapter of Genesis account dealing with 6 days, were they normal days or something other than normal days. The question is, where do you fit in various periods of time beyond that? You have genealogies in chapter 5 and 11 and so forth. So it's a bigger picture than just Genesis 1.
Let's take the first 3, and then we'll talk about some more, okay? Let's respond.
Okay, well, Genesis 1:5 is an argument used by young Earth creation, saying that defines a 24-hour period, but you find the identical wording in Zechariah, where it's referring to the day of the Lord, which is a long period of time, not a 24-hour period. So, in that sense, that argument doesn't hold weight.
With the number. In other words,
it's the exact same attachment of the word yom with the way that the number is attached. You find that also in Zechariah, but it's in referring to the day of the Lord rather than a 24-hour period. Danny is right. Often the arguments made if the days are numbered elsewhere in Scripture, they're 24 hours. What you discover is that those 300 plus places where they are numbered are referring to human history, not natural history. Genesis 1 is the only place where they're numbered and they're referring to natural history. Then when you see the evening and morning, the argument is made that I think there's 37 passages where you find the word yom attached to the word evening or morning, and it refers to a 24-hour period outside of Genesis 1. But if we actually look up all those passages, in no case do you see evening and morning attached to the word day. The closest you come is Psalm 51:17, where King David says, I'll worship unto the Lord in the evening and the morning and noontime. But the word day doesn't show up in the text. If you actually look up those other passages, you will find the word day in the same paragraph, but it won't be in the same sentence used with the word evening and morning. And moreover, when the days are numbered outside of Genesis, it's not true. Even with human history, they're always 24-hour periods. Hosea 6:2, it refers to the Jews as a people being without a king for 1 day, a second day, and then they'll have a ruler. And most Bible interpreters look at that as a reference to the diaspora, when the Jews have been without a ruler over their nation for 2,000 years. And so the whole point is you have to put the claims to the test. Actually look up all the Bible passages and see if the claim stands the weight of biblical evidence.
What was the significance of calling the light day?
Well, again, I mean, where we differ, I mean, you heard Danny talking earlier. He believes that the sun, moon, and stars weren't made until day 4. The position we take at reasons to believe is that they were made before the 6 days. They didn't become visible until day 4 from observers on the face of the earth. Genesis 1:2, the Spirit of God is brooding over the surface of the waters of the earth. I believe that's a statement to the point of view from which we're to interpret the 6 days. And I think the real proof of that is Job 38. Job 38 and 39 also take you through the 6 creation days, though it doesn't number them, but it describes the content that you see in Genesis 1. And with reference to day 1, Job 38, 9, and 10 tells us that God blanketed the seas, referring to the waters that cover the surface of the earth, with clouds that blanketed in darkness. So it's telling us it's dark, not because of the lack of the sun, moon, and stars, but because the atmosphere would not let light pass through. So day 1, let there be light. Notice the text doesn't say that God created the light or made the light. It uses the verb haya, let there be. And so this is light coming through the clouds for the first time so that photosynthesis can begin, but not until day 4 do we see the atmosphere becoming transparent so that advanced creatures on day 5 and day 6 can actually use the position of the sun, moon, and stars to regulate their biological clocks.
What do you think, Danny? Why is that not persuasive?
I've talked to people about some of those other passages, and I understand that even where they appear that they're not literal days in those other passages, they may indeed refer to literal days. Now we're talking about Hebrew and things which I'm out of my league on that one. And I don't find your argument about the definition of day in verse 5 as being conclusive. I think we've talked about this many times. We're probably not going to convince one another quickly.
No, but we can let Hebrew scholars settle it. I mean, they're the experts on this. They know the passages.
But you can take someone like Gleason Archer, who once opined in print that he thought that the very clear meaning of the text was a normal 6-day period. But then he immediately says, we know from geology that the world is millions of years old, so we must seek some other sense. Yeah, and so we have an eminent Hebrew scholar here who's very clearly...
Let me jump in, because he was my professor.
All right.
And when I held to the young earth view, kind of growing up and coming through university, when I got to graduate school, Gleason Archer was writing for Billy Graham's Decision magazine. And I walked through the door and I said, what are you doing? He says, well, I'm writing on this passage. And I said, well, he said, what do you believe? And I told him my young earth point of view at that spot. And he says, that's not what the words mean. Okay? And if you look into his Old Testament survey book, that was kind of the standard book that all the seminaries use in terms of going through the Old Testament, and I went through that course with Gleason. He knew something like, a great number of languages. He used to take notes in his teachers' meetings in Hittite. I mean, he was picking up languages left and right. When we would talk about certain lexicons, I remember saying that this is what the lexicon said, and he said, it's wrong. I'll send him a letter, and he did. He corrected the lexicons. So I remember Gleason Archer straightening me out in terms of what he was saying here. That was his interpretation. It was not the geology that brought him to that point of view. In fact, before he ever published it, he held it secretly for 10 years, thinking about it. And there were no scientists even talking about that point of view. And he said it was because of the language that brought him to that position. And he put it in print in a very faint-hearted way and simply said, this is what the words are saying to me. So he came together with this day-age view before Hugh was around or any of the folks
He told me the same thing back in 1990, that he drew this conclusion from the text and had no idea whether or not the science would support his conclusions.
Then how do you explain John, how do you explain the quote that I've referred to? I'm sure you know the quote from Gleason Archer.
Yeah, I think that again, that his language period, that 10 years where he was kind of putting the geology first, while he was thinking about, can I be correct in terms of my interpretation of this language? When he thought about a problem, he really thought about it. I never wanted to argue with him, and nobody else in the department, the Hebrew department, wanted to argue. Nobody in the United States. He was the teacher of all the teachers. And so for him to ruminate on that for a 10-year period of time, and then to write it up in Decision magazine for Billy Graham when it was not the popular view, took a lot of courage on his part. So all I'm saying is I was there when this stuff was going on.
Was he convinced solely by the Hebrew, or was he convinced at least partly from what claims of scientists
Danny,
was?
he told me he developed this day-age view in 1955. And this was long before the geology influenced him or the astronomy influenced him.
But the day-age theory has been around a very long time.
No, but I mean, he drew it from the text. He says, I did it independently. And later on, he was influenced by geology and astronomy. That actually dates all the way back to 1955.
I cannot believe that a well-read man like that was not aware in his youth, before 1955, that geologists and others were arguing for millions of years. I just can't fathom that.
It's not that he wasn't aware. The guy's a Harvard graduate. I mean, you know, he knew so many things and in so many areas. What I'm saying is that when he got to the language, It was the language that persuaded him. And he did not know if science would support his view. He was out there. In a sense, Danny, he was like what you feel you are right now. You're thinking, this is what the language is saying, and I'm out there regardless of what the current theories are. And I'm saying, this is what I saw Gleason Archer when I was a student standing there arguing with him. This was his position, and then he put it into print. So, you know, I'm interested in these words. And again, like I said, we have debated these words, and we brought in another Joe genius, Dr. Walter Kaiser, who went through there and says, we all have to be very careful about what we're saying to the public. And they are very careful, and the Hebrew scholars are saying this is the latitude that these words are allowed and no more. And so this is why I'm bringing it up. And I throw this out for our audience as well. You can look up these words and you can see if this is true and see if this kind of fits into the context. Now, let me ask you both here, what about this two things? Because we believe that God created, and we also believe that God gave us Scripture, and we believe in inerrancy. We hold them both, okay? This is where the old scholars used to talk about the two books, all right? And God is not lying in either one. Our interpretation may be screwed up in both. But what He's given us in both is true. Would you agree with that?
To a point.
What point would you disagree?
Well, I noticed that in Hugh's presentation, he quoted from Article 2 of the Belgic Confession. Mm-hmm. And I found it very interesting that you only quoted the first part of it. It goes on to state, however, God is more clearly revealed and openly shown to us in his holy word, the Bible. Mm-hmm. The point you had quoted was the first part dealing with nature around us. And I think if you take the whole Article 2 of Belgic Confession together,
which I do.
Well, you didn't quote the second part.
Well, it was like a time.
But if you take the whole thing together, it seems to indicate very strongly that the divine word kind of trumps anything you might take from the world. Now, hear me out on this. One passage we all turn to in the Belgic Confession references is Psalm 19. The first 6 verses deal with natural revelation. The next 6 verses deal with the Word of God. And I've been struck for years. It took me years to see this, by the way. What we can learn from the divine word is very specific. It lists a whole list of things there, very specific, very particular. That's because it's a verbal revelation to us. The problem with general revelation is the fact that it's nonverbal. It doesn't have any words. In fact, Psalm 19:2 is it? It says, verse 3 perhaps, where it says, in the King James it says, there is no speech or language where their voice is not heard. But the word where is in italics. It's not in original Hebrew. More modern translations many times delete that, and they also, most commentaries will back this up. They think the actual meaning is there is no speech nor language. Their voice is not heard. Very different meaning there. There are no words. There is no language. And the problem with nonverbal communication is it can be very easily misunderstood. We deal with body language. We deal with facial expressions all the time. And I'm not very good at reading them. I can misread them terribly. And I think that's the problem we have here, is we have this specific word given to us, verbal revelation given to us, and I don't think we should ever take interpretations we take from a nonverbal world around us to trump what is clearly stated in Scripture. And that's my problem I have. That's what I mean by to a point.
Yeah, but I'm not arguing that one trumps the other. I kind of look at the book of nature and the book of Scripture like different disciplines of science, different books of the Bible. I mean, they're clear. I mean, what you see in the Belgic Confession is that the verbal inspiration from Scripture gives us a clearer description of who God is, His plan of salvation, than we get from the book of nature, which I totally endorse. I totally endorse sola scriptura, that the Bible is the only authoritative revelation from God, the only verbal revelation. But one thing that the people who framed the Belgic Confession recognize is authority can only rest in a person. The book of nature is not a person. But you also see in the Belgic Confession the recognition that both books provide a reliable, trustworthy revelation from the one that inspired the Bible and created the universe. So it's not a matter of one trumping the other. It's the fact that they reveal different aspects of what God wants us to understand. To me, it's kind of like debating which is better, the book of Hebrews or the book of Romans. Well, they have different agendas, different purposes. And it's not that one trumps the other, it's that both are giving us a trustworthy, inerrant revelation. And if we really want to get everything that God wants to teach us, we need to integrate. That's why God gave us 66 books. That's why God gave us multiple scientific disciplines, so that by integrating, we can get a sure interpretation of what God wants us to understand. But obviously, there'll be things in, say, Romans that are a lot clearer in revealing things about God's plan of salvation than anything we can get from the book of nature. But likewise, I would recommend that you go to the book of nature, say, to learn about comets, as opposed to going to the book of Romans.
I think this is a very important point, that you have to integrate over our comprehension and also understand the Bible within the context within which it was written. As someone who teaches calculus-based physics, I know it would have been cruel for God to reveal himself through quantum mechanics to people who didn't yet have the concept of zero. And the book of Genesis is a beautiful way of describing our reality to people who didn't yet have quantum mechanics, relativity, algebra even.
And whatever else it is that we don't actually have yet.
Right. It's an ongoing process. And just as when we explain where babies come from to the smallest of children, we don't explain the combining of the DNA from the mother and the father to create children of different colored eyes in one family. We leave out those details when we're talking to children. We were children when Genesis was revealed, and we have the story that a child would be told. But today with science, we're able to continue to see God's mystery revealed in the stars by using the intellects we've been graced with to continue to hear his message.
Yeah, I think the first time that Hugh told me about the expansion of the universe and said there were Bible verses backing that up, I didn't quite believe them, and so I had to look them up, and it kind of blew me away that God would actually describe the stretching out of the heavens.
And that was something that was recognized by Jewish theologians 800 and 1,000 years ago. So it wasn't just 21st century astronomers using hindsight. Long before the Big Bang was discovered by astronomers, theologians were reading this from the biblical text and saying, this is the way the universe must be.
Well, I also like your thought about the fact is the Bible is the only book that talks about God speaking before time. Explain that a little bit for folks that maybe haven't heard that.
Well, it's something I noticed when I was looking at the different religions of the world, trying to decide which one was right, is what you saw on the Eastern face was this idea that space and time were eternal, and God or gods or cosmic forces created within this eternal space and time. But what I saw in the Bible is that space and time don't even exist until God creates the universe. And then you see in Timothy and Titus references to God's activities before the beginning of cosmic time. The hope that we share in Jesus Christ was given to us before the beginning of time. The grace of God that we now experience was put into effect before the beginning of time. So evidently there was cause and effect phenomena going on before even the time dimension of the universe existed.
You know, I can't help but say that I appreciate you two very much, okay? Can I say it again? That you're the only young Earth astronomer that had the courage to step up to the plate and come and debate, okay? And I enjoy the conversation with you every time we have it, all right? And I hope that you enjoy this kind of a conversation together. There are so many spots where you are open in terms of listening to the evidence and trying to bring it into your view and letting it influence your view, and you're open to looking at Scripture, and I appreciate that. And I appreciate all of you folks. Again, I recognize what's going on in the academic world, and the pressures are increasing on our scholars more and more. Folks are hesitant to go public for a variety of reasons on a variety of topics these days. And Jesus Christ is becoming very, very controversial, and the things in the Bible are becoming very, very controversial. It goes all kinds of directions. And you have brought your academic background, and you have brought a wealth of years. I think of the combined amount of information that you guys have poured through over the years, and it is amazing. It overwhelms me. And I know that you could give me 50 footnotes for everything that you're saying, and that this is television where we're asking you for sound bites and give me the conclusion, and you're wondering about what the academic community would say. But I think that people in our audience recognizing this would say, thank you, thank you, thank you for being willing to stick your neck out and to say, this is where I think the hard data is leading us, and it is not conflicting with a biblical worldview. I appreciate that. And Hugh, also I appreciate the fact that you have stuck your neck out in terms of going on campus. I've watched him go into 500 astrophysicists, astronomers that were not Christians and present the same thing he's presenting to us today. And I've been amazed at how you have gracefully done that and the acceptance that you are getting in terms of people across the world. So I guess this is a way of concluding this program and this series of segments that we have done. I wanted to give the scientists a chance to say what they wanted to say, and I wanted the positions to be represented as clearly as we could represent the different presentations, the different positions, and to also show you that in Christ we can have this discussion and it can be ongoing, and hopefully it'll be helpful to you and it'll strengthen you in your faith where you're at. If you're not a Christian, I hope that it will open you up to investigating the claims of the Bible and the claims of Jesus Christ, and show you how science can kind of undergird that which Scripture is saying. So folks, I want to say thank you again for all of you for coming and for your contribution in these programs, and appreciate it very, very much.